Joining us live from NASA's Johnson Space Center in Houston, Texas. We're here today to discuss the upcoming spacewalk on Monday, April the 8th, in which two spacewalkers will continue the work that's been done over the past couple of weeks. On Monday, you can expect to see NASA astronaut Anne McClain step outside of the hatch for her second spacewalk, and she'll be joined by Canadian Space Agency astronaut David Saint-Jacques. These spacewalkers will continue the work on the space station's batteries. As you can see here in the room, we've got an example of the adapter plate, which we'll discuss a little bit more later, and they'll go into some other tasks. But first, let's meet our experts here with us today. First, we have Kenny Todd, with the Operations and Integration Manager for the International Space Station. Next is Rick Henfling, the Flight Director for this EVA. And additionally, we have John Malarski, who is the Spacewalk Lead for Monday. We're going to start out with some comments from each of these participants, but you can prepare your questions for a little bit later in the show. If you're on the phone, please press *1 to indicate that you have a question. And if you notice that your question has been answered, please press *2 to withdraw it. If you're following us online, feel free to use the hashtag AskNASA to submit your question. First, we'll start with Kenny.
Thanks, Leah. Well, good afternoon, everyone. It's great to be here. It's actually really good to have two of these three EVAs in our rearview mirror now. Completely successful. Crew did a fantastic job. We've got lithium-ion batteries up and running in channels 2A and 4A, which again was our goal from the beginning of this set of EVAs. Rick will talk to you about our third EVA and some other, I'll call them kitchen sink type tasks that we've been trying to get done for some time. And we're still making some changes to that EVA, and I'll talk to you a little bit about that. But from a battery perspective, the lithium ions are performing as designed up to this point, with the exception of one single battery that we're having some issue with on channel 4A. That was the first set of batteries that we put in here a couple of weeks ago. Two of the batteries on the channel 4A are working fine. One of them at this point looks to be failed, and we're not anticipating any type of repair action for that particular battery itself. We are, however, we're undertaking a set of robotics and EVA activities to allow us to reinstall two of the nickel hydrogen batteries back in to that slot in that particular string where that lithium-ion battery is currently failed. So during the second of these three EVAs, we put a small task in there to go back to the work site on channel 4A and remove a cable. Once we removed that cable, that allowed us to be able to press ahead with some robotics activities, which are underway this week, actually starting and taking place today and through the rest of the week, to essentially remove the lithium-ion battery that we think has failed and reinstall two of the other nickel hydrogen batteries. So the way the sequence is going to go, in addition to the lithium-ion battery, it looks like that particular string also has another power box failure. It's called a BCDU, a battery charge discharge unit, that interfaces directly with the lithium-ion battery. So we're gonna replace both the lithium-ion battery as well as the BCDU, and those robotic activities are underway as we speak here. But again, that all got kicked off with removing this cable on the second EVA that was installed during the first EVA. So we'll press ahead. We'll install the BCDU today and get that removed and get the new one in place later in the week. We're going to reinstall the first nickel hydrogen battery in that location where the lithium-ion was, and then Rick and his team are going to go out and do an EVA. Take an adapter plate that's in one of the other nickel hydrogen slots and move that adapter plate, freeing that location up, and then after the EVA, we'll take the second nickel hydrogen battery and drop it into that spot. So when you look at channel 4A at its conclusion, it'll have one of the strings will have two of the strings will have a lithium-ion battery, and then the third string will have two nickel hydrogens. So it'll be a mixed configuration. We anticipate that we can run that configuration for quite some time and get us back to our nominal power capability on channel 4A. So we feel really good about where we're going to end up on the backside of these EVAs and robotics activities, and so we're in the process of trying to carry all that out over the next week or 7 or 8 days, and we'll let that work get done. As for the failed components, the BCDU, at this time we're planning on trying to bring it home on SpaceX 17 if we can. That would be our goal. We've got a lot of other things that we're trying to bring home on that particular Dragon, but we're going to do everything we can to get it home here in the spring. It's the first failure of a BCDU, so we're obviously interested in trying to understand what happened to it. We have a lot of these particular boxes on station. They've been extremely robust and have served the program for a very long time. So, you know, the fact that we had one failed is not a total surprise given the amount of time that they've been in use. But again, just trying to understand what might have happened is going to be our next goal. As far as the lithium-ion goes, our best guess right now is to put it on the pallet that came up on, and at some point here in the future we'll dispose of the pallet with the batteries that are on there, and we won't be returning the lithium-ion battery itself. We will in the future fly up an additional lithium-ion battery and install it in that slot, although at this point I can't tell you if it's 3 months away or 6 months away. That's all still very much a part of the discussion. So we'll have to continue to look at all the options to try to get a replacement lithium-ion battery up there. They do exist here on the ground, and so it's just a matter of us getting one ready to fly and finding a slot for it on a vehicle coming up to station. So we'll go have those discussions here in the near term and start to target a recovery for that particular location. Other than that, the crew is doing fantastic on board. We do want to go ahead and get this third EVA done shortly after we finish this triple EVA set. We'll be getting ready for the Northrop Grumman flight, followed a week later by SpaceX Dragon. So by the end of April, we're hoping to have two new visiting vehicles on station, and so we're right in the middle of the throes of it now. But it's been a pretty exciting month so far, and it's still early. So we're looking forward to the next 3 or 4 weeks, and it's a pretty exciting time. So with that, I'll turn it over to Rick, and he can talk about the specifics of what we're going to do on Monday.
Okay, good afternoon, everyone. I'm Rick Henfling, the lead flight director for the Truss Jumpers EVA. That's US Spacewalk number 54. Before we get out and conduct our spacewalk on Monday, we have a few robotic preparation activities that Kenny had mentioned. In summary, we have the removal and replacement of that battery charge discharge unit. And then we also have an activity to remove the failed lithium-ion battery from the integrated electronics assembly. We're going to take it over to the pallet, which was the component that brought up all the batteries on the HTV-7 mission. Once those activities are complete, we will be in a good configuration to have the spacewalkers take an adapter plate that was originally intended for use with the failed lithium-ion battery, and we're going to move it over and stack it on top of another adapter plate, which is currently in use. And the engineers who developed these adapter plates did a great job in providing a design that allows these plates to stack on top of one another for just this type of situation. And this is a task that we didn't originally plan to do on this spacewalk, but as the third EVA in a series of 3, we understood that it was certainly a possibility that we would need to react to some of the issues that were encountered in real time. And so the team has done a tremendous job to be flexible in the planning of this spacewalk, and we'll be ready to go on Monday. As for the crew, preparations are going well. The tool configuration is being done on board today. We have a little bit more tool configuration later in the week. The suits are behaving extraordinarily well. Typically, when you have a series of EVAs, there's a number of suit considerations and items of interest to make sure that we run to ground. But we are doing really well from a suit perspective, and the 2 suits we're going to send outside for use by Ann and David are in great shape. Tomorrow we have a study session to review the procedures, and then if the crew has any questions, we'll have an opportunity to have a conversation with them to clarify any questions they may have. And everything else is proceeding well with the rest of the EVA preparation activities for conducting operations on Monday. At this point, John can discuss the specifics of the tasks that we're going to conduct during EVA 54.
All right, thanks, Rick. I'm John Malarski, the lead spacewalk officer for this EVA. As Rick mentioned and Kenny mentioned, we'll be adding an adapter plate relocate. So the batteries themselves are robotically compatible, but the adapter plates were designed only to interface with EVA crew members. So this is designed a battery.
Hi, everyone. Thank you for joining us live from NASA's Johnson Space Center in Houston, Texas. We're here today to discuss the upcoming spacewalk on Monday, April the 8th, in which two spacewalkers will continue the work that's been done over the past couple of weeks. On Monday, you can expect to see NASA astronaut Ann McClain step outside of the hatch for her second spacewalk, and she'll be joined by Canadian Space Agency astronaut David Saint-Jacques. These spacewalkers will continue the work on the space station's batteries. As you can see here in the room, we've got an example of the adapter plate, which we'll discuss a little bit more later, and they'll go into some other tasks. But first, let's meet our experts here with us today. First, we have Kenny Todd, with the Operations and Integration Manager for the International Space Station. Next is Rick Henfling, the Flight Director for this EVA. And additionally, we have John Malarski, who is the Spacewalk Lead for Monday. We're going to start out with some comments from each of these participants, but you can prepare your questions for a little bit later in the show. If you're on the phone, please press *1 to indicate that you have a question. And if you notice that your question has been answered, please press *2 to withdraw it. If you're following us online, feel free to use the hashtag AskNASA to submit your question. First, we'll start with Kenny.
Thanks, Leah. Well, good afternoon, everyone. It's great to be here. It's actually really good to have two of these three EVAs in our rearview mirror now.
this point, John can discuss the specifics of the tasks that we're going to conduct during EVA 54.
All right, thanks, Rick. I'm John Malowski, the lead spacewalk officer for this EVA. As Rick mentioned and Kenny mentioned, we'll be adding an adapter plate relocate. So the batteries themselves are robotically compatible, but the adapter plates were designed only to interface with EVA crew members. So this is designed, a battery can actually interface right on top of this for storage locations. So the robotics folks will take those batteries off, and we will have the crew actually, they have a hex driver that inserts down into the socket here and actually unscrews this adapter plate, and they will pick it up and relocate and stack it with another adapter plate. They'll also have to restore this cable to its original launch configuration. It was originally linked to the neighboring lithium-ion battery, and then it will go to the stowage configuration. Once the crew has stacked the adapter plate, they'll have cleared the way for the robotics folks to install that nickel hydrogen battery back in place. And then we will pick up with our normally scheduled activities, which we've got a video and animation to show the rest of the activities that are scheduled for this EVA.
US EVA 54 will be conducted by Anne McClain, EV1, in the red stripes, and David Saint-Jacques, EV2. EV1 will lead out of the airlock to the nadir side of the US lab and temp stow the bag. EV2 will be going over the top of the lab. They will meet up at the same work site, but they'll take different paths to deconflict their safety tethers. After going over the top of the lab, EV2 will temp stow the bag on the zenith side of the US laboratory. From here, both will converge on the port side, forward end of the US lab, where they've got a MMOD or micrometeoroid debris shield that they'll release. The crew will work to release that shield and the underlying insulation, then connect the cables underneath. They'll set up their bag with that cable and work to clear the site. They'll remove an electrical connector which will allow them to access that shield, as well as removing a translation aid, known as a gap spanner. Once that's complete, they can access that shield and get underneath to connect an Ethernet cable that will be utilized to route to various parts of the truss for future wireless Ethernet connections. This will spread wireless Ethernet connectivity to payloads on the outside of the International Space Station. EV1 will disconnect a cable, then take the new cable from EV2 and hook it up under the shield. Then they'll replace all the hardware that they previously removed. From there, EV1 will transition to the Node 1 nadir worksite and remove another MMOD shield and route cables for a power upgrade of the space station. These jumpers will be utilized in conjunction with the other ones that EV2 will be routing. This will allow the station to react to external power failures by reconnecting IVA jumpers inside the space station, as opposed to having to spend an EVA to reconfigure the power system. Now, EV2 will work from the zenith side of Node 1, directly above EV1. EV2 has a longer set of jumpers that will run from the forward side of Node 1, routing into the S0 truss through the MLI, where he will temp stow those for EV1 to pick up later. EV2 will wire tie them along handrails to keep them out of the way of any future EVAs. Once finished routing that cable, EV2 will come down and help EV1 secure the micrometeoroid orbital debris shield over the Node 1 nadir worksite. From there, the crew will transition back to the airlock to pick up bags for the next task. EV1 will be heading up to the S0 truss to pick the cable that EV2 had previously left. This is the one just installed through the MLI on the aft side of the truss. EV1 will enter the bay and continue routing it inside of the truss, separating the blue and red cables, The blue cable will transition to the next bay over to the right, while the red cable will be temp stowed on a handrail for installation at a future time. Once those cables are connected, EV1 will exit the truss bay, enter the adjoining bay, and complete the routing of the blue cable. With the connection of the blue cable, that completes one leg of that redundant power path that will enable the Space Station Canadarm2 to utilize redundant power supplies, if needed, in the event of a power failure. At the same time EV1 is connecting those cables, EV2 will have picked up what is known as the Bartolomeo Training Slip-Off Protection and head to the front side of the European Space Agency's Columbus module. These are plugs that are going on into the end of the trunnions. These are the trunnions that were used to hold the module in the Space Shuttle payload bay for its ascent. These plugs will widen the end of the trunnions to help in the installation of the Bartolomeo platform that'll be launched by ESA at a later date. EV2 has installed one and is moving to the outboard worksite to install the second slip-off protection.
Thank you very much to Rick, Kenny, and John for joining us and telling us more about the EVA, the Spacewalk. We are going to now open the floor for questions. So we have media in the room, and we may also have some on the phone line. Just a reminder, if you have a question, press *1 to queue it up. And if you hear that question answered before you get the chance to ask it, press *2 to remove it. We're also online, and you can ask your questions using the hashtag #AskNASA. So we'll start. Does anybody in the room have any questions? Okay. And don't forget to state your name and affiliation before answering your question.
Sure. Hi, Robert Perlman with CollectSpace.com. It was mentioned that the BCDU, this was the first failure of its type, and that you want to bring it down to look at to see why it failed. Do you have any theories as to what the failure might have been?
Not at this point. We really don't. We're not even hazarding a guess at this point. That's why it's important to us to get inside the box, and usually it'll have some signature once we get in there. But no, we basically just saw the output not acting the way we want. So we feel pretty strongly it's failed, and we'll get confirmation when we put the new one in here later this afternoon and start trying to do some work with it. But no indications at this point.
And it was mentioned that the part of the work for this EVA is to provide a redundant power source for the Canadarm2. Just to clarify, so the ARM has not had a backup power source until this point, and was there an event that triggered this idea of why it needs to be added now?
So the ARM does have redundant power sources, and we have increased the capability and the tasks that we are comfortable performing with that ARM. And so if one of the power sources that supplies power to the ARM fails, we now have the opportunity to do a remove and replace using the ARM itself. However, we wouldn't want to operate the ARM in a zero fault tolerant configuration so that we would be susceptible to a failure that would leave us in an ARM configuration that would be unsatisfactory. So by having this redundant power source to protect us in the event of a failure, we can now still perform robotic removal and replacement of various devices on the external part of the station without having to send the crew members on another spacewalk, because there's risks associated with the spacewalk anytime we go outside, and if we can reduce the opportunities of exposing the crew members to those risks, it's beneficial to the ISS program.
Thank you. I'm Mark Carreau with Aviation Week and Space Technology, and I have a couple questions. My first one is, are the lithium-ion and nickel-hydrogen batteries electrically compatible to your satisfaction, working close together? I know you've had them on different sides of the solar array, but I just wonder if the proximity adds any sort of concern.
Not. Are they compatible? Yes. When you take the strings and you look in there, there's a BCDU, if you will, that's interfacing with each string. So there's 3 BCDUs, and there are three essential battery sets on there. So 2 of them are going to be hydrogen. They're going to be working with its own BCDU. Each of the 2 lithium ions will be working with its own BCDU. We're going through the update of our products right now to make sure that our different algorithms understand that we're running in a mixed configuration on this particular channel. And so those product updates are going to get across the finish line right about the same time that we finish these robotic operations. So that's all in work right now. So we understand what needs to happen in order to run in this mixed configuration, and those activities are in work within the ops community, ops and engineering communities.
Okay, thank you. And I had kind of a big picture question. The first 2 spacewalks, you were kind of at one general site, lots of big equipment. This time they seem to be moving around, more hand action. But I just wonder if you could sort of characterize the difference between this particular spacewalk once you're through with the batteries and working around the station as opposed to the battery swap out.
So for this spacewalk, we have a lot of unique work sites, and there's not a whole lot of opportunities to get access to those work sites in the future, and we have a number of future experiments that we are trying to prepare for, and the spacewalk that we're going to conduct Monday is a conglomeration of all those unique work sites that really didn't fit anywhere else, and so we're gonna tackle all of those tasks in one single spacewalk, as opposed to doing a number of shortened spacewalks with only going to one of those work sites.
Hi, Eric Berger with Ars Technica. I realize that things are always subject to change, but I just wonder if you could talk maybe a little bit about future EVAs that you would have planned for this calendar year, if any. I know April you've got the visiting vehicles and other things scheduled for later in the year, but I'm just wondering what other tasks are you hoping to accomplish outside the station this year?
Sure. We have a little later in the year, in the summer time frame, we'll have the new docking assembly that's going to be coming up on one of the SpaceX flights, and that's going to drive an EVA there. Once you get past that, we really are wrestling with the numbers of EVA requirements between now and the end of the year. We have on the HTV 8 vehicle, there will be another external pallet coming up with a set of batteries destined for the outboard channel. And we know those particular EVAs are going to be longer, more difficult, in that there's going to be more of them. In addition to that, we're also considering the AMS repair sometime here before the end of the year. At least we're planning for it. We're working through all the details of hardware deliveries and procedure development and making sure that we can do it. But in terms of our thinking between now and the end of the year, those are 2 pretty major objectives that we're trying to work our way through. And do I think we're going to do all the EVAs for both of those objectives? Probably not, just because we got a lot of science between now and the end of the year that we're trying to get done with some of the vehicles that we have coming up. So I think we've just got to work through the rest of the plan, figure out what makes sense to do this year versus trying to get a more ready time frame to do those maybe sometime after the first of the year. So that's all still in a state of flux. We'll do the IDA here in the spring, and then we'll start to put a little more fidelity on the plan probably summertime when it comes to the spring, or when it comes to the fall and the winter.
Thank you, Mark Carreau from Aviation Week again. I'd like to follow up Eric's question and your comments on the IDA. Is there a requirement to have the second IDA installed as part of any of the qualifications for the commercial crew vehicles, or can you do all of that with one IDA?
Yeah, that's a good point. Yeah, just like we flew the first flight using the Node 2 forward, that's really what we need. But at some point in the future, we're going to want the Node 2 Zenith capability. Once we get up and running and start flying in a standard cadence, it's going to be to our advantage to do it. So, plus we like the redundancy in ports. To be quite frank with you, I mean, it's just it's puts us in the best posture going forward. But in terms of a requirement for certification, no.
Thank you. And before we go to any questions on the phone, if you're watching and you don't know our acronyms, EVA is extravehicular activity, and that is a spacewalk itself. An IDA is an international docking adapter, and we also have the BCDU, the battery charge discharge unit. And John, if you would like to give us just a high-level definition of what that does and why it's important for the batteries.
So the BCDU, the battery charge discharge unit, it's what manages the batteries. So obviously, during the day we have big solar arrays, the power station, but during the nighttime the solar arrays are not drawing or generating power. So we've got the batteries, and the BCDU manages the state of charge of the batteries through that day-night cycle.
Great, thank you so much. We'll go to questions on the phone, starting out with Marcia Dunn with AP.
Hi, can you hear me?
We can.
Great. For Kenny, probably. Given the potential for greater numbers of women on the space station, will you be getting a second medium-sized suit ready in the near future in case the opportunity or need comes up again for a two-woman spacewalk?
Well, right now, Marcia, we don't have it in the work plan to go do that. If we find ourselves needing to get another medium, or one that one of our female spacewalkers needs another medium, and we need two of them, then we'll have to do some work on orbit to make that spacesuit available. We do have an upper torso, which is a medium size. It takes some amount of time to go do that, but yeah, we could absolutely do that if we found ourselves requiring that. If we had no other option than to go swap out the upper torsos, we can certainly go do that. Again, it's not something we do very often, and we take great care when we do it, and we want to make sure that when we have to do it, that we have the ample time to get it checked out.
Just one more follow-up along those lines. Why isn't there two medium-sized suits at the ready all the time? Is it a space issue on the space station where you just can't have so many suits all ready to go? Is it a lack of, I'm just trying to understand. I know it's a time issue to get one ready, but why not just have two mediums and two larges ready at all the time?
Well, again, I think a large part of that is due to reflected in the complement of the crew that we have on board, and what their requirements are. A lot of crew members, they can, what we say, upsize or downsize. They have a primary suit that they fit in, that they train in, but there's also some amount of training that's done in other size suits to see if those suits will work for them. And so that's just a standard way of doing business. And at some point in the future, if we deem that based on the crew complement that it's better to have things sized differently, then we'll certainly try to do that from a strategic standpoint.
And if I may, if I have one more question, is it just a timing issue for the last spacewalk, which should have been Ann and Christina? It wasn't merely you just didn't want to take the time, or were there other things going on, like it might have been posed a danger for the suits being put together at such late notice? I'm just trying to get a handle on how that all unfolded from your point of view.
Yeah, well, in general, we had a request from Ann on orbit directly from the crew member. We try to make decisions relative to all station ops with input from the crew, and in this instance, we had an input that said we should go look at this and look at it carefully. That's what she made that request to the head of the astronaut corps. We all got together and talked about it and talked about the merits of the situation, and in the end, the decision was made that her recommendation to stay with Nick seemed solid. If there would have been a request to go change the HUD or try to resize to a medium, certainly that's something we would have gone and considered, but that wasn't the request. We looked at it hard to see what our options were. This was the second in a set of 3 EVAs. On the backside of this set of EVAs, we have 2 visiting vehicles. And to be quite frank, we're trying to keep as much margin as we can going into this 3rd EVA. You never can tell what's going to happen, and if you can keep the margin out in front of you, then just from an overall program management standpoint, it made better sense. So she offered a solution. We went and looked at it. we like the idea of trying to maintain the margin ahead of the third EVA, and making sure that we're ready to support our visiting vehicles that are coming up shortly after the third EVA. So anyway, when you look at the totality of the picture, and given that this particular recommendation came from her, we looked at it hard, and in the end accepted it.
All right, thank you. Next on the phone, we have Antonia with Florida Today.
Yes, hi, can you hear me?
Yes, thank you.
Great, thanks so much for taking my question. So regarding the spacesuits currently in use, will the space station see new EMUs before the program ends, and if so, when?
Well, in general, these spacesuits, they come up and down over a several-year period. The numbers that we keep on the station aren't going to change. But what we do is we cycle them up and down and put them through a refurbishment cycle. So that's an ongoing process. It'll be going to the end of station.
And so, so NASA has no plans then to update then the current EMUs. So then the next time the new spacesuit comes would be for another mission, not for the ISS.
Well, certainly we are looking and working with the follow-on programs to make sure we understand what their requirements are. Space Station is a perfect test bed for these types of capabilities, specifically spacesuits, and so we're working again with the other programs and the EVA project office to try to look at the future and what is it going to take as we start to move further out into the solar system. So absolutely we'll use Space Station as necessary to try to help prove out any new technologies associated with new spacesuits. And so we're absolutely a player in that. As far as having new suits for the station itself, you know, I don't know of any plans. We've got our standard refurbishment plan for the existing spacesuits, and we'll continue to work with the other programs and as they seek to do their own technology developments in that area.
Thank you. And next up on the phone line, we have Hugo with the Canadian Press.
Thank you. Hi. I just wanted to know, there seems to be a lot of movement around the space station and a lot of little tasks to be done. I wanted to know, how long are they supposed to be out, and is it the average time of a spacewalk?
Yes, so the spacewalk is planned for 6 hours and 30 minutes in duration. That's the nominal timeline that we plan our spacewalks to. And so while it may seem like there's a number of unique tasks as part of this spacewalk, they all fit within the normal 6 hours and 30-minute timeline that we schedule.
All right, thanks.
All right. We'll take a couple of questions from social media, and if you are watching and following live, you can submit yours using the hashtag AskNASA.
Thanks. We have a question from Reich. He wants to know, how long does the life support resources in the spacesuit last?
Yep, so as Rick mentioned, the nominal spacewalk is 6.5 hours long, and we always try to keep a 30-minute reserve on top of that. So we always try to keep at least 7 hours in the suit. It does depend on how fast and hard the crew is working, though, but we try to keep at least 7 hours for an EVA.
All right, another question on Twitter from Nathan. What do you use to secure the cables to the space station? Cable ties, Velcro, bands?
So we actually utilize wire ties. They're metallic wire ties, so not the plastic cable ties you may use at home, but basically twisty ties, more like you kind of use on a bread bag. So you actually twist those onto a handrail, lay the cable in, and twist it again, and that's what secures along the translation paths.
Thank you. We'll go back to the phone line now. We have a question from Megan with space.com.
Hey, can you hear me?
We've got you.
Great, thanks. Just a quick clarification. I was wondering if you could tell me how many hard upper torso units each size are up there now, and then how many of each of those sizes are set up for spacewalks right now, just so I get the numbers straight.
Yeah. So we've got as far as configured for the spacewalk, we have a single medium spacesuit We've got 2 large spacesuits, and we've got an extra large spacesuit. And then in terms of the spares, we have another medium spare, another extra large spare, and I think another large spare as well.
So we typically try to keep at least 2 of every size suit with the hard upper torso up there that we can change on and off the life support system as needed.
Great, thank you.
And another question on the line from Sean with Spaceflight Insider.
Yes, good afternoon. The question about timing for the EVA was 6 hours, 30 minutes. I'm wondering, can you speak to how much time is required specifically for the battery work, which was ahead of the work you described for the what was originally planned for EVA 3?
Sure. The battery tasks that we have added to this timeline are 1 hour and 30 minutes in duration. Those will be the first tasks that the crew members will execute once they come outside of the airlock. And to accommodate the 1 hour and 30 minutes that we added to this timeline, there were other tasks that were lower priority that we had to defer to a future spacewalk.
Thank you. Follow-up question. If you did make reference to keeping the margin out in front, if there are developments or things off nominal about this work and it requires a 4th EVA, do you have any capacity to execute that before the 2 vehicles arrive later this month?
I think that will depend on exactly the nature of the issue. If we run into a significant problem and it takes our engineering and ops team a little extra time to try to figure it out, we'll buy ourselves some time. I think at this point, yeah, we just have to see what kind of problem we're dealing with. You know, we have the ability to go out on pretty short order, especially when the situation where we're in right now. We do get some efficiencies from a spacewalk standpoint by putting them together like we have here. So if there was something immediate that we had to turn around and go back out the hatch for, and it was that critical, then sure, we could try to do it. And at the end of the day, you know, we can move a vehicle to the right if we have to, if we're looking at trying to save the station or recover some capability or something like that. But in general, a lot of it's going to depend on exactly what type of issue that we're dealing with.
Okay, I think we have another question on social media using the hashtag #AskNASA.
All right, Amin is wondering, what are the risks for this kind of EVA?
So anytime we send the astronauts out to conduct an EVA, there's a risk associated with performing those operations. There's nothing unique that the crew members have not been exposed to as far as training on the ground. Both of our crew members, Anne and David, have had opportunities to perform tasks similar to these while training at the Neutral Buoyancy Laboratory, which is our pool that we use to conduct our spacewalk training. And so we're highly confident in their abilities to execute the tasks on this spacewalk.
Another question on Twitter that is somewhat related. In case of need, how much the repress time of the airlock can be accelerated in order to have the spacewalkers back inside?
In a true emergency, if it's a life-threatening event, I mean, the airlock can be repressed in under 2 minutes. So it's a lot faster than we normally would. There are other implications to doing so, but if it's truly life-threatening, you can do it in under 2 minutes.
Great, thanks. Do we have any more questions in the room?
Just to follow up on the potential AMS spacewalk later this year, when I had talked to him a couple years, Sam Ting mentioned that there would be 4 pumps potentially sent up to station. Is that maybe the hardware you were talking about needing to go up? And what is the status of the cooling system? I think they were down to 2 cooling pumps, one of which was kind of a little flaky. So maybe you could just talk a little bit about the configuration of that instrument now.
Okay. Yes, with regard to the current condition of the AMS, I really would have to tell you to go talk to the AMS project folks. They're continuing to monitor their pump situation. You know, 2 pumps, and you know, they're continuing to evaluate. As far as the EVAs go, yes, they're building a pump package. They're going to deliver that to space station. In addition to that, we have a pretty good number of AMS-specific tools, EVA tools, that have been developed to support some of the the tasks here that are just tasks that quite frankly we just haven't done before, and so they've developed some unique tools, and getting those tools delivered is part of the picture as well. So anyway, those will be hitting the dock here hopefully in the next few months.
And could you maybe just talk a little bit about, because my understanding is that a lot of work has gone into preparing for this fix, in terms of astronaut training time and the special tools you mentioned and the pumps and so forth. Could you just maybe talk philosophically a little bit about how it's important for a station to facilitate this kind of research, or why maybe the program has put so much effort into this?
Well, there's a couple of years ago, I was at a payload ops integration group meeting where we were getting ready for a future increment, and a lot of the new customers that were there, I was trying to give them a feel for how we as the space station community are really wanting to support the science community, and I brought up this particular AMS payload as being one that quite frankly they're threatening to rewrite our physics books, and you know, we as a space station community, as a NASA community, this is something that is near and dear to our heart. And so the research that Dr. Ting is doing and his team and the collaboration, they are very much on the verge of changing the way we think when it comes to particle physics. And so there's a lot of interest in making sure that we continue to collect data and continue to see if we can push our knowledge further when it comes to these type of you know, physics. It's very impressive what that group is doing. So yes, we're spending a lot of effort, we're spending a lot of time to try to do it, but again, in the end, we think it's worth it, and it's certainly something that NASA supports.
Thank you. Okay.
I'm Mark Carreau with Aviation Week and Space Technology, and I think this is for Kenny Todd. Looking at the spacesuits you have now, what's your sort of sense about their utility through 2024 and possibly longer? Can you get there? I think that's my bottom line question with what you got and the kind of work that you do to maintain them on the ground and in orbit.
Sure. I would tell you several years ago we went through what I thought was a pretty significant learning curve after shuttle retired, and we had suits on orbit, and we were doing things on orbit that typically were done on the ground relative to maintenance. And I think we learned some things along the way there. The maintenance activities that we have in play right now on Space Station, I think are about as good as we can get. We understand the situation with water and how to make sure that we don't let water get in places it shouldn't. And I think through the repetition of cleaning suits and taking care of them over this period of years and months, we've seen that the suits are pretty much you know, solid in terms of being ready to go when asked. And so no concerns there. As far as you know, the longevity and what we can expect you know, throughout the program, as long as we're able to continue over certain periods returning these things to the ground, we feel pretty good about our ability to take care of them on orbit and then do the refurbishment at the proper time interval. So I think that we've shown pretty good success in that area. So I don't see anything. You know, I'd have to go talk to the folks that are a little closer to that and understand their sparing situation during refurbishments and all that to see if all that equipment's in place. But I certainly have heard of nothing, Mark, that would tell me that we couldn't continue down this path for a very long time.
We're going to go back to the phone. We have another question from Sean with Spaceflight Insider.
Thank you, Sean Costello. Question: during the video, the summary video, there was reference to some wireless Ethernet capability being installed. I'm wondering, can you speak to any tests that might be performed on orbit or while the EVA is underway in order to validate that that work is done? And second part, what vehicle might first be expected to make use of that wireless Ethernet capability?
So we have the task in our spacewalk coming up on Monday sets the groundwork for the future expansion capability. So we have a cable that we're going to install on Monday that actually has about 8 connections, and that's why we colloquially refer to it as a spider cable. There's 8 special connections that we can then hook up in the future, and we can provide the wireless capability throughout the space station. And as new payloads fly on board and require more and more data throughput, having that wireless expansion capability to support their needs is a crucial element of enabling the success of the space station.
Monday morning, April 8th, for live coverage of the 3rd spacewalk that has taken place over the last few weeks. This is a live feed from the space station's Quest airlock, where astronauts are continuing procedures to prepare themselves and the airlock for today's extravehicular activity, the 216th spacewalk in the history of station assembly and maintenance. Today's spacewalk is scheduled to last approximately 6.5 hours and was planned to begin at 7:05 a.m. Central Time, but the crew is currently running about 30 minutes ahead of schedule and may make it out of the hatch earlier. We're live from Mission Control at NASA's Johnson Space Center in Houston, Texas, where the Orbit 2 team is coming in to take over from the Orbit 1 team, who has been walking the crew through their suit up, pre-breathe, and other spacewalk preparations this morning. Leading the teams today is Flight Director Rick Henfling. He will be in contact with all the flight controllers on the ground throughout today's spacewalk. You can see Rick there in the gray suit on the right of your screen. To his left is Flight Director Zeb Scoville handing over today's procedures. Capcom today is Doug Wheelock. He is on hand to speak with the station astronauts and will hand over communications to the ground IV once the Quest hatch is closed and depressurization is underway. He also serves as today's Capcom for the other astronauts on board the space station. You can see NASA astronauts Nick Hague and Christina Cook maneuvering Canadian Space Agency astronaut David Saint-Jacques into the crew lock area of the Quest airlock. They're currently in the equipment lock, where they've been getting ready for pre-breathe they've been pre-breathing this morning, purging the nitrogen from the astronauts' bodies, preparing them to breathe in the 100% oxygen environment, which they will be immersed in for the next several hours. Already in the crew lock is NASA's McClain. You can see she's wearing red stripes around the legs of her spacesuit. That's designating her as EV1 today. This is McClain's second spacewalk, having only completed her first just a few weeks ago with colleague Nick Hague, you can see on the left of your screen. She's the 13th woman to walk in space and already has 6 hours and 39 minutes of time outside the hatch. Joining her is David Saint-Jacques on what will be his first spacewalk, becoming the 4th Canadian to perform a spacewalk, preceded by Steve McClain, Chris Hadfield, and Dave Williams. As we mentioned, this is the third of 4 spacewalks this year, and several have just taken place in the last couple of weeks. A Russian spacewalk will be conducted on May 29th by Oleg Kononenko and Alexei Evchinin. The current crew on board consists overall of 3 Americans, 1 Canadian, and 2 Russians. We've got the USOS crew in the hatch right now, and as you can see, this is the full crew. To the left is David Saint-Jacques, one of today's spacewalkers, and then joined by NASA astronaut Anne McClain to his right. Cosmonauts Oleg Kononenko and Alexei Evchinin are also on board. To their right is NASA astronaut Nick Hague and NASA astronaut Christina Cook, who both completed a spacewalk just last week. The space station is currently flying over Ghana in West Africa, about 255 statute miles above the Earth. They're currently in an orbital daytime. Throughout the day, we'll see the space station go through periods of both light and darkness as it orbits the Earth, approximately every 90 minutes. We're going to take a look at an animation detailing what the spacewalkers will be working on today, but there have been some changes since its creation, most notably at the beginning. At the start of the spacewalk, McClain and Saint-Jacques will continue the work that has been conducted over the last few weeks on the station's batteries. So far, 6 lithium-ion batteries have been installed to replace 12 nickel-hydrogen batteries. However, one of the lithium-ion batteries installed in the 4A Power Channel's Integrated Electronics Assembly, or IEA, along with the battery charge-discharge unit, was found to not be charging after installation on the March 22nd spacewalk. Today, these spacewalkers will stack an adapter plate on top of another to make room for the nickel-hydrogen batteries to fill its spot, and they'll also secure the new battery charge-discharge unit, or BCDU, that robotics controllers moved into place last Tuesday. Let's take a look at what else the astronauts will accomplish today.
US EVA 54 will be conducted by Anne McClain, EV1, in the red stripes, and David Saint-Jacques, EV2. EV1 will lead out of the airlock to the nadir side of the US lab and temp stow the bag. EV2 will be going over the top of the lab. They will meet up at the same work site, but they'll take different paths to deconflict their safety tethers. After going over the top of the lab, EV2 will temp stow the bag on the zenith side of the US laboratory. From here, both will converge on the port side, forward end of the US lab, where they've got a MMOD or micrometeoroid debris shield that they'll release. The crew will work to release that shield and the underlying insulation, then connect the cables underneath. They'll set up their bag with that cable and work to clear the site. They'll remove an electrical connector which will allow them to access that shield, as well as removing a translation aid, known as a gap spanner. Once that's complete, they can access that shield and get underneath to connect an Ethernet cable that will be utilized to route to various parts of the truss for future wireless Ethernet connections. This will spread wireless Ethernet connectivity to payloads on the outside of the International Space Station. EV1 will disconnect a cable, then take the new cable from EV2 and hook it up under the shield. Then they'll replace all the hardware that they previously removed. From there, EV1 will transition to the Node 1 nadir worksite and remove another MMOD shield and route cables for a power upgrade of the space station. These jumpers will be utilized in conjunction with the other ones that EV2 will be routing. This will allow the station to react to external power failures by reconnecting IVA jumpers inside the space station, as opposed to having to spend an EVA to reconfigure the power system. Now, EV2 will work from the zenith side of Node 1, directly above EV1. EV2 has a longer set of jumpers that will run from the forward side of Node 1 routing into the S0 truss through the MLI, where he will temp stow those for EV1 to pick up later. EV2 will wire tie them along handrails to keep them out of the way of any future EVAs. Once finished routing that cable, EV2 will come down and help EV1 secure the micrometeoroid orbital debris shield over the Node 1 nadir worksite. From there, the crew will transition back to the airlock to pick up bags for the next task. EV1 will be heading up to the S0 truss to pick the cable that EV2 had previously left. This is the one just installed through the MLI on the aft side of the truss. EV1 will enter the bay and continue routing it inside of the truss, separating the blue and red cables. The blue cable will transition to the next bay over to the right, while the red cable will be temp stowed on a handrail for installation at a future time. Once those cables are connected, EV1 will exit the truss bay, enter the adjoining bay, and complete the routing of the blue cable. With the connection of the blue cable, that completes one leg of that redundant power path that will enable the Space Station Canadarm2 to utilize redundant power supplies, if needed, in the event of a power failure. At the same time, EV1 is connecting those cables. EV2 will have picked up what is known as the Bartolomeo Training Slip-Off Protection and head to the front side of the European Space Agency's Columbus module. These are plugs that are going on into the end of the trunnions. These are the trunnions that were used to hold the module in the Space Shuttle payload bay for its ascent. These plugs will widen the end of the trunnions to help in the installation of the Bartolomeo platform that'll be launched by ESA at a later date. EV2 has installed one and is moving to the outboard worksite to install the second slip-off protection.
That's just a look at what the astronauts will be accomplishing today. They also have some time scheduled for some get-aheads and are hoping to get to those as well. You can see the crew is now totally in the crew lock portion of the Quest airlock. NASA astronauts Nick Hague and Christina Cook are still in the equipment lock portion. Throughout the day, we'll be answering questions from social media, so be sure to submit yours with the hashtag AskNASA. Our first question is, what are the measures being taken by the astronauts to avoid decompression syndrome? So far today, the astronauts have participated in a pre-breathe segment to help purge the nitrogen from their bodies. They will be breathing 100% oxygen. Pre-breathing consists of two phases. In the first, the crew breathes that 100% oxygen through a mask to begin purging the nitrogen. And in the second phase, the crew gets into their spacesuits and conducts something called the in-suit light exercise. They move their arms and legs ever so slightly, raising their metabolic rate to help speed up that processing of the excess nitrogen. At the top of your screen, you can see Capcom's Tracy Caldwell-Dyson and Doug Wheelock. These are both NASA astronauts, and they are currently communicating with the astronauts aboard the International Space Station. Behind them is Ground IV Jeanette Epps, another NASA astronaut who will be talking directly to the two spacewalkers as they move throughout their task today, walking them step by step through the spacewalk. Wheelock and Caldwell-Dyson will hand over that communication once the Quest hatch is closed and depressurization begins in the crew lock portion. Flight Director Rick Henfling has just conducted a go, no-go poll for the spacewalk to begin, receiving the green light from all of the flight controllers.
Houston airlock, step 63.5. We removed serial numbers 0004 and 0017.
Copy, Nick. Those are good numbers. Thanks.
We've got some more Ask NASA questions before the crew closes the hatch and begins to depressurize the airlock. The first is dexterity an issue with the thickness of gloves and equipment? It is a little bit of an issue. At nominal pressure, the suit is about 4.3 pounds per square inch. To put that into context, the atmospheric pressure we're used to on Earth's surface is about 14.7 psi. That's also the pressure of the inside of the International Space Station with a mixed oxygen and nitrogen environment, again, much on Earth. The suits are kept at a lower pressure just to allow much more flexibility since the gloves are rigid, and it is a lengthy time working with those gloves, about 6.5 hours scheduled for each spacewalk. The next question is, what's the longest time that astronauts can spend spacewalking? From Emma. The longest single spacewalk actually occurred in 2001. NASA astronauts Jim Voss and Susan Helms spent just under 9 hours. It was about 8 hours and 56 minutes outside of Space Shuttle Discovery during STS-102. They did some maintenance work on the International Space Station, but typically, astronauts' spacewalks can last from 6 to 8 hours, and it really depends on their consumables, how much oxygen they are using, and how much carbon dioxide is being emitted. Astronauts Nick Hague and Christina Cook closing the hatch between the equipment lock section and the crew lock portion of the Quest airlock.
Houston airlock, we are complete with steps 70 and 71.
Copy, Nick. Thank you. Nice work to you and Christina. We are working step 72, and we meet you at the tail end of that step.
Wheels.
Currently in a satellite handover for the International Space Station as it continues to orbit the Earth at 257 statute miles. These temporary losses of communication or video are tracked, and sometimes the schedules are planned. The tasks are scheduled around these losses of communication.
Recording device install. Go ahead, space to ground 2. Hey, Alexei, going back to your question on how to position that device, the device in RO, basically just set it up where prescribed for the radiogram, get everything made it per the radiogram again. We're going to be activating it and testing it once you've done that. And after testing and after we receive the test video file, that video recording device in particular can be shut down, and we'll be working on getting you the answer to your question.
Хорошо, понял. У меня еще вопрос есть по видеорегистратору ISS. Значит, я его направляю направление изображения на люк с грузовиком, и та розетка, которая, значит, указана.
EV1, EV2, and airlock, this is Houston. EV1 and EV2, you're now hot mic on Space to Ground 1. For Nick and Christina, we are complete with step 72 on the ground. You have a go to pick up in step 73.
And copy, Wheels. Okay, David, on the UIA, you're going to check that the depress pump power is off, OFS.
Depress pump power is off, OFS.
That you've got a depress pump enable LED on.
Enable is on.
And Houston airlock, we're looking for your go on step 76.
Airlock Houston, do you have a go in step 76?
Copy, we've got to go. So guys, we're going to move on to the depress Q card.
Copy.
And that was the green light from Mission Control Houston and the astronauts aboard the space station that they are go for depressurization of the airlock.
Switch pump power on, ON.
10 seconds for complete startup. Set for you, David. Set the depress pump man ISO valve to open. Expect alert tone.
Depress pump man ISO valve open.
C. You're both monitoring your suit P gauge. Stays less than 5.5. If it goes greater than 5.5, David, you'll stop the depress.
1 copy. 2 copies.
Depressurization of the crew lock portion of the airlock has begun.
LFP 13, 13.
Copy, David.
LFP 12.
Copy, 12.
LFP 11.
E11 on the pressure. Copy.
The crew lock continues to depressurize. It's currently under 10 psi. Started at 14.7, about what we're used to on Earth. At 5 pounds per square inch, the teams will pause the depressurization for a systems check and then resume it to vacuum.
LFP 9.
Copy, airlock pressure 9.
LFP 8.
Copy, 8 psi on the pressure.
Galaxy 7.
Copy. Airlock pressure is at 7 psi. Note for you all, when the crew lock is at 6 psi, you can expect an alert tone. Then when we're at 5 psi, David, at that time, you'll be putting the depressed pump man ISO valve to close when we reach 5.0.
2 copies.
Christina Cook snapping pictures of the astronauts in the crew lock as depressurization continues.
Galaxy 6.
Copy. 6.0.
Approaching.
Copy. 5.3. And as you're tracking, when you do see 5.0, we'll be taking the depressed pump man ISO valve closed.
Copy. Back me up in case my DCM has toggled to O2 position.
We'll do it. And David, we are seeing 5.0 on our end, so you have a go to take the depressed pump man ISO valve closed.
Depressed pump man ISO valve closed.
Copy. Now for both of you, we're going to be doing an automated leak check. So status until you see leak check question mark displayed, then yes for 2 seconds, and follow the displayed instructions.
EV1 is in leak check. EV2 is in leak check.
Copy. EV1 and 2. Remember, keep us informed of the time remaining.
50 seconds.
Copy. 50 seconds remaining for EV1.
Same for EV2 now, 45.
Be 45 for EV2.
Seconds left for EV2.
Copy. EV2.
EV1 leak check complete. EV2 leak check complete. Setting O2 to EVA.
Copy. Leak check complete on both. And for both of you, checking your O2 actuators in EVA. We copied yours as an EVA for EV1.
It is now an EVA. EV2.
You're now in EVA for EV1.
EV2 moving to EVA.
O2 position, EVA on the DCM. Repeat your last. O2 position, EVA on the DCM.
EV2, O2 position, EVA. Checks EVA on the DCM.
Both of you have your O2 actuator and EVA. Dottie, for you, depress pump man ISO valve can come back open.
Depress pump man ISO valve open.
Copy, and for your awareness, we are now taking the emergency MPEV to open.
Copy. Copy.
Emergency MPEV is open.
Copy. Copy.
Again, monitor your suit pressure gauges stay below 5.5. If not, you'll stop the depress, David.
Copy.
After completing some scheduled system checks at 5 pounds psi, depressurization of the crew lock has resumed and will continue until it is a vacuum.
LRP 4.0.
Copy 4.0.
LRP 3.0.
Copy 3.0. And for your awareness, when we get to 2.0, you will be taking the depress pump man ISO valve to close.
Copy. Point 5, approaching.
Copy 2.5, and we're watching as well.
Point 2.
Copy 2.2. Copy 2.0. David, you're going to take the depress pump man ISO valve closed.
Closed.
Copy closed. Now you will take action to switch depress pump power to off. OFF.
Depress pump power off. OFF.
Copy off. OFF. You now have a go to report your initial tether configuration for egress. We'll be following along, as will the ground.
Okay, we'll start with mine. I have a right waist tether on my D-ring. It is just to my MWS. On my left D-ring extender, I have my safety tether pack. The red hook is gate closed slider lock black on black. My crew reel is unlocked. A yellow hook is gate closed slider lock black on black. That's connected to my anchor reel, which is unlocked. My anchor hook is on my MWS. Also on my left D-ring extender is my waist tether. It is anchored on my left D-ring extender, gate closed slider lock black on black. And the waist tether is connected to EV2's anchor hook, and I have both of those in front of me. They're both gate closed slider lock black on black.
I'll take over from here. My anchor reel is unlocked. It has the yellow hook closed back on black. The crew reel is unlocked, and it is the green hook, which is not locked. That is attached to my right gearing extender, the red hook, gate closed, black on black. And finally, on my left gearing extender, I have a waist tether, gate closed, black on black, attached to the airlock gearing extender, gate closed, black on black. I have an extra waist tether on the right gearing extender, gate closed, black on black, to my main workstation.
And EV1 also has the green hook is on my crew reel unlocked.
EV1 and EV2, Houston copies all. Good config.
Confirmation that David, Saint-Jacques, and McClain have all of the tethers necessary to venture outside, not only to keep them safe and attached to the space station, but also to keep any of the tools and equipment that they'll use attached to themselves.
And for the EVs, for your awareness, we are just waiting for the EV hatch pressure to be visible at less than 0.5 psi, and we'll take that from Anne when the time comes. And you can also expect an alert tone when the crew lock DPDT is near zero.
Copy, and the PSI on the EV hatch is just above 1.
Copy, around 1.0 psi.
E2 copies.
EVs, for your awareness, it does look like we're tracking for a nighttime hatch opening, but it will soon be turning to day after you egress.
Copy. GPS ID reads 1, exactly 1.
See exactly 1.0.
Depressurization continuing. The airlock is now under 1 pound per square inch. As the pressure in the airlock continues to fall, we can expect about 3 or 4 more minutes.
hatch PSID 0.6.
Copy, 0.6.
EV hatch PSID reads 0.5.
0.5 on the EV hatch. You can take the EV hatch open and stow it.
Okay, in work.
And we are still showing you are in a night path, so reminder you can get your helmet lights on if you haven't already.
Okay. 2 copies. Hatch is unlatched.
Copy, unlatched.
Okay, the hatch is open and it is locked.
The hatch is open and locked. We are taking the emergency MPEV to closed.
Copy.
Emergency MPEV is closed, and that concludes the crew lock test. We can move into post-depress, and TC, the test is yours.
Thanks, Christina. You and Nick did a great job getting them ready, and quite early, I might add. Ann and David, you two ready?
Good morning, Tracy. Great to hear from you already.
Good morning, TC. Ready.
Well, it's great to be here with both of you. Let's start with the post-depress step 1. On your DCM, both of you, take your power, switch to BAT, stagger the switch throws, expect a warning tone.
My display switch is functional.
Copy. David, on the UIA, take the switch power EV1, 2 switches to off OFF. Check power EV1, 2 LEDs, 4 of them are off OFF.
Power EV1 off, LED off. Power EV2 off, LED off.
On your DCM, both of you, you can disconnect your SCU. Install the DCM cover and stow your SCU in the pouch.
Work. And if you want to get the H2O is off message.
Time for 82.
Copy, and that's expected.
Copy, and that's expected.
As you heard the reports, depressurization is complete and the thermal cover of the airlock is open.
Copy, Ann.
EV2, SCU is in the pouch.
Copy, David. Okay, David, for you, check the depressed pump man ISOL valve is closed.
This pump man ISOL valve closed.
All right, both of you, on your DCM, Take your temp control valve to max hot.
Mark? You want it max hot?
2 is max hot.
Copy. Take your water switch to on.
EV1, water switch on.
EV2, water switch on.
And my DCM is blank, no bite.
Copy in. David, check DCM blank, bite off.
Blank, bite off.
All right, you guys can set your TCV as desired.
The EV1 set 5.
EV2 set 4.
Spacewalk has officially begun at 6:31 Central Time. That's 11:31 Greenwich Mean Time, the time used aboard the International Space Station, as the astronauts have switched their suits to battery power.
Just under 4.4. It's fluctuating as I move. At 4.3.
EV2, 4.3.
Okay, those are good numbers. Copy 4.3 for both of you. Okay, guys, as Nana said, you guys are coming up on a sunrise, and so you can adjust your visors as you desire.
Okay.
And we're looking at good suit data for you guys, and so whenever you're ready, Ann, you can egress the airlock. I think the hatch already blew open.
Yes, thermal cover is open. And I'm egressing. I think this crew lock bag's going to have to now stay in.
As NASA astronaut Ann McClain, who is EV1, Spacewalker 1 today, with the red stripes on the legs of her suit, exits the Quest airlock, you will hear her communicating with NASA astronaut Tracy Caldwell Dyson as the ground IV.
Copy, Ann.
She will walk the astronauts through today's tasks. As has been mentioned, it is dark outside because the space station is in an orbital nighttime over the South Pacific Ocean. Moving at about 17,000 miles per hour, they will orbit the Earth every 90 minutes, and so they'll be coming up into the sunrise over the coast of Chile.
ET's anchor hook is on the aft D-ring. It closed, fiber lock, black on black.
All right, Ann, we copy. Anytime you're ready, you can give David the go to release his waist tether.
David, you can release your waist tether.
EV2, waist tether release from the airlock wing extender.
And David, first bag that you're going to be passing out to Ann is your crew lock bag number 1, the Node 1 Nader bag.
Work.
And I see that, and let's get in my red for you just a second.
Okay, I'll do a red swap for you. It is routed to your BRT. I'm releasing the large small, airlock large small.
Copy. And I have the bag.
Airlock large small, all hooked on the airlock gearing extender.
And the bag is on my VRT. Valves are out.
Okay, copy, Ann.
I think the idea is actually.
And David, for your IDA bag, I understand you're going to pass that out to Ann, and she's going to temp stow it for you.
Correct.
Let me just grab this hook here, David.
Yep.
Okay, that bag is hooked to the port stanchion inside the circumferential handrail. You can release the from the airlock.
Airlock is released and on the gearing extender.
All right, I'm going to pull this out so it's out of your way. And again, I'm on the forward side. The bag's kind of in the middle.
Okay.
And then whenever you're ready, there you go.
82 egressing.
All right.
Go aft.
Greetings.
Greetings.
Five seconds from a 20-second handover.
TC?
It's closed.
Oh, well done.
Currently in a satellite handover. That was a good look at the Capcoms today. Those are the two astronauts communicating with both David and David Saint-Jacques and Anne McClain as they operate outside the space station.
I understand the thermal cover is closed and you guys are starting your buddy checks?
That's affirmative, Tracy. So I'll go look at David here. I've got a green WBS light. I have two VRT tabs lit. And actually, David, your man ISO valve is partially closed if you'll push your header down. And your HDF handle is down. And I see your safety tethers. They are anchored on the aft D-ring, back on black. Two reels are unlocked. The yellow hook is still locked, and your red hook is still locked on your D-ring extender.
Those are good calls. And on David's suit, did he get his left handle down?
He did indeed, yes.
Okay, check on hand. Green light is on. Fuel this way. Three tabs are up. I'll just switch to the other handle. This side. Yep, both safer handles are down.
Here's my tether.
Tethers.
See my anchor is black on black.
Black on black. Yellow hook is black on black. Green hook is not locked. Red hook is locked. Black on black.
Okay, and I see
your waist tether.
I see two reels unlocked.
And no tangles.
Copy all. I believe we're in a good config.
And we agree. All right, give me a baseline glove and HAP check, starting with Ann.
Okay. And I have a dry HAP, and my gloves are in good condition, no change.
V2, dry HAP, and good gloves. No change.
All right, copy all. I think we're ready, guys. With that, Ann, you have a go to start heading up the Cetus spur to the forward face, heading out port. And David, we can do your translation adaptation. Let me know if you want me to walk you through any of the steps.
Yeah, I will start the translation.
Yeah, go ahead, Tracy. I'll take the steps.
Okay, David, you'll start off with some small translations. Go to the left, to the right, start, stop, and just try to control your motion. You want a firm and trusting hand grip, but you don't have to make it too tight.
Okay.
As McClain heads to the first work site of the day, David Saint-Jacques is getting accustomed to his suit and being outside of the airlock by performing some small movements, as this is his first spacewalk.
Okay, TC.
Okay, next try body yaw and roll. Start it, stop it, see how well you can control it.
Work.
Next try body pitch and just use wrist only and then use moment arm.
And EV1 is on phase 1.
I see you there, Ann. All right, you're going to head to the starboard CETA cart, and then you're going to go south and set up your green hook.
Okay.
Okay, TC.
All right, David, your motor in here. Confirm your local tether is on structure, and then stabilize yourself and then release from the handrail.
I got local tether on structure. Leaving handrail. Okay, Tracy.
Okay, David, that's all we have written down on paper. Anything else you want to try before grabbing that IDA bag?
I think I'm ready to start my slow translation.
Okay, I think we want you to get that IDA bag on your BRT if it isn't already.
Not yet. I'm doing that now.
And EV1 is at the starboard CETA cart.
Copy in. Think you know you're looking for handrail 3651. It's there on phase 6, right below the CETA cart.
You see it.
McClain and Saint-Jacques will begin making their way to the station's P4 truss structure.
Copy.
Okay, TC, I have the idea bag on my BRT. Battles out. It's riveted.
Excellent, David. Now you can translate to lab on the port side to drop off the bag, so let me know when you're on phase 1 and at mile marker 7830.
7830.
Yeah, and that's just above the port strut over the lab.
Strut. Copy. Okay, I'm moving.
David has with him the IDA bag, the IDA bag, that stands for International Docking Adapter. This is a view from his helmet camera. You can see the number 20 down at the bottom as he translates to temporarily stow that bag for later access. He'll then make his way toward NASA astronaut Anne McClain as they prepare the work site for the adapter plate relocation.
Let's see the spirit.
As you can see, this astronauts and the space station are now in an orbital daylight just off the western coast of Chile.
All right, Tracy, my green hook is on 3651.
Copy that. All right, you can start your translation to P4. And as you get closer, I have some cautions to read to you once you get on the IEA. Before you cross the Sarge, you want to check your gauntlets are in place.
It's a live look from NASA astronaut Anne McClain's helmet cam. You can tell by the designation of the number 18 in the lower right-hand corner.
She was on phase 1.
I see you there, Doug.
Report.
Moving under the MT.
Copy.
The astronauts are moving towards the P4 truss structure and the 4A power channels IEA. That stands for Integrated Electronics Assembly. This task was not originally planned for this spacewalk, but following the failure of the battery charge discharge unit and the lithium-ion battery on the March 22nd spacewalk, this timeline was shifted a little bit to incorporate this new work.
And David, you're looking for handrail 0259. I think there you'll find the gap spanner. You'll take port.
And on there, coming down the gas spanner.
David, you're going to take the gap spanner to handrail 0288. It's nadir of the fluid umbilical that you're crossing now.
Okay, I'm at the Sarge, and my gauntlets are in place.
Okay, copy, Ann. So you're going to use the struts to get over to IEA, and you'll fair lead as required on that handrail once you get onto the IEA. That's just outboard of those two whiffs. And I'll read this caution as you go onto the IEA. Do not translate on the inboardmost ORUs there until you've driven the H1 bolts. And do not translate on the AP stanchions.
Copy.
And Tracy, I'm at 0288, working on putting the bag.
Excellent, David.
And I'm at the VCDU. I'm going to get up here in a good position to drive the spool.
Copy, Ann. And is it your plan to take care of those bolts before dropping the crew lock bag?
Affirmative. If that's all right, I'd like to.
Okay, see you there at slot the BCDU. Let me know when you're in place and have your PGT ready. I'll give you settings.
Homework.
And David, let me know if you need any handrails called out.
I think we put the handrail numbers on the straps, so far so good. I want the hinge zenith, right?
You got it. There's also a note here that says you need the bag straps fully extended to reach those handrails.
Copy.
Ground IV Tracy Caldwell Dyson speaking with Anne McClain to work to configure the PGT, or the pistol grip tool, which is sort of like a driver to help secure and detach different bolts aboard the space station.
Stand by. Any stanchion, David?
Copy.
We have the good cow. We have Alpha 7 set, clockwise 2. And I'm ready to drive H1 when you are.
All right, you're reading my mind. Yes, Alpha 7, clockwise 2. You're driving H1, 4 to 5.5 turns to torque. Make sure the socket is fully seated to disengage the ARD.
To prepare this work site today, robotics controllers on the ground removed and replaced the BCDU, that battery charge discharge unit that failed, and replaced it with a new one. And that is what Anne McClain is working on right now by tightening that into place.
And I've got the bag there on 226.
Copy, David, 226.
And David Saint-Jacques confirming he has stowed that IDA bag.
ATC, how am I doing for mid rates?
Checking.
Tracy, on the H1 bolt, I got 9 torque, green light, 5 turns exactly, and the locking indicator moves toward lock. The silver is not over the white line, but it did move toward lock.
Copy, Ann. Those are good numbers. You'll stow your PGT and head south to the battery 5 slot.
Copy.
McClain is now moving to the nickel hydrogen battery slot. This was initially where the lithium-ion battery was located, and it failed, so robotics controllers moved it to the exposed pallet. That failed lithium-ion battery won't be repaired or returned to the ground for further investigation, but the battery charge discharge unit will, hopefully on a future spaceflight, perhaps SpaceX 17.
Copy 0207, and I don't know yet about your met rates, but that bag's looking pretty good.
We'll go ahead and do the 4th strap. I'm sure right there.
Copy, David. Your met rates are looking real good.
Okay, I got the 4th strap down on 0206.
Copy, 0206.
I think I'm complete here.
Okay, David, we're ready for you to head up to the forward face and out port to join Ann, and I'll have you stop to get your green hook anchored underneath the SETA cart.
And Tracy, I have the PGT set up on Alpha 7 clockwise 2 on the H1 volt of the slot 5 battery.
And you're reading my mind. Good config. You're going to drive 4 to 5.5 turns to torque.
Work. Indicators moving. And Tracy, we got 5 turns, 9.2 torque, green light.
Nicely done. All right, you can stow your PGT, and you're going to work on the bag next. Or did you want to work on the bag or get the adjustable off the handrail for the cable?
I'm going to drop the bag, and then we'll see how quick he gets out here. He's going pretty quick, so I might just drop the bag, and then we'll see where he's at.
Good plan.
NTC, I'm up the gap spanner.
Copy, David.
McClain has tightened that battery into place and is going to stow the crew lock bag.
And Ann, you probably memorized the handrails on the IEA, but you're looking for 5128.
Copy, 5128, and I am there.
2 back on phase 1, going forward.
Copy, David.
Take that mile marker again for the green hooks.
You're going to find your handrail just underneath the starboard SETA cart. You're looking for 3652, and you'll see Ann's green hook at the handrail just below it.
Thank you.
Casey, remind me, as I stow this bag, can I just put this adjustable and this cap inside the bag?
I think you want to keep the adjustable on the cap. And you can relocate that tether, that adjustable tether, to the handrail next to 5120. I think it's 5124, but we need to keep that adjustable on the cap.
Okay, so the adjustable will stay on the cap. Do I need to move that if I have enough real estate to tag the bag down?
Yeah, you're good, and you don't have to move it. It's just if it was in your way with the bag.
Yep.
And I'm at the handrail 3652.
Okay, the bag is on 5128, Tracy, with an adjustable.
Okay, copy. And let's see. Once he gets there, you guys are going to be working on the AP cable. We've got you in the procedures working on that together before you get into the APFR, so you might want to get into position.
Okay, and so that AP cable is the one that's attached to this 5128. I believe we're going to be removing this cap and the cap on the AP. Is that correct?
Yeah, and you can do both of those if you'd like.
Okay. And so just to clarify, TC, I can take the cap off of the cable right now?
Yes, you can take the cap off of both the cable and the adapter plate.
Okay, and the AET and the cap that's on the cable is going back in the crew lock bag, is that correct?
The AET with both of the caps will go back into the crew lock bag.
Copy. Okay. Actually, that'll save me. So I'm going to pick up this AET and the cap that's on the table. I'm going to put it on my mini workstation.
In TC, EV2 have my green hook. It goes black on black on 3652. Both reels are unlocked.
Good work, David. Copy. All right, translate port. Make sure your gauntlets are in place before you cross the Sarge. And once you're there, I can give you some vectors in terms of handrails, but you're going to go quite nadir on the Sarge before you cross the struts.
Saint-Jacques now moving on his way to the P4 truss to join Anne McClain.
Continue on phase 1 and then go aft once on the IEA. That's okay.
We're good with that plan.
The astronauts will work together to move the adapter plate. The adapter plate completes the circuit between the lithium-ion batteries to close that circuit and power those up. The adapter plate doesn't have a robotics interface, and so the crew has to move it and stack it on top of the adapter plate in slot 2.
I think the stowage gauntlets in place.
Copy.
All right, the cap is removed from the cable.
Copy, Ann.
And it is on an AET on my mini workstation.
McClain is removing the adapter plate connector cable and will restow it into launch configuration since that adapter plate is no longer being used.
And David, I'm going to read a caution to you, even though I don't think you're going to be close to the P4 radiator, but avoid kick loads and invert in contact with it.
Copy. Reminder.
And David, where are you at? Oh, you're right there.
I'm just next to you now.
Greetings. All right, so the AT, if our tethers are going to stay clear, I'd like to translate back around where you just came from.
Okay, I'm going out of your way.
And watch your right foot. All right, so if I come this way, can you see how my tether's coming? It'll be all right if I skip over you? Okay.
I'm hanging on tight here.
Okay, so I did the bag, I got the cap off of the cable.
Okay.
So the next thing is going to be that J4 cap. And having that cable to connect.
Yep.
All right, I'm going to go get an AT on that ATFR and move it.
Sure. I'm going to put the tail lead here on handrail 5114. Just hold the trouble.
Okay, and I'm going to need your hand for a sec because this is not going in the right direction. See where my tether packs are?
Yeah.
You see where my tether packs are?
Hey, look, better. And,
I think it's, I might just need to turn around.
Yes. They are, yep, you need to do one turn the other way. But if you could also, if you point your legs at me, we'll probably swing out.
Did you pull those?
Yeah.
Thank you.
I'm sorry.
You're right, just to make it
on it. See. Just one leg. Leg. There we go.
Perfect, thanks.
And David, do I understand you're going to put an adjustable fair lead on handrail 5114?
On handrail 5114, yeah. If you concur.
good plan.
The Richmond tether.
TC, I'm headed to the ATFR, I think you overheard. Get the AET on the ingress aid and then move that to with 10.
Copy, Ann. And before you get into the APFR, before you do any other work with the APFR, we do have some TA clamps and other work on the AP.
Yeah, the V's going to work on the app, and then we're going to, I believe we're attaching the cable and then doing those 3 TA clamps.
That's affirmed.
McClain and Caldwell Dyson discussing the APFR. That's the Articulating Portable Foot Restraint. And McClain will use that to have more stability as they work to remove that adapter plate.
You think that's all right? I'll work on the APFR while David works on that, and then we can link up. Is it all right?
It's a good plan, Ann.
Yeah, I have my rich man on this.
Copy.
Copy, David.
Copy, David.
We're going to work on connecting the cable, right?
We're connecting the cable on those 3 TA clamps.
Yes, David, we'll have you connecting the connector to the adapter plate.
Copy. I have the cable. I see right there.
And David, before you connect it, I want all those typical checks of the connector and the plug. Yeah, and David, you'll see the connector cap on the AP, and you'll just read to that and put it on your workstation until you can get back to the crew lock bag.
Okay. Just read to the bail. Okay. That's okay. Ron, did you already take the cap from the cable?
I did. I have it on me.
Okay, perfect.
At TC, we got an AET from the ingress aid to a tow loop, and the ingress aid is locked on black.
Excellent, thank you. And you're going to be relocating the APFR from with 14 to with 10, a clocking of 1.
Clocking 1.
Connector cap is off and routed to my main workstation.
Copy, David.
Forward. There are no pins as this is a dummy. Yeah, my bad.
to the APFR, and I'll be releasing it from West 14.
Copy, Ann.
Made it over center.
Excellent. And I see you working on the TA clamps.
On the TA clamps. Works.
And the roll of Foxtrot is set on APFR. And I also see Romeo Romeo, Yard 12, and I believe you said parking of 1, right?
I did.
McClain has already worked with the battery charge discharge unit today, and as they continue to set up the work site to complete the adapter plate removal, just a recap of what's gone on so far with the robotics operations. So far, 6 lithium-ion batteries have been installed to replace the 12 nickel hydrogen batteries. However, because one of the lithium-ion batteries was not charging along with the battery charge discharge unit, it was removed by robotics controllers last week.
Both of you. And you've got to go to ingress the APFR. And David, when you're back in place to assist with the AP, you can give me a glove and half check.
When that lithium-ion battery was confirmed failed during the successful replacement of the battery charge discharge unit, ground controllers removed that failed battery from the integrated electronics assembly Wednesday morning of last week and installed it on the Japanese HTV external pallet. It will not be returned to Earth for examination. It will burn up upon re-entry into the Earth's atmosphere.
Copy, dry hap, no change on the gloves. David, as you get into position, your next step is going to be to retrieve that PGT and get ready to hand it to Ann, the one with the 9-inch hex.
Okay.
Last week, on Friday night, April 5th, robotics ground controllers continued those battery recovery operations using the station's Canadarm2 and Special Purpose Dexterous Manipulator, or Dexter, to relocate the nickel hydrogen battery from the Integrated Electronics Assembly Slot 6 to Slot 5, where Ann McClain just tightened that into place. That brings us into our current configuration today, a mix of both nickel hydrogen and lithium-ion batteries. And that mix of batteries should be sustainable for the foreseeable future, and eventually a replacement nickel hydrogen battery or a replacement lithium-ion battery will be flown to replace those nickel hydrogen batteries. Ann McClain is now getting in place in that articulating portable foot restraint. As the astronauts get into configuration for their next task, we are going to take an Ask NASA question. You can submit yours on the internet using that hashtag AskNASA. This one comes from Jeffrey, who wants to know what a spacesuit weighs on Earth. On Earth, a spacesuit weighs, give or take, around 315 pounds, depending on the configuration. Each spacesuit has several different parts to help fit the astronauts as best as possible. But of course, once in space, it weighs virtually nothing.
No, you're too high now. Yeah. Feeling bored. And then down. Clock. You look good now. Brilliant.
Nice work, you two. And Don't forget to stow the ingress aid and check that your tethers are clear of that pathway for the AP.
Copy. I see my tethers are clear. Ingress aid is back. I'll recheck that as we bring the AP out. I'm ready for that PGT to beam.
Yep. I'm going to go in place to help send the AP.
Hey, if Ann, you could give us a glove and hat check real quick. I know you got PGT in your hand.
Okay. No worries. Right glove, no change. Left glove, no change to the structure. I do have, you probably see it on my WVS, some of that same black pink stuff that we had last time.
Yeah, we can see it. Just as a black mark.
And I'm just here next to the right shoulder.
And half is dry.
Copy, Ann. You ready for your settings? Oh, wait, let's get a ret on that AP. And we have you, Ann, going to the tether point on the heater mat. And remember, that's a specific orientation for the ret on that spot.
Copy that.
And McClain will use the pistol grip tool to release 2 bolts and free the adapter plate. She'll then transfer that adapter plate to David Saint-Jacques, and he'll tether that to keep it close by.
Hang on to that real quick. Yep. Thanks.
David, while she's doing that, you want to check the PGT settings for her?
I already called it and got Bravo 2 in there.
Oh, okay. Yeah, Bravo 2 counterclockwise too.
Bravo 2, counter 2.
All right, Tuesday, I am redded, and the red is locked out, so it's not imparting any force.
Like you did this before. Yes. All right. Once you get that PGT, you're going to install into H1. Confirm 1 line flush and 8 turns.
Copy. Copy. H1. I have 1 line flush on H1. I'm ready to drive.
Copy. Expect 8 turns.
Driving. Okay, at about 6.5 turns, it started kind of jumping like it was fully released.
Copy. See. And Ann, was it 6.5 or did you drive to 8?
Drove extra, so it started skipping. The first skip was at 6.5, and I just drove just past 8.
Okay, copy. 7 seconds to hand over, get in position for H2.
Copy.
McClain and Tracy Caldwell Dyson confirming that the first of those bolts on the adapter plate has been released. Space station is now in a handover period between satellites, and McClain will take a moment to prepare for the second bolt to be released.
Actually, you know what? I'll just lean back.
All right, guys, I got you back on voice only at the moment. How are we looking, Ann, on H2? We're looking for 1 line flush.
We're working on it right now. There we go. I got one line flush on H2. I have Bravo 2, and a clockwise 2 set.
It's a good config. You're looking.
Yeah, it's mocked out.
All right, you're looking for about 19 turns.
Work. It got turned off, so I'm just redoing a cal real quick.
Copy.
This is a view from Ann McClain's helmet as she uses the pistol grip tool with a hex driver attached to release the second bolt on the adapter plate.
And did the PGT power off? Is that why you got to redo the cal?
All right, cal. It did get powered off. It might have been me when I was flipping the, checking the settings, but it did go off. It did the auto off. But we have a good cal, good LED test. I'm bracking Bravo 2, Honor 2.
All right, good settings.
I'm going to reinsert on H2.
All right, looking for one line flush.
Okay. I have one line flush on H2.
Copy. 19 turns.
Work. If you wouldn't mind putting a hand on it, I could already feel running towards building. 5 turns. Get it. A little bit. There we go. Now it feels good. Yep. See it coming out. Okay, I got the skip right at 18. I believe we are released. Out of here.
Okay, and I copy 18 turns.
And the AP is released. And David, why don't I hold it while you get in a good position?
I'll
with a hand
I'll
off.
move to the other side.
Sounds good. I've got the PGT in the other hand to give you.
Okay, so you guys are transferring the PGT back to David, and I'm looking in the camera. It looks like you guys put one ret on the tether loop to the handle. Is that going to David, or is that you, Ann?
That's to me. So we'll do a ret swap when I hand off.
Okay. You guys are going to rotate the AP 180 from the position it's in there in slot 6, so just keep that in mind with the rets and being able to release those.
Copy, will do.
Caldwell Dyson just mentioned the RET, that's the retractable equipment tether. Astronauts wear several tethers, both for the safety of themselves and also so they can keep their equipment close by when not in use.
Probably pretty good. Here's the PGT. I'm going to let it send back to the bag.
Yep. That's fine. Put a BRT down.
Okay.
BRT to 5128.
Okay. And let me know when you have a red out, and I'll get this AC out.
Yep.
NASA astronaut Anne McClain is now removing that adapter plate. She will transfer that over to David Saint-Jacques.
And
to the DRT.
And we had you guys both reading to the AP, and it'll be your call if you both can fit a ret on that tether loop on the handrail.
Yes, we should be able to.
Excellent.
Right.
Just a sec. There you go.
Before you grab it, I'm holding it for it, and I think you get a good visual on it.
Yep. And move in a better place. Good exit. No far, no bent in. Good.
I'm going to turn it, the handrail facing you.
Okay, guys, I copied the good checks on the AP interfaces.
Yeah, 2 reds on it now.
Yes. No
I'm
problem.
going to put my DRT down, and then I can 2 hands.
No problem. Watch your feet.
I'm ready. And off.
Okay, coming your way.
How are you?
You have it.
And sorry to keep pestering you two, but is the red going to both of you or just to David now?
Just to David.
Copy.
And I'm out of the APSR. Move it to F14, and I think I need to roll it to kilo. Is that correct?
Yes, all the settings are the same, including the clocking, except kilo, the roll.
Okay.
And David, you're in a good position to rotate the AP, or have you already done that?
It needs to go plug house inboard, and that's the way it is.
Yes, electrical connectors will be pointed inboard.
Have I read on APSR?
Copy.
McClain is now moving that APFR, articulating portable foot restraint, into the next position where she will use it to tighten the adapter plate, which is connected to the top of another adapter plate, storing it for potential future use. As the astronauts prepare to install the adapter plate in slot 2, we are going to take another Ask NASA question. You could submit yours using the hashtag AskNASA on Twitter. Augusta wants to know what the astronauts do if they have an itch. It's a good question. There's actually a small bar of foam on the inside of their helmet where they can scratch their nose or itch their nose or even lean in and use that to pop any pressure differences that's in their ears. It's called the Valsalva.
Popping a kilo is set. Correction, roll, sorry.
Yeah, okay, thanks.
Popping of 1 on inward. All right, the APFR is in with 14, a clocking of 1. Black on black. Heuristic pulse test.
Copy. And you said the roll was back in kilo, Romeo, kilo 12 is set. And then check your ingress aid is black on black.
Copy, I will check that when I get to that side.
Guys, we got 20 seconds to a 20-second LOS, and I know you're working on getting in the APFR. I'd like you to also inspect the receptacles in slot 2.
Okay. Ingress aid is black on black if you're still with me, Tracy.
Copy.
All right, how you doing, David? Good. Keep in reach, all right.
I'm back with you guys on voice only.
With you, Tracy. I'm in the APFR. In the receptacles. Okay, EMI band looks intact.
Okay, and make sure your ingress aid is stowed, your tethers are clear.
Okay, tethers are clear, and I think you might have been in the handover what I called the, it is black on black.
I did get it, thank you. All right, and you've inspected the receptacles there, slot 2. It looks like you've got it in place. Nice work.
Yes, tethers are clear, and I'm ready to take it from you, David.
Guys, you got 2 minutes to a night pass.
Okay, thanks.
If I caught on the cable below on the trunnion, yeah, move those cables away. Caught. There we go.
Okay.
Are we at the strobe? You're gonna.
Yeah. Yeah, let me get one of mine on there.
I can move now. I don't need to bear too.
I'm going to release you right back to you, David.
Okay. I'm going to get the TTT.
Copy. All right, your rep's coming back.
Got it.
And you can, all the tethers are clear from what I can tell. Good. And let's get this cable. Cable will have to run on top of these connectors. This is these cables good. Yes. They're gonna clear? I think like that, yes. Yeah, can you see what it looks like down there? Yeah, no, it's clear, yeah.
And
so you can plug it toward your knee. Okay.
It's just a reminder to lock out your ret.
Okay, thanks.
As you can see, the space station is now entering an orbital nighttime over the east of China.
We got to stop that. Fly on the H1 side. All right, ready for that PTT.
And you're going to start at the H2 bolt.
Copy.
David Saint-Jacques hands over the pistol grip tool to NASA astronaut Anne McClain.
And Tracy, I have Alpha 7 clockwise 2 set.
You got it. Confirm one line flush.
She's tightening 2 bolts to secure the adapter plate on top of the adapter plate currently in slot 2. Once a new lithium-ion battery is launched to the space station, this adapter plate will be used to close the circuit and charge the batteries.
Driving 16 to 17 turns, and I'll take all your calls.
The 17 turns, ready to be? All right, ready. All right, we have a caller error. That was my fault. I just bumped it. Can we drive again? Ready? Let's go. Down. True. 8 turns, and it is moving in. All right, Tracy, we got a green light, 9.4 torque after 16.4 turns.
Copy, and good numbers. Ready for H1?
Copy. For H1? On H1. Need that down if you don't mind.
And you know it's same settings, Alpha 7 clockwise 2.
I have Alpha 7 clockwise 2. Lines visible, 1 line flush on H1.
Nice call. Drive 4.5 to 6 turns and report your numbers.
Good work. Okay, we've got 6 turns, 9.1 torque, live.
And repeat the turns. I think you said 6.
Affirmative.
All right, nice job. you guys can release your RET. And Anne, if you've not already, transfer the PGT back to David.
PGT is pivot back to the bag. Can you reach that by any chance?
And while you two are in close proximity, and do you want to transfer the cap that you removed with the adjustable to David so he can put it in the bag?
That is a great idea.
Good idea, yeah.
And just
for this whole adjustable, so I can just clip it onto your head.
Yeah, confirm for me that you have also the adjustable that was connected to that cap and then the handrail, right?
That's correct, yep. And I'm transferring both the cap and the adjustable is now on David.
Both on the main workstation.
Excellent. Okay, in big picture, I think you both know, but Anne, you're going to be working on APFR, and David, you're going to be doing a socket swap on the PGT and doing a cleanup and inventory of the bag.
The adapter plate is now in place, and the astronauts can begin cleaning up their work site. Before moving on to the next work site, the astronauts will perform inventory of the tools that they're using today.
Just so you guys know, I can see you in your WBS trying to follow along, but we're in the dark, so if you guys want to make any calls just to make sure I'm in sync with you, I don't mind.
Okay, I'm just working on getting the for it. Good. To Tango Delta 1 and low profile.
Copy.
And then a BRT for stabilization.
We've got another Ask NASA question from Ninja Turtle. He wants to know how many times the astronauts will orbit the Earth during the spacewalk. The space station moves at about 17,000 miles per hour, so it orbits the Earth once every 90 minutes. So if this spacewalk lasts about 6.5 hours, could go longer or even shorter, the astronauts will rotate the Earth just over 4 times.
EV2 socket swap complete, good full test.
Copy, David. You're going to put that PGT on your swing arm using the external ret from the crew lock bag.
Okay.
We have another question from Tom, who wants to know if the battery won't be repaired or sent back, what will happen to it? It's currently on the exposed pallet on the Japanese HTV-7 vehicle. That vehicle does return to Earth and burns up in the Earth's atmosphere. So it might look like a shooting star, but we probably wouldn't get a view of that from Earth.
David, can you just confirm for me that you also did a pull test on the 2-inch that you put on the PGT?
Yes, good pull test on the 9-inch on the Super Caddy and on the 2 inches now on the PGT.
Excellent. Thank you.
See, I have Tango Delta 1 set on the APFR, and my BRT ret's on it. I'm going to pull it out and get it on my BRT.
Copy, Ann.
At just over 1 hour and 20 minutes into the spacewalk, the astronauts are wrapping up the first of today's tasks.
Affirmative.
Okay, I'll be looking for a glove and hat check from you when you're ready. And before you leave that spot, we would also like you to check slot 6 and look at the receptacles there and make sure you see no FOD or anything anomalous there.
Okay, so that's when we took the AP out of. I checked for FOD, and I checked the receptacles. I also got about 10 or 20 photos of the receptacles and the cooling grid.
All right, you rock. Thank you.
Going to be?
Yeah, I just I'm short on rest, so I have to do a bit of a triangular dance there. Getting there.
Copy.
You don't
as they wrap up this first task. So far, they've worked on the battery channels, just as the last two spacewalks have.
And David, just so it's clear, the RET series that you had to the PGT that you had attached to the bag, we intended for you to break that apart, and one of the RETs would go to the PGT and be stowed on your swing arm, and the other RET would be to the cap that you guys removed from the...
I agree, but I need one free RET to break that. So I've just generated that by getting an adjustable, and I'll recuperate my adjustable later.
While on the P4 truss, the astronauts were working on the integrated electronics assembly. NASA astronaut McClain completed the installation of a battery charge discharge unit by installing one bolt to tighten and secure it to the station, as well as a battery in slot 5. The team moved to demate and then mate an adapter plate from its original slot on top of another adapter plate, where it can then be removed for future use with a lithium-ion battery once delivered to space station. There's not currently a date set for that, but we do have some on Earth ready to go.
The fair lead is still attached.
I'll get to you next. And Ann, I may have missed it, but glove and hat check after you're done with the photos.
Only change on the back of the right glove, some of the white MLI is rubbed off, and there's a metallic that's showing right at the middle knuckle. The left glove has no change. Actually, my left glove does have a change. On the just below the index fingers, where I had the RTB pulled up before, the RTB that is at the base of my finger on the palm side is also now pulled up with a little crack. The Vectran appears unaffected. You see that on my WBS.
Okay, copy that. And we're talking about your right glove. Did you give me your hat?
I have.
Copy.
I'll be ready for the inventory when you're available.
I'm available.
Right. Inside the crew log bag, I have a caddy with a 16 9-inch rigid hex driver, an adjustable with a plug cap, and a ret, a cable cap, cables on an integral, a ratchet wrench with a palm wheel, and a 2-inch on an integral, and a pin puller on an integral. That's for the inside.
Copy all. David, verify for me the socket caddy is on a ret.
Socket caddy is on an integral. Check. On a ret, sorry.
Okay, yeah.
On a ret. On a ret, yeah.
Got it.
Well, that's it for the inside. Outside, The long wire tie. That's to an eyelet. And adjustable.
All right, David, that's a good inventory. Thank you. All right, from you, once you get to your crew lock bag on your BRT, I'll take a glove and hap check.
Saint-Jacques just took some inventory of the contents of the crew lock bag, and both astronauts have performed a glove and hap check. That's HAP, which stands for helmet absorption pad. Astronauts regularly check their gloves for any damage during the spacewalk. And the helmet absorption pad, the astronauts check to ensure nothing inside of the spacesuit is leaking and it remains dry.
Tracy, for your essay, I moved my cooling from 5 to 3.5.
Thank you.
And Tracy, I have the crew bag on my BRT.
Nice work, David. Okay, when you're ready, I'll take a glove and hap check, and then I'd also like you to roll in your TCV and let me know what that setting is.
I have no change on the gloves. And the temperature. That's 5. Move it down to 4.
Okay. David, I copy a good glove and hap check, your change in TCB setting. And for you, and back to your right glove, we would like for you to describe again what you're seeing on the back of your right glove.
Here, they have the 3 vertical seams that go from the finger crotches down to where the flat the palm bars is, and where the intersection of the seam that's in between the middle finger and the ring finger comes kind of down toward that flap, right at that intersection. It's just kind of rubbed off, and I can see white material rubbed off, and then the next layer looks like an aluminum foil type.
Okay, and we copy. That was
no more than about 2 millimeters.
Copy, and I think you were saying 2 millimeters. That's a good description.
Copy.
Okay, it looks like you guys are all ready to head back inboard. David, check for me your fare leads that you set.
Yes, I need to retrieve my fare lead.
Okay, once you have done that, we're going to have you lead back, so you have a go to translate. And then both of you just do a real nice sweep of the work site just to make sure all tethers are with you and not at the IEA. And then we'll have David head out first, picking up his fare lead.
No way.
Yeah. I don't know if it's going to get snagged, but that wire tie that the piece was on is kind of hanging out. size from the TGT on the side of the coolant bag.
Okay. And maybe I could put it inside the coolant bag.
The astronauts are leaving the first work site after completing the first task, removing that adapter plate 6 and stacking it on top of the adapter plate 2. This leaves the integrated electronics assembly in a good configuration, and the nickel hydrogen batteries, which will replace the failed lithium ion battery, will be robotically moved later this week. The astronauts will next make their way to the outside of the U.S. lab to begin cable installation for some additional Ethernet connections outside of the space station.
You see, as I look at my gloves, one small update. At the base of my trigger finger on my left hand, there's actually a little chunk of the RTB missing. A couple millimeters. I don't know if you can see that in my WBS. Again, the Vectrat is affected.
Yeah, and we can't see it. I think we'd have to wait for a day pass to get that kind of resolution. But for missing RTV, we're still good. Yeah, as long as you don't have any damage to the underlying Vectron, you're just fine. And guys, I have a request for the area there around slot 6 where you guys just removed the AP. You guys know the solar array blanket box restraints, those structures that swivel back and forth. We'd like, yeah, if you could, can you stand those up a little bit so they're more vertical and kind of out of the envelope?
Yep, so be doing return with your right hand. And you want them out of the slot 6 envelope? Or 5 envelope, rather?
As much as you can in between, kind of out of the envelope of the PFCS and the slot 5.
Man, I might need your assessment on my safety tether.
I'm on my way. What you got?
It's coming from my shoulder.
Okay. Okay. Got my local.
And David, I know you're working on your fair lead there. Just want to let you both know you're still looking really good on the timeline.
Actually, fairly is retrieved.
I roll over to your left.
Yep, it is. Thank you. So EV2 ready to depart the work site, unless you have more tasks you want me to do.
If you guys like how you left the place, then we are go for you to translate inboard with David leading, and you're going to head to the starboard seat of cart. David, that'll be your first step once you make it back on the forward face, and you'll be picking up your green hook.
Copy.
All right, want to get out of your way, David. Tracy, I adjusted those fabs so they're up as vertical as I can get them.
We appreciate it, Ann. Thank you.
Thank you.
Okay, I get Truss here.
Okay. Get out of your way.
Hey, guys, in 5 minutes, you have the sunlight to look forward to. Just a heads up.
Okay.
She is inboard of the Sarge.
Copy, David.
All right, my safety tether is right there.
You got it. I see it. Thank you.
You are clear.
82's on phase 1.
Going behind him. Gauntlets are covered from the Sarge.
And Ann, I think you know your first stop is going to be at the port seated cart, and we'll have you release the brake handle on the inboard side.
Copy. I'm inboard of the Sarge.
Copy.
You want to do the seat perks? You at my green hook location. Yeah.
Copy, David. And Ann, you'll be pressing that brake release twice to a hard stop on the port inboard seat cart.
Okay, I give it an extra one. It's 3 to a hard stop on the inboard brake.
Overachiever. Okay, Ann, and David's there picking up his green hook.
Okay, I'll kind of hold on the port side. Actually, I can drop the APFR.
Yeah, and you know which whiff?
All right.
You're good.
Hook retrieve. The fields are unlocked.
Copy, David, and you're going to head to the mile marker 7860 to drop off the crew lock bag for Ann.
860.
Hey, Ann, how does the underneath of that MT look?
In what sense?
Does it look like anything like you see in the pool?
It is. You know, the cables are a little more better behaved up here. They tucked in nicely.
I think there's a whole class of ASCANs relieved to hear that.
And I have yet to run into pool structure up here.
But there's no friendly divers to help.
That's the downside.
And the famous words from Doug Wheelock is that it's all the same as the pool except for that big blue planet.
All right, I'm going to leave my green hook while I drop the APFR.
Good plan, and you know this is any clocking.
Any clocking.
In the mile marker for the bag drop.
7860. It's just above that port strut.
Your Capcoms for today, standing up is Tracy Caldwell Dyson, and seated.
7, which keeps the boot plate over the feeder cart. I have a good pull and twist test.
Copy that, Ann. And we'd like it also in Tango Tango Delta 1.
Tango Tango Delta 1 set.
At the bottom of your screen is NASA astronaut Doug Wheelock.
I think you're done with that APFR. You just have your green hook. I want you to hit the brake pedal there on the starboard outboard side.
Starboard outboard, copy.
And Ann, did you grab your adjustable off the ingress aid?
Not yet. Good reminder.
Both Caldwell Dyson and Wheelock have actually performed 3 spacewalks together. That was in August of 2010, fixing a failed fuel pump.
And while you're there, you can give us a black-on-black call on the ingress aid.
Sure thing. I see the ingress aid is black on black.
Copy.
True bag 1, temps code at the mile marker 7860.
Okay, David, we copy. You got the crew log bag at the mile marker, and we're not seeing WVS, so check your button.
Correct, it's not green. WVS will not come on. I'm pushing the button, but the LED does not turn green.
Okay, we copied, David. Hey, David, try it one more time and just make sure that your finger is right in the center of the button.
Sure. I see in my mirror that the button is depressing about a quarter inch as I push. Again.
Yeah, try it one more time.
TC, I've got my adjustable now. Thanks for that reminder.
No choice, TC.
You bet. Okay.
LED.
Okay, copy. Both of you got your adjustable and you've got the brake pedal on the.
Yes.
Okay. And then David, we copy. Try the button twice.
3 times.
Well, David, the good news is that we can see in one of the station cameras, so we got an eye on you.
Right, with the crew bag temps to make my way to the next site.
Yes, and with that, I know, Ann, you're still working on the CETA cart and getting your green hook, but this is where I'm going to hand over the mic to Jeanette, and it's been a real pleasure. You guys are doing a great job. You're doing well on the timeline, and we'll be watching.
Thanks for everything, Tracy. Great working with you this morning.
Thank you, TC. It was nice. Always nice to work with you.
Thanks, guys.
And good morning, Ann and David. This is Jeanette. It's like your second team in the pool.
Has it already been 2 hours?
Exactly. So for you, David, you're going to go out to the lab MMOD shield, the Charlie 201 worksite, and you're going to get there by going later on the port lab struts and then forward.
No, wait.
And Jeanette, I released the CETA brake twice.
Copy that, Ann. You've released the CETA brakes, and you're going to pick up your green.
Team is doing a little bit of troubleshooting on David Saint-Jacques' wireless video system, that's WVS, or his helmet camera, to see if they can get that to reconnect. Meanwhile, McClain is working on the CETA cart, that's CETA, Crew and Equipment Translation Aid.
Go to handrail 0259 and take that gap spanner across.
I'm on the gap spanner as we speak.
Copy, David.
Then I have my green hook. It's reattached to my crew rail.
Copy, Ann. Now you're going to translate to the lab handrail 0251, and that's forward on the port lab strut. Forward of the port lab strut.
Copy.
And as you saw, NASA astronaut Jeanette Epps took over the
0288.
ground IV position, so now she's communicating tasks with the astronauts.
Bag load, and you're going to use the wire tie to restrain it open.
Copy.
Okay, and before you translate out, can we ask you to hit the CETA brakes one more time?
On my way back.
Thanks, Ann.
The port side of it or the starboard side? I hit the starboard side a couple times. Let me just get this, or I hit the port side. You want me to just hit the starboard side?
And we need the starboard side.
Complete.
Copy, we saw that. Thanks, Ann.
Jeanette, the lid is open and we're tied.
Copy that, David. And you can go ahead and grab the long T-handle tool with the adjustable and red and stow it on your mini workstation.
Work.
Jeanette, I think I'm stopping here to do a rich man. Is that right?
Copy that. You're going to install a rich man's air lead.
Jeanette, I have the long T-handle tool and the adjustable on my mirror station using the red that was in the bag.
Okay, copy that, David. You're going to wait till Ann gets to the work site, so stand by. Hey, David, we're looking at some data on the ground, and we have a question for you. Are you using your glove heaters, or have you noticed them turning on and off?
I'm not using them, and they're currently off with us both.
Okay, copy that, David. We think that there may be a connection issue with the Reba battery.
Okay.
Okay, I have a rich man installed at the islet at mile marker 7860. Jeanette.
Copy that, mile marker 7860 for the Fairleys.
Confirm.
Okay, and as you know, you're heading out to the work site. You'll head down the port lab struts and go forward from there.
All right, I'm at 251.
Copy.
I think I take this gap spanner to the left.
That's affirmative.
All right, so I'm not behind you, dude.
Okay, and as you're heading out to the work site, you're heading nadir. I have one reminder warning to avoid inadvertent contact with the SSRMS Lee on the lab PGDF. It'll be near your feet.
I see. Thank you. All right, I'm at 286.
Move. I'll go further forward.
Copy. And you want me to keep going around this gap spanner to 205, right?
That's affirmative. You're going to drop your green hook in on the lab handrail 0205 or a better location if you have it.
Okay.
And David, one, go back if you have it.
204.
Say again, Ann?
Say again.
I'm going to drop on 204.
Copy, your green hook is on 0204. And David, for you, if you haven't already, you can drop your green hook on lab handrail 0268 if you need.
268. On the end cone. We'll do that.
And for you, Ann, next you're going to go to the EWIS antenna. And I have a caution and a warning reminders for you. First, do not use the EWIS antenna as a handhold. And second, there's an EWC antenna boom on the nadir side. It can be a whipping impact hazard if deflected.
Okay. And my green hook is on 204. And I just did that so I didn't have to stop. Or I could potentially come in contact with the arm.
Copy that. And I see that you're near the EWIS antenna, and what you're going to do there is you're going to demate the P1 from the EWIS antenna 11J1.
I am still making my way for 204. So be there in just a sec.
Maybe two green hook on 0268.
Copy Dalit and copy Ann.
What's real on lock?
All right, now I'm right next to you. Anna?
Saint-Jacques and McClain are now at the U.S. lab and are working to get under the MMOD shield. That's the Micrometeoroid Orbital Debris Shield. They'll be demating and mating some cables to provide additional Ethernet to the International Space Station.
This antenna that's on handrail 298, I see the J1 connector. Am I good to disconnect that?
That's affirmative. You're go to disconnect the P1 from the J1.
P1 from J1 is disconnected.
Copy. Could you give me the calls for the FOD, pins, and EMI band?
Just looking at it right now. I see no FOD, get pin, and my band is intact.
Okay, copy. Good calls. And if you can temp stow the cable away from the MMOD shield.
McClain has demated the first cable. This was only necessary to access the work site and will be remated afterward.
And once that's completed, if you need to, you can loosen or remove the gap spanner.
Let's see. Loosen this a bit.
I think we're going to need to,
With this one, you mean the one by your referral? I've loosened it a bit.
Okay, yep. Actually kind of nice as a handhold. You leave it there.
Okay.
Okay, Jeanette, we are ready for the next step, which I think is all tethered.
Okay, copy that. And before you do that, can you check your WVS? We've lost your signal as well as David's now.
Okay, my green light's on.
Copy, your green light's on.
And the green light's definitely not coming on.
A good look at the micrometeoroid orbital debris shield from Ann McClain's helmet camera.
Okay, and we now have your WVS signal, and we still do not have David's, but we're going to continue.
Copy.
Okay, next, David, if you can hand Ann the long T-handle tool with the adjustable and ret. And you're going to install that T-handle tool on the center hex socket of the MMOD shield.
Copy. Z can pop it in. There we go.
Okay, it's in. We're good pull test.
Copy, good pull test. And Ann, can you verify that you have a ret from your mini workstation to the T-handle tool?
There's one from David's mini workstation to the T-handle tool.
Copy, it's on David's mini workstation.
That's correct.
Then, Ann, you can take the free hook of the adjustable on the T-handle tool and secure it to handrail 0364 on node 2.
Okay, it doesn't quite reach yet.
Copy.
Even maxed out, it's a few inches short.
Copy and stand by.
Maybe if we clock it differently? Help?
I don't think so.
Really yet.
We're about pretty short.
The astronauts use that T-handle tool just installed into the micrometeoroid orbital debris shield to help remove the shield and also tether it. It can kind of be thought of like a hold point.
Okay, and we see that the adjustable doesn't reach to node 2, so what you can do is leave the long T-handle tool connected to David, the ret connected to David, and then once you get the shield partially open, you should likely be able to reach to that handrail.
Understand. And I've got my VRT on node 2 364 and my end effector on lab 267.
Okay, copy that. So next, Ann, we'd like for you to release the hooks of the long-duration tie-down tethers, the nadir hooks on 0298, and temp stow them on 0279.
Okay.
It goes in to me.
Again?
It's a handrail here.
279, yeah, that's... And Jeanette, you said the handrail is 298 or 297 or 279?
0279, Ann. 0279.
Release 279, copy. Release 279?
You're going to release from handrail 0298, and then temp stow the hooks on 0279.
Got it. Okay.
We need some
I'll
slack
get
again?
these released, and then I'll hand them to you.
We need some slack? Need slack?
Yeah, we're going to need slack.
Okay. Work on that.
I'll get the other one.
Just over 2 hours into today's spacewalk, and the astronauts are releasing some long-duration tie-down tethers that help keep the MMOD shield in place. They're going to lift the shield and mate some cables underneath.
Get some slack. Got enough slack?
Yes. Release.
Got it?
All right, and the other one's released now, too. Okay, both those long duration tie-down tethers are released, and David is connecting them to 279.
Copy that, Ann. So next you can grab the short T-handle tool from your mini workstation.
Work.
See both long duration tie tethers. Good.
All right, I have the short T-handle tool.
And David, one item, can you verify that you're closing the MLI over the buckle as you temp stow the long duration tie downs?
I did, but it's not to close the whole the wire tie. The MLI is closed over the buckle.
Copy that, David. That's a good config. And what you're doing with that short T-handle tool, you're going to verify that the center and nadir Zeus fasteners are released. And you can use the T-handle tool to verify that the Zeus marks are aligned with the L in the lock, the word lock on the shield.
The center one is in line with the L.
Copy that.
And nadir one, also in line with the L.
Copy, center and nadir Zeus fasteners are aligned with the L. So you're going to BRT to that handrail that you were connected to earlier on 0364, and your mini workstation end effector to the lab 0267. And while you're doing that, I have a reminder caution and warning for you. First, the caution, be sure not to put significant force into the shield. Because of the stuck fastener, moderate force can deform the shield and the tab, which could prevent reinstallation. And then the warning is that, just a reminder that the Zeus fastener tings could have sharp edges.
Okay. All right, I think I am all connected. Okay, I am BRT'd and unaffected.
Okay, and I see that you're BRT'd. Now you can go ahead and try to attach that adjustable to the node 2 handrail 0364.
It'll come up and out. like this one's still caught.
Yeah, feels like it, huh? Look under.
That's not allowing it to come up right here.
Wriggling it. Got it.
Okay, and we see that the center Zeus fastener may be a little stuck. So if you can grab the T-handle tool again and try to rotate the Zeus fastener counterclockwise as far as it can go. If it goes a little past the L, that's fine.
Okay. And David's got that tool in his hand. He's working that.
Counterclockwise as far as it can go. Okay. And then clockwise to the line. Okay.
Seem like it got it?
Excellent. With the RT as well.
Okay.
Put this back here.
Yep. It seems like that's released.
Let's see if I can have a look underneath.
Astronauts are troubleshooting a fastener that is stuck in place and prohibiting the release of that MMOD shield.
Released. Okay. Not released.
Okay.
Okay, David and Ann, can you tell me if you see any motion relative to the structure in the center Zeus fastener?
So we think that the center Zeus fastener is still connected.
Copy that. Center fastener is still connected.
This view from McClain's helmet camera shows her using that T-handle tool to try and release the stuck Zeus fastener.
It's catching there.
Look underneath, you can see where it's mated.
Here. Well, I've moved this. You want to try clocking it?
Okay. From here. Down.
There's definitely a connection between that center Zeus fastener and structure.
Yeah, you can see on the bottom, underneath, there's like a little sandwich of plates of metal.
So we're going to see if we can turn it while I kind of wiggle it. I can actually get out of this anyway a little more.
A little bit of bring each other's way.
Yep, hold on, let me back up. I could just pull this.
Keep constant tension and
You know, what we're doing is I'm cycling force up on the panel a little bit. David is trying different clockings of the Zeus fastener, and hopefully it's pretty stuck.
We copy all, and we see the hard work that you're putting in. Stand by, we're talking on the ground.
Is it any better when it's tunnel to the lock, to the all is locked?
Okay, and we see that the Zeus fastener is really stuck, so what we'd like for David to do is go ahead and grab the pry bar and use the small trash bag to cover the Zeus fastener as you pry it open to catch any pieces. And as long as you can cover the area properly, we're good with that on the ground.
Okay.
I need to want to do a square swap on the long T handle.
Sure.
Ground teams are moving on to the next step of the plan to release that stuck Zeus fastener. David will translate to the IDA bag, that's the International Docking Adapter bag, and retrieve the pry bar. The astronauts will use that to hopefully free the micrometeor orbital debris shield so they can access the work site underneath.
You want to grab the pry bar? I'll get my little trash bag ready.
Good.
We copy that in.
Oh, this might be splayed because I can see from the side that the metal is through the plate and it is not connected to the wire. It might just be slightly splayed.
Maybe just with force will.
Yeah.
Copy all, and you were reading our mind. Thanks for the info.
All right, come my trash bag here.
Okay, and David, we're in the crib sheet, so I'm going to read the steps to you as you perform. You grab the pry bar, and I see the trash bag is in place. So first, you want to verify that the Zeus fastener is turned counterclockwise to a hard stop.
And I don't know if it's going to hit a hard stop, Jeanette, because it's just free floating above that wire. Get a good angle, and get out of your way.
Okay, and we copy that. If you can just align the markup with the L.
It is about 10 degrees counterclockwise at the L.
Yeah, past the L.
Okay, and that's good. So you're going to place the bag over the failed Zeus fastener. I have one quick caution to read to you. So the short edge of the pry bar can't reach the Zeus fastener. So we're going to use caution in the next few steps that I give to you so as not to bend the MMOD shield. So next, place the short edge of the pry bar between the panel and the bracket of the Zeus fastener. And you're going to rotate it side to side to see if you can break it free.
It works. Under the panel.
In the panel?
Yeah.
Doesn't reach.
And Ann and David, I have one quick warning to read to you as well. So do not touch the backside of the MMOD shield or the handle fastener. The fragments can be sharp. And then the fastener and shield tool interface must be covered to avoid potential projectiles.
Okay. Got it covered with a trash bag.
Just to be clear, you want the shield, the tool under the shield panel or on the top surface?
David, I'm checking. So, David, we like for you to put the pry bar under the panel and then rotate it.
Right, that's where we have it. Between the panel and the bracket.
That's a good callback.
I'm trying to go as far as deeply in as I can. Of course. Movement. I feel some movement.
Yeah. A little further.
Want to try it from your hand?
Yep. Okay.
All right. Limited by the handrail.
Yeah.
You try the other side from your edge of the handrail?
Sure.
Astronauts are still working with the pry bar now to free a stuck fastener on the micrometeor micrometeoroid orbital debris shield. Once that shield is lifted, the goal is to install a spider cable and mate that underneath the shield.
Not want to move, does it?
No, it does not. Try locating the piece a little bit.
The T-handle right here. Kind of maybe do it simul?
Yeah, let's try that. Or we got to keep the bag on when we put force.
Yeah. And gently.
About thing, keep your hand on the tool. Go anywhere.
Just
try again with my phone.
Can, yeah. Seems like you got some movement at the beginning there, but
it's hard to get something, yeah.
You can see the Earth in the background as the astronauts are 257 statute miles above Germany.
Nice.
Got it. And the juice fastener is still kept.
Awesome work, guys. Awesome work.
All right, where were we? I'm going to get my trash bag back on my MWS here.
I'll go put the pry bar back in the bag.
Okay.
Okay, guys, as you're cleaning that up, can you tell us what method you used to get that panel open?
What were we doing at the end? We had the T-bar playing with the clocking, and the Z has a pry bar kind of cycling force on it.
We're having a handover, 20-second handover.
Astronauts David Saint-Jacques and Anne McClain celebrating with a high five after freeing the stuck Dezus fastener from the micrometeoroid orbital debris shield. We're in a temporary satellite handover. Once we return, they will lift that shield and tether it, and then start removing the multi-layer insulation.
Okay, guys, we're back up with you via voice only right now. Shortly, we'll have video. So if you can give us the method that you use to get that panel open.
It's a combination of wiggling the T-handle tool and to change the clocking. At the same time that you use the pry bar underneath, kind of just cycle force on the connector, and then it came out. I'm looking underneath, it does look slightly splayed, not very much so.
Okay, all good information, Ann. Thank you so much.
The trick was, as we were applying more force on the pry bar, we're sneaking it in further and further in with more leverage. And I don't know, maybe we felt altogether like 3 discrete moments where we made progress.
Okay, great, David. Thanks for the info as well. And I see that you're getting that adjustable from the long T-handle tool onto the new 2 handrail.
Firm. You have to pull up a little bit. You might be imparting a little force. Actually, I think it's stuck on where the antenna connects down there. I need to go in and up.
And you may need to swing the MMOD shield out to disengage the 2 nadir tabs on the inner side of the shield.
Copy. Yeah, we need to get above the antenna first.
Want to do the corner there? I'll do the pulling. Better located. Sure. There you go. Also put 2 adjustables. Sorry? We also put the second adjustable in series. Good. It's not really going back. Yeah, you can tell there's kind of marks from the previous time where you have to lower it a little bit. Yep. I think too. You're going to get it. We go. Get it. All right. And the red is on. Excellent.
Okay, that was great teamwork, guys.
Okay, finishing.
Okay, that was great teamwork, guys.
It's cinched. All right. About as high as it will go. And I think we're going to release this Nader MLI. Is that right, Jeanette?
That's correct. You're only going to release the Nader MLI Zeus fastener and the center and Zeus fasteners, if you can report if there's any damage on the Nader fastener.
You can see that micrometeoroid orbital debris shield is lifted.
J14. Take a photo of the fastener we just worked on.
Astronauts have also lifted the MLI, or the multi-layer insulation.
To access the connectors. And for you, David, if the shield is stable, you can go back to the IDA bag and release the caps from the Papa 14 and the J1, and that's on the Whiskey 4300 cable.
Am I getting my angle? Copy.
And David, those caps remain tethered to the IDA bag.
Get this angle a little better. Yeah. Those
caps remain tethered to the IDA bag.
Caps remain in the bag. Okay. One more wait.
You can see the work site and some of the cables that the astronauts will be disconnecting and reconnecting under that multi-layer insulation from Anne McClain's helmet camera, denoted by the number 18 in the lower right-hand corner.
You have a go to demate the Whiskey 2809 Papa 14 from the J14, and you can temp stow the cable underneath the MLI.
That's fine.
And for you, David, get ready to hand that Whiskey 4300 Papa 14 to Ann.
Over to the back.
At this work site, McClain will first demate a cable and then route the new cable once she is handed that by Saint-Jacques. She will route and mate that new cable, which will eventually provide Ethernet for the space station.
All right, I see Whiskey 2809, 14.
Just over 2.5 hours into the spacewalk, and the astronauts are outside of the U.S. lab performing this work.
My band. You know, bent pins.
Copy that. Good EMI band and good pins. Okay, when David has that Ethernet cable, he's going to have the Whiskey 4300 Papa 14. You're going to mate that, and you're going to route it under the handrail 0267. And David, as you transfer that, verify that all your safety tethers are clear of the cable.
Reminder. Here.
Okay, I have 504300 P14. I believe this will be going to Lab J14.
That's affirmative to Lab J14. And David, once you have you verify that your safety tethers are clear, you can retrieve the Whiskey 4300 Papa 1 P1, and it should have a label wire tie CP13. And you're going to temp stow that on handrail 0226.
You need to
so we're going to need some help with the side loading here, because this could be severely side loaded.
Yep. So I'll delay a bit helping out here with this connection.
Copy that, David. We see you there. Thanks for letting me know.
BRT down.
All right, so if you can push that cable down to try to get some of that memory in. Pull it toward you. Pull it toward you.
What clocking do you need?
I need to rotate this connector clockwise.
Oh, okay.
I need to pull this cable. This is this cable right here. So if you could grab it like here, and then we got to rotate it clockwise somehow.
Which way is the clocking? Like this?
Yeah, let's see, it's got to go over the top like that. We're going to roll it closed. You know what I mean? From here, we got to roll clockwise.
Clockwise.
Yep.
Oh, the cable is
exactly.
It's shaped that way. Okay. If I can bend it first.
Maybe.
It's going to be clocked all the way like this.
Yeah.
Or like that.
We're basically trying to bend this very angle
on a very short
at a 90-degree angle right next to the back shell.
Very short
feed it in there.
Both ends in here.
Oh, got it. All right, I'm going to hold it. Can you reach the bail?
Okay.
I'm not going to I'm not. I don't know if you can get any force on the bail from there. Even if we could just do it partially for now. Got it.
Take it in.
Well done.
Is it over center?
It's not over center.
Not yet?
Not yet. Yeah. I'll make it one side where you get the other one.
Over center.
You got it.
I got it over center.
Nice.
Both sides?
Good job.
Good. Over center, made it.
You guys make a great team. That's excellent. As Will said, teamwork makes the dream work. So, good job, guys.
Makes the connections over center, too.
Okay. Next, below gas.
Yeah, J1 to...
At the leg, right?
That's correct, and you're going to locate that J1 on the Whiskey 4300 cable, and you're going to mate it to the J1. Mate J1 to the Whiskey 280 P14. So.
Turn off the cable.
2809 P14 is in my hand.
And
all right, let's find the pins. I'll get the EMI band side if you get the pin side. EMI band is good on the P14 Whiskey 2809 side.
Good pins, no FOD.
Copy, good pins, no FOD, and EMI band. And EMI band.
Over center.
Made it over center.
Copy, made it over center. And if you can verify that the cable runs underneath the shield out under handrail 0267.
It does.
It does. Thank goodness.
And if you're good with those connections, do we have a go to perform connectivity test?
Connectivity.
Copy that. We have a go to perform connectivity test.
Go to perform connectivity.
Internet, I'll get going on the stowing you wanted me to do earlier from stowing the second layer cable.
Yes, stop it. So you would go back to the IDA bag and you would retrieve the Whiskey 4300 Papa 1 Ethernet cable, and it has a label wire tie CP13. And you're going to temp stow that on handrail 0226. It's where you attach the IDA bag connector.
I see the handrail.
And Jeanette, once you get the connectivity, the next thing is going to be closing this MLI. Is that correct?
Yes, and you're correct. And you can go ahead and start working on closing the MLI. Verify that the MLI covers the worksite under the panel. Verify that the MLI covers the worksite under the panel.
Okay.
And so, give us a few minutes so you can go ahead and work on that MLI as you need and make it as tidy as you can.
After completing the connection of some cables underneath the micrometer orbital debris shield and the multi-layer installation, McClain provided the go for Mission Control Houston to conduct some connectivity tests. Meanwhile, Saint-Jacques is temporarily stowing a cable which will eventually be routed as a wireless access port.
And so, and we've got a good connectivity test. Excellent.
Oh, that's great news. And Jeanette, the Nader Zeus fastener and the MLI is in.
Copy that. And okay, Ann, that sounds great. And if you can stand by just 1 minute, we have to verify one more test on the connectivity. 1 minute, we have to verify one more test on the connectivity.
Okay.
Internet, I have wire tie CP13 on handrail 0226.
Okay, copy that, David. And can you verify that your safety tethers are clear of the cable?
Safety tethers are clear of the cable. Just a reminder.
Okay, copy that, David. And just for your information, all connectivity tests were good. So great job, guys. For you, Ann, can you verify that the Whiskey 2809 cable is routed in the gaps in the shield nadir of the handrail 0267?
It is in between, it's coming out the same place it was before, so there's a split in the MLI. It's directly in between handrail 267 and 98, and should have a shot of it in my WVS if you can. I also took some closeout photos.
Copy, Ann. Okay, Ann, can you verify that you got the MLI Zeus fastener?
Yes, the nadir MLI Zeus fastener is reconnected.
Copy all, Ann.
Clockwise and then, or counterclockwise and clockwise.
Copy all, Ann. Excellent, Ann. Thank you for repeating that. Okay, and David, for you, if you can retrieve the rest of that Ethernet cable from the IDA bag, it's the third layer, and it should have a label saying wire tie start. And you're going to temp stow that on the other handrail 0288 where you installed the IDA bag connector.
See that?
Okay, and for you, Ann, if you haven't already, you can release your BRT.
If you haven't already, you can release your BRT.
Say again, David?
Release. I think we're releasing that AET.
Yeah. I think maybe I'll just stick around here just a few more moments near the shield in case I need help with the
I think it's going to be a two-person task to get this closed.
Okay, copy, guys. We have a 20-second to a handover.
Copy.
As you saw, we had confirmation from Jeanette Epps, the ground IV today, that there was a good connectivity test with the cables just installed. The astronauts are now reinstalling that multi-layer insulation that was removed to access the worksite, and then on top of that, we'll reinstall the micrometeoroid orbital debris shield. Additionally, they will retighten those tie-down tethers on top of the micrometeoroid orbital debris shield and perform some worksite cleanup before moving on to their next task.
Down there.
What?
Okay, guys, we're back up with you on voice and no video.
Yes. Copy. We are just working to get the car head closed.
Copy that. Can you verify that you have a RET to the long T-handle tool and your mini workstation?
Yes, I do. And we released the AET from 364. I am ready to the T-handle tool and that AET so we can go with the next work site. And we're working on getting the flanges underneath if that's our good next step.
Copy all, and good work.
Okay, just clock it a little bit towards station and kind of bow it down.
Okay. Yep, that's good. And actually now, let's get it down and then push. Maybe if I push it down and you push it in?
Yeah, I'll try to go up in the crease.
Go ahead. Push it in.
Push further down, I think.
Hold on, let me see if I can get over this connector. We kind of decide which way we're going to do first. I think if I push it down, and then we try to rotate it in.
Go out, and shift, and in. Right?
Sorry? Great technique. Yeah, there's cuts on the shield. You can tell from where I don't want to hit the V with infinity too hard.
Okay, Ann and David, we see that you're having some trouble getting the shield in. You can likely use the pry bar and use that, or you can remove the handrail if you need to.
Copy.
And if you use the pry bar, you use it sort of like a shoehorn to push the shield in.
That makes sense.
Okay. How far are we?
We're close.
Wow, what was that?
So we're sort of there. We got to get. This is where we're going to have to kind of rebend this.
It's bending on. It's the connector of the EWIS antenna that's catching.
Yes. And it can tell it's caught there before. Not the first mark in the motor shield. I wonder if we lift it up and then pull this side down first. Can you lift up with your left hand? Or maybe we should just redo that adjustable and then let it out slowly. See what I mean? Because it'll kind of, we can put a little memory in it and then stick it underneath.
There's the friction.
You want to set adjustable back on?
Yeah, we'll do that, yep.
Maybe try to bend it. It's down.
Right here?
Yep.
Out of this position.
Okay, Ann and David, if you can ensure that the tabs on the inboard side are in before you push in, and then that may help you get it in.
Yeah, they're not. That's the issue. Two of them are out.
Copy that.
We had it in, and the issue is actually not the handrail, it's the EWIS antenna connector. And I think it's because we bent the shield, not permanently, but just bent it on its way out, so we need to bend it on its way in, so we're just kind of figuring out a way to get...
Back our track.
Yeah, kind of work backwards.
Copy all, Ann.
So I think if this was connected, then we could bend this under, and then let it go.
And Ann and David, just a reminder that if you need, you can remove the handrail.
I think I found something that interferes. You see that trunnion there?
Yeah.
I think that interferes with us. That needs to go underneath the shield.
Oh, that pin? Oh, I see what you're saying.
I mean, yeah. I think that's what we're putting it in.
Yep, yep.
I think that's what it is.
Yep. I concur.
You flip that under. Give a line.
You need the pry bar?
I want to see if I can get there.
Or do you want that T handle tool to push on it?
Yeah. Let's get here my beer T.
I should go up there.
Yeah, no, this is what I need. I know what I need.
That's that corner. I think that's what we're talking about.
It's just a rat, some junkie with a rat.
Okay. So Jeanette, just so you can picture what we're talking about, the shield on the inboard side by handrail 267 is caught underneath the base of one of the...
push now, you're clear.
Come on, stand by.
Yeah, clear.
It was caught under one of the MLI juice fasteners.
The innermost juice fastener of the MLI.
But he just got it.
Okay, now let's push.
Okay, I copy all in, and we see what you're doing there.
All right.
Everything very good?
That's close.
Right.
You can see McClain with red stripes around the bottom of her spacesuit at the lower end of the screen as EV1 and David Saint-Jacques just above her with no stripes on his spacesuit as EV2. The pair are working to reinstall the micrometeoroid orbital debris shield.
And you would have to drive 2 bolts because the handrail is in a seat track.
Copy. All right. Whoop.
Okay, and at this point, we recommend that you go ahead and remove that handrail.
Okay, so I see a 16 bolt right in front of me on this end. And pull that to the handrail.
And if you need, I have steps for you, and I have a PGT setting as well.
Copy.
So is it far enough in, you think? No.
Is it far enough that way?
Yeah.
Might be able to go more. Can you kick that part down a little bit? There we go. Oh, we're getting it.
There. Again, there's got to be some hard interference somewhere.
There's what?
There's hard interference somewhere.
Yep.
Okay, and you guys have done a great job in trying to get that panel, and we think that you should go ahead and grab your PGT and loosen the handrail to get that panel in.
Copy. Ready for settings.
Okay, and in your PGT settings would be alpha 7, counterclockwise 2. And you should only have to turn the bolt about 1 turn.
Okay, 1 turn. And if I just release this, the Zenith side, is that going to be able to swing out? Or I'm not going to have to release both sides?
And you'll not be able to swing it out because the handrail is in a C-track, so you'll have to loosen both.
Copy, understand. All right.
Do we have to ret it? Or?
I have a ret on it. I move my end effector so I'm not actually connected to it.
So, and just to clarify,
I have alpha 7, counter 2 set. Sorry, go ahead.
Those are good readbacks for the PGT settings. You're going to make 1 turn on each bolt, and then you're going to change your PGT settings after that.
Copy and work. There's 1 on the Venus. You could probably find something else to hold on to.
We copy 1 on the Zenith.
What am I getting pulled by?
Waste tether.
Waste tether, yeah, it's slid down to the bottom.
I have there, treated.
Can you throw that back? Okay, there's 1 turn on the nadir bolt.
Okay.
For the next setting.
Copy that, Ann. So you're going to change your settings to Alpha 1, counterclockwise 2, and then you're going to release both bolts to a hard stop. It's going to be about 6 turns each.
Alpha 1, counter 2 to hard stop.
McClain is using the pistol grip tool to loosen and remove a handrail to allow them better access to completely retach that micrometeoroid orbital debris shield.
Okay, guys, great work. We see you on the timeline.
Copy, thanks, Jet. Okay, there's our hard stop on that, is Venus. Okay, those bolts are moving the hard stop.
Okay, and in order to remove the handrail, you have to depress the release buttons.
Copy.
And then you could slide the handrail out, slide it nadir out of the C-track.
Work. I just took off down the handrail and hold it up. Okay, I think we can get past that there, yeah? Yeah. Right. You're on the same, you're on the same juice fastener. Same issue as previously. Sorry? You have the same issue, it peeled off, it peeled under the MLI juice fastener. Okay. Don't forget. Alright, here we go. Okay. Get it down in the middle again. Yeah. The next point is, yeah. Technique. Okay. Well, that's good enough. There we go. Got it. How about the cables there? Where they go? So this is where they were coming out before, yeah. It looks good. Yeah, I concur. Did we get the handrail back on? A lot easier to work here when there's something to hold on to. Did I get it? I got it. Oh, had it. I'll get this side to get that set.
And David, for you, while Ann is getting that handrail installed, can you verify that all the tabs are in on the inboard side of that panel?
3 tabs are in. The panel is flush with its neighbors.
Copy, 3 tabs in. Thanks, David. And Ann, let me know when you're ready for PGT settings.
Stand by.
Pull towards me a little bit so you can He's not in the rails.
To go toward you.
And we're going to go both in at the same time.
There we go. Now.
Okay. If we're in, maybe one
more little seat track. Yep.
So, and you go ahead and install the handrail by sliding it into the C-tracks to a hard stop with the T-tab, and then you're going to push the handrail into the C-track to engage the soft dock feature.
That didn't work. There we go. Got it. Yep. And then
push on the button on this side. It's out of the track here. Not in the track on this side.
Out of the track?
Not in the track.
Yep. Yeah. You can pull it.
Again.
Yep. Good. Push.
Okay.
Put it in. That's it.
Yep. That's where it wants to be. Yep.
Yeah. Okay. And before it moves again, let's PGT it. All right, ready for settings, Jeanette?
Get a hand on it so it doesn't move away.
Thanks.
Okay, and your PGT settings are alpha 2, clockwise 2, and you're going to turn each bolt about 7 turns to a hard stop.
Alpha 2, clockwise 2.
Those are good numbers.
All right, it's tracking in. All right, I have a green light, 3.7 torque, 9.2 turns. The stator thing?
Copy that, 3.7 and 9.2 torque.
And 3.7 torque, 9.2 turns, green light on the Venus side. The handrail is reinstalled.
Okay, those are good numbers, Ann, and good job. So next, Ann, you would go back and reinstall those long duration tie-down tethers on the lab handrail 0298.
Copy. Throw me those.
And for you, David, if you can retrieve that the rest of that Whiskey 4300 Ethernet cable and temp stow it on handrail 0288.
Ahead of me off the long duration head antennas at the moment.
Copy that, Jeanette. I'll just finish helping. I think this is our efficient people here.
Okay, that sounds great, David. Great teamwork.
McClain is finishing up the reinstallation of that debris shield by tightening those long-duration tie-down tethers. Afterward, they will perform some inventory of the tools in their bag and then begin cleaning up the work site.
Taking tension.
I'm going to close up this. No eye on the buckle now.
So, Jeanette, we're not attempting anything with the central juice fastener, right?
Can you repeat that, David?
We're not attempting to do anything further with the central juice fastener?
That's correct, David. You're just going to reinstall the long duration tie down.
Okay.
Okay, and can you verify that you cinched the long-duration tie-down tether after you got the hook on?
Yeah, we cinched those. There's just a little bit of play in them. I don't know if you can see them in the WGS. We can pull them tighter if need be.
Copy, and we're looking. Okay, and we see that, and we need to tighten that up because those are the tie downs are what's going to keep the panel in.
Copy. We'll switch them down further.
Awesome. Thanks, Ann.
No worries.
And? Yeah. The one I'm working on is a twist.
Sorry?
Yeah, just to flip the connector half a turn.
All right.
We're 3 hours and 11 minutes into today's spacewalk, and this is a live look from Mission Control in Houston, Texas at Johnson Space Center. Astronauts have just installed a new spider cable under an orbital debris shield and are now cleaning up that work site.
All right.
Okay.
Are you ready for this J1 connector on the EWIS?
And that's a good teleconfig, and we are ready for the EWIS antenna connector.
Work.
Into that, I'm going to go back through the bag and say again the next steps for me, temp store cable.
That's affirmative. You're going to go to that third layer in that IDA bag, and you're going to grab the rest of that Ethernet cable, and you're going to temp stow it on handrail 0288. And you should see a label, wire tie start.
Start on 0288.
I got ahead of band and no bent pins. Working on getting it inspected. And we are mated over center on the EWIS.
Copy that, mated over center on the EWIS antenna. Okay, and if you loosen the gap spanner. Right now, Ann, we don't have your WVS.
Interesting sound. Are you still with us?
Hear me, Ann?
I hear you.
I hear you faint.
You hear me faint?
Faint, yeah, very faint.
Can you hear Jeanette?
I can hear her faint too.
David, how do you hear me now?
I hear you. Yes, we hear you now. Do you still have me faint?
Yeah, I hear Ann fainter than before. Don't know about you, Jeanette.
Okay, and I see you tightening up the gap spanner. We need a report on the other long-duration tie-down tether. We want to make sure that that is also cinched down.
Yes, that is pretty tight.
Yeah, cinched
it is
down
a guitar string.
I see that in your WVS. Thanks, Ann.
Great.
And can we see the... Go ahead, Dad.
So just one clarification for the cable that I'm lying down. I am leaving the adjustable in the bag.
That's correct. You're going to retrieve the adjustable from the spider cable and stow it in the IDA bag.
Great.
And for you, Ann, can you verify that the MLI is covering the buckle on that second long duration tie down and the wire tie is in place?
Yes to both, and I'm getting closeout photos for you of the whole area.
Thanks a lot, Ann.
McClain has remated the antenna previously demated to access the work site and is taking some photos of the work site as she prepares to move on to their next task.
All right, photos complete.
Copy that. And one last item, the gap spanner. If you can rotate the buckle 90 degrees after cinching it to ensure that we have 1 inch slack. And we're coming up on the day pass.
Copy, and yes, we can rotate the buckle.
I saw that, Ann. Thank you.
For the cable.
I saw that, Ann. Thank you. Go ahead, David.
I think I copied I should look for wire tie start. I don't see that. I see wire tie number 1.
Copy. Stand by.
Looks to be the kind of the outermost wire tie.
McClain just tightened the gap spanner, which translation paths aren't always easy on stations, so sometimes in between handrails on the modules, gap spanners make it easier to move from one location to another. We are also entering a day pass over the South Pacific Ocean.
And,
the adjustable is in the bag.
We copy all, and if you can verify that your safety tethers are clear of the cable.
Safety tether is clear of the cable.
Clear of the cable as well.
Copy, Ann. And since you're done with that, Ann, can you give us a glove and hab check?
And Jeanette, just one thing to add on the left glove. Again, my index finger, RTV, I don't know if you can see it in the WBS, where the out of my pointer finger is, the RTV is peeling back, but it looks like there's a second layer of RTV underneath it.
Copy, and we can see that on your WBS checking. We copy all on the left glove, and we'll just track.
And Jeanette, I can give you an inventory of the IDA bag if that's next.
That is correct, David.
Inside the bag, you have a extra cap on an adjustable, a jack cap on an adjustable, tie bar on a ref, a small, large adjustable, and a small adjustable. And that is all for the inside. And on the outside, there's just one wire tie on the lid.
Yes, that was that. Here's the lid strap.
Okay, David, that's a good inventory.
Thank you.
So next you're going to release the 4 hooks on the IDA bag and stow it on your BRT, and then we need to get a glove and half check from you.
Do I have?
All right, the lid straps closed out.
No changes on the glove.
I'm going to release these two.
You're up to it?
Okay.
And for you, we didn't get a check of your right glove, and we need a half check as well.
Yes, the right glove with no change and dry half.
Okay, we can copy right glove good and dry half.
Let me know when you want me to release these two.
And with that call in, I see you helping David get the IDA bag, but you're going to translate back to the no-coordinator crew lock bag on the cedar rail, and you're going to retrieve your green hook as you're heading out there.
Okay, and you're ready to begin?
Ready.
Okay, I've released one. I'm going to go get the other one. All right. Those are released. I did not hook them back to the bag.
Bottom two released?
Yeah, bottom two are released. I've not hooked them back. All right. I'm going to start heading back unless you need a hand.
I'm releasing the last one and I'm on my way.
Okay.
The bag is on my ERT.
Copy, David.
4 corners released.
Okay, guys, we're pretty much on the timeline. 3 hours and about 20 minutes. PEP.
Okay.
And David,
now retrieving my green hook. Retrieving my green hook.
copy, you're retrieving your green hook, and then after that, can we get a glove and half check?
So tonight I have my green hook from 2.
We're currently in a satellite handover as the astronauts wrap up their work at the second work site of the day on the U.S. lab. They lifted and removed the micrometeoroid orbital debris shield and multi-layer insulation after having just a little bit of trouble releasing one of the fasteners. They then mated 2 cables underneath and routed one outside to provide Ethernet to additional Ethernet to the space station.
And you're heading out to pick up the crew lock bag at mile marker 7860.
Copy.
McClain is now going to pick up a bag previously stowed on the space station, and Saint-Jacques is heading back to the airlock to stow a bag and retrieve the Truss Jumper cables, plus one orbital replacement unit bag.
Okay, David, we had that handover, so we didn't get the glove and hat check from you.
Dry hat. No changes on the gloves.
Copy, no changes in the gloves and the hat again.
Dry hat. Am I cutting out?
Copy, dry hats. And David, I see you're heading back to the airlock, and so you're going to go back to the airlock and stow the IDA bag in the airlock.
See, I'm on phase 1.
Copy, phase 1.
We're about 3 hours and 30 minutes into today's spacewalk. The astronauts are now leaving the U.S. lab segment and are heading to the Node 1 portion of the space station. That's the Unity module. Unity was the second element of the space station to launch.
All right, I'm at the location where my crew lock bag and the spare lead are. Directing both.
Copy that. You picked up your spare lead as well. Copy. So you're going to head to the Node 1 nadir work site via the airlock. So you're going to go past the high-pressure gas tanks beneath the ESP2.
Okay, and I just got there, so I have not picked up the bag or my tether yet.
Okay, copy that, Ann.
You at the fuse spurt? You at the airlock.
Copy, David. You're at the airlock. You would go to open the thermal cover and stow that IDA bag in the airlock.
We've got more Ask NASA questions coming in. If you use that hashtag on Twitter, we will look to answer your question on air. This one comes from Oma asking, why was the mirror added to the astronauts' spacesuits? The primary reason the crew wears mirrors is to be able to see the switches and labels on the front of the suit because they can't look down and see it. It's out of their view. That's things like their volume or cooling. The labeling is written in mirror image because they can use the mirrors on their wrist to reflect back and see the actual reading.
All right, I have the crew lock bag. It is redded to my BRT, and it's in my BRT.
Copy that, Ann.
So far on today's spacewalk, the astronauts have relocated an adapter plate to complete some battery work that has occurred over 2 other spacewalks in the last few weeks. They just installed a new spider cable to extend Ethernet further on the space station, and the next cables installed will provide backup power to the Canadarm 2.
And as I said earlier, you're going to head back towards the airlock, and then you're going to go nadir past those high-pressure gas tanks to get to the work site. And one item, when you get back to the airlock, we have a troubleshooting step for David's WVS. So if you can stay at the airlock for a minute, and we'll give you those steps when you get there.
Sounds good. EV2, the IDA bag is in the airlock on a large, small adjustable.
Okay, David, we copy that the IDA bag is in the airlock, and next you're going to retrieve that medium ORU bag, and you're going to bring it out and stow it on the airlock starboard toolbox nadir handrail.
Starboard toolbox, major handrail, good work. All right, land back toward the airlock. Jeanette, if you wanted to walk us through the WVS troubleshooting.
Yes, and what we're going to have you do is we're going to have you pull the tab on David's Reba battery, and you're going to pull the right one towards his right shoulder.
Copy.
So, David, once you come out with the medium ORU bag, if you and Ann can work out a good time to do that.
Cool. Yep, let me show you my bag. All right, we're going to go towards your right arm, which is toward me. Okay, that is pulled toward me, or toward your right arm.
Okay, thanks, Ann.
Switch it on. On the button. I'm going to join on the button. All right, so. Oh, no green light.
We copy, no green light.
And should I stay here or get to translate?
Okay, David, with those troubleshooting steps, since you still have no green light, we don't believe that you'll have glove heaters for the remainder of the flight of the EVA.
Thanks for the heads up.
Okay, and I see you heading out to the work site. I have a caution and a warning reminder for you. First, as you translate out, if you can avoid inadvertent contact with the existing connectors and fluid QDs at the work site. And then the warning is do not translate on the gap spanner restraining the Node 3 and lab fluid jumpers.
Okay. Internet, the medium ORU bag is on the starboard toolbox major extension.
Copy that, David. So next you're going to go back into the airlock and you're going to retrieve the truss jumper cable with the cap keeper.
Good. All right, I am at code 133, Jeanette.
Okay, that's a good handrail. And you can release the gap spanner from that handrail and stow it on handrail 0132.
That will work.
Saint-Jacques is retrieving some tethers from, some cables from the airlock on the International Space Station, while McClain has translated to the Node 1 nadir shield. That's the Earth-facing side of Node 1. Saint-Jacques will also make his way over to Node 1, but he will be on the zenith side to install some truss jumpers as well.
In the way at all of accessing this panel. Are you good with me just leaving it?
Checking in. So, Ann, that's your preference. If you don't think it's going to be in your way, then you don't have to remove it.
I don't think it's going to be in the way. It's loose and it's just kind of right at the edge.
Okay, copy that. Then you can leave it if it's not going to be a problem for you. But I see those wire ties. So next, if you need to release the wire ties to move those existing cables in front of the shield there, and we're talking about shield Charlie 208, you can release those wire ties to get them out of your work site.
Jeanette, I have the Truss Jumper cables, blue and red.
David, repeat that.
Method to the cap keeper.
So, David, would you verify that you have the cap keeper connected to the truss jumper cable?
The cap keeper is connected to an eyelet on the far end of the truss jumper cable. I have a rep.
Copy all, David.
I have a rep to the cap keeper.
Copy all, David. Thanks.
This is a view of the Quest airlock. David Saint-Jacques is inside right now, retrieving some jumper cables. You can see the Earth a little bit in the background as the space station is coming up just off the west coast of Ecuador.
That might be why I felt like was coming lower.
Copy that, David, on the left side.
Yeah, that's what it feels like. Either left or at least much fainter on the left.
Okay, David, can you report whether or not you feel like there's sweat on your head?
I do feel some sweat. It's hard to tell if that's enough to kind of drown the hearing.
Okay, we copy that, David.
Raise the volume up to 5 now on the tri-radio. I hear you better.
Okay, copy that, David.
Jeanette, the long T-handle tool is connected to Charlie 208. Good pull test.
Copy that, Ann. Thanks for that. Okay, now if you need to, you can BRT to the handrail 0133.
Yeah, I will probably do that in just a second.
McClain is working on Node 1 to remove another micrometeoroid orbital debris shield.
Copy that.
That thermal cover is closed.
Copy, thermal cover is closed. Okay, while at the airlock, can you give us a check of your safer handles?
And that I believe my next step is to release these 3 Zeus fasteners.
Copy that, Ann.
Those handles are down, Jeanette.
And copy, good handles are down. And can you give us a half check?
A dry half.
Copy, dry half. Okay, David, you're going to head out to the Node 1 Zenith forward end cone, and you're going to be looking for handrail 0137.
0135.
And we see that you're working on those Zeus fasteners, and just a quick reminder again, warning that the Zeus fastener tings could have sharp edges.
3 hours and 40 minutes into today's spacewalk, and the astronauts are moving into their third task to install some backup power cables for the Canadarm2.
Starboard released as well.
Copy, starboard release. So now you can remove that shield Charlie 208 and tend it over to the other shield, adjacent shield starboard, Charlie 207.
And Jeanette, unload the high pressure gas tanks. Pass on to the feeder screw.
Copy, David. And David, you should see that handrail right as you get out to that work site.
Okay.
And you can take that adjustable that's on that long T-handle tool and connect it to handrail 0133, and that would be on the starboard stanchion.
I have a BRT to 0137.
Copy that, David. And now you're going to demate two Z1 connectors from the Node 1 Zenith, and you're looking for Papa 140. You're going to disconnect that from the J640, and you're looking for the Papa 141. You're going to disconnect that from the J641.
These are the two outboardmost ones.
At this work site, Saint-Jacques will demate two connectors and mate an additional two before routing that jumper cable bundle across the boom.
From the MLI. And first, before you continue, we need for you to connect the adjustable from the long T-handle tool. It looks like it's connected to the gap spanner. If you can make sure that it's on the starboard stanchion of handrail 0133.
Copy. That starboard stanchion's clobbered, unfortunately, so it's not free. I don't think I can get another hook on there. Can I go to one of the French hooks of the gap spanner?
So you can connect it to any other handrail. I mean, if the other stanchion is clear, you can connect it to that and just tend it over to the other MOD shield.
Jeanette, Papa 140, Papa 141 disconnected.
Copy, and can you give me a report on the FOD pins and EMI bands?
Pins, open pins, no FOD. EMI bands on both.
Okay, that sounds great, David. If you can wire tie that Papa 140 and 141 off to a nearby cable uncapped.
Okay, and Jeanette, I got that AET on that starboard stanchion by releasing. There's an AET that was connected to that starboard stanchion that's connected to a connector, but it's also wire tied. So I just released that AET and it's just staying right there, so I'll reconnect it at the end.
Okay, we copy all in, and we're fine with that. So if you need to, you can go ahead and release your red hook from the T-handle tool.
That is released.
Okay, we see that, and so you are going to release that starboard nadir Zeus fastener from under the MLI, and remember not to release the other two inner MLI Zeus fasteners, just one.
Once McClain accesses the worksite underneath the orbital debris shield and the multi-layer insulation, she will begin demating the currently connected cables and mate them to the new adapter one at a time.
Starboard Zeus fastener is released.
Copy that, Ann. We see that. So, Ann, for you, next we're going to demate the starboardmost pass-through connector under the shield. And it's going to be near the handrail 0133. And you should see J607.
Okay.
And for you, David, after you've wire tied those cables off out of your worksite, you can retrieve that jumper cable bundle and release wire tie start, one twist.
Copy, I'm just finishing the wire tying.
Okay, copy, David.
The cables are tied off.
Copy that, David. The cables are tied off.
On to the connections. Leaving starts.
Copy, David.
The bailback on J607. Just going to get it off the connector.
Copy that. You've got the lever back on J607.
Moving the caps from the red and blue ends.
Copy that. You're removing the.
641 and P641.
Copy that. You've removed the caps P640 alpha and P641 alpha.
Correct. All right, J607 is removed.
Copy that. Can you give me a report of the FOD pins and EMI bands?
Don't have a great view inside of the that it was removed from, but we've got good pins, with 3 good pins on the J607 side.
Copy that, Ann. And if you need to, you can go ahead and slide that shield farther out of your worksite starboard. It looks like it's difficult to see in there.
That's J641 alpha, made it to J641. No band pins, no FOD, we didn't my band.
Copy that, David. Good call, and you did the blue one first. Thanks. And then you're going to connect the P641 alpha to the J641.
That is made it over center. Both connectors made it over center. Both good pins. FOD, we did my band.
Copy all, David. And for you, Ann, after you've got that disconnected, you're to retrieve that jumper Whiskey 1010 from the crew lock bag, and that jumper remains routed to the crew lock bag. And for you, David, now that you've got those connected, you're going to route the jumper cable bundle across that cable tray, and you're going to install wire ties number 1 and number 2 to the cable tray boom handrails on the nadir side, and ensure that your safety tether is clear of the cable.
Copy and work.
Saint-Jacques has mated the connectors at his work site. These are backup power cables for the Canadarm2. McClain is now underneath the orbital debris shield, where she will begin mating the new adapter to the cables underneath.
All right, I have the T1010 cable Papa 609 connector.
Can you repeat that connector number again?
I have the T607 on the Whiskey 1010 connector.
Okay, those are good numbers. So you're going to connect that to the J607, the Whiskey 0918.
Yeah.
And you're going to check that the lever on the 607 is forward and over center.
Okay, and
The network ties 1 and 2 made it to the gray boom.
Okay, excellent, David. So next you're going to route the cable bundle behind the strut, and you're going to release wire tie start again, 1 twist.
Copy.
Saint-Jacques is going to be installing some wire ties on handrails.
Both sides of that connection.
Copy all of that, Ann.
The cable Saint-Jacques is routing, he will ultimately bring to the S0 truss section, temporarily stowing it there where McClain will access it later.
Copy, I see it.
Jeanette, so I undid the wire tie start once more to feed the cable. Confirm where does wire tie 3 go?
Okay, wire tie 3 is going to go to handrail 3461, and it should be port of WIP 14.
3461. I completed a red swap past the cable on the other side of this thread.
Copy, David.
Yeah, can I release the TA clamps upstream of these to get rid of some of the side loading?
Checking in. Stand by. Okay, and you can go ahead and release those TA clamps.
Thanks.
We're still taking Ask NASA questions, and this one comes from Spivey, who wants to know if the team practices all of the system repairs in zero gravity. While we can't practice in zero gravity, the astronauts do train for spacewalks in the neutral buoyancy laboratory here in Houston, Texas.
Copy that. Next, you're going to route and release wire tie start and wire tie 4, 1 twist, and you're going to install wire tie number 4 on handrail 3460.
The neutral buoyancy laboratory is a very large pool, and it has mock-ups of the space station underneath, so the astronauts can go in, suit up, and get the closest thing to microgravity as possible on Earth.
J609 demate it. And now you're going to...
1010 in my hand.
That's affirmative, and you're going to connect that to the J609 and confirm that the P609 is forward and over center.
Copy, Mark.
we're type 4, handrail 3460.
Okay, great job, David. Next, you're going to go to the MLI, and you're going to open that flap near width 13. And this is where you're going to stuff the truss jumper cable bundle and the cap keeper into the truss.
Yep, I see that opening, and I see the handrail.
Excellent, and you should see handrail 3451, and you would use wire tie start to bundle that cable inside the truss.
I see 3451 inside the truss.
Good read back, David.
Okay, we're mated over center on both sides of the snap connector for 609.
Copy that. Mated over center on the J609 and the adapter P609. So next you're going to release the ret from the jumper and let it tend itself back to the crew lock bag. And then you're going to demate the second from the starboard pass-through connector.
Relax. 608.
That's correct. J608 is second from the starboard pass-through connector.
Is demated.
Copy 608 is demated.
1009.
And copy you're retrieving Whiskey 1009 from the crew lock bag.
I have a Whiskey 1009. I have a Papa 608 connector in my hand.
Okay, you are right on track. You're going to connect that to the J608 and confirm that the P608 is forward and over center.
Copy. And I have good pins, no FOD.
Copy, good pins, no FOD.
I don't see an EMI band.
And good EMI band, copy.
I said I can't actually see the EMI band. See just a little bit of it. It's pretty recessed in the snap connector.
Okay, we copy all, and that's what we expect.
And that is mated over center.
Copy mated over center. So next you're going to demate the fourth from the starboard pass-through connector under the shield. And we have 10 seconds to a handover.
We've just entered another satellite handover while the space station is flying 257 statute miles over Ukraine. We're now 4 hours and 5 minutes into today's spacewalk, and this is a live look of Mission Control in Houston, Texas. Everything is moving as planned today, minus a few modifications with some shield removals.
Okay, Ann and David, we should have you back on voice, and we should get video shortly.
We are continuing to answer Ask NASA questions, and this one comes from Miss Zippel's class. Her students in grade 6 want to know how the International Space Station receives power. The space station is totally powered by the sun, and you can sometimes see those big solar arrays that capture the sun's light. It uses the sun's power and stores that in the batteries, which we were replacing earlier today. That's through the help of the battery charge and discharge unit. When the station is in the sunlight, it stores the power, and when the station is in darkness, it discharges the power through the batteries, which then power the space station.
It's wire tied with wire tie start to 3451 at the truss, and I'm closing the MLI.
Copy, you have wire tie start on handrail 3451 and closing the MLI. And for you, Ann. You should have disconnected, demated the fourth from the starboard pass-through connector.
Not yet, working on it. Have to reposition the
Copy.
airways down here.
I believe I'm now on my way to retrieve Ann.
And David, before you do that, could you give us a glove and hat check?
Of course, yes. Draw hat. On my left index fingertip, with some eraser type liner.
Copy for the left on the index, eraser type.
I have 610 disconnected, and in my hand I have Whiskey 1009, 610 ready to connect. I have no spod, HDMI band, and no bent pins.
Copy that J610 to the adapter in the P610 and confirm that the P610 is forward and over center. Forward and over center.
Work.
And David, I'm sorry, but I didn't hear for your right glove.
No change on the right glove.
Copy, no change on the right glove. Thanks, David. And so for you, David, next if you can head out to help Ann, and she may need your help to reinstall the MMOD shield on the Node 1 nadir location.
All right.
That'll be good timing, so just getting the last connector here to read.
McClain is mating the last of the new adapter cables for this portion of the spacewalk, which will provide backup power to the Canadarm2.
And 610 has made it over center. I think that's 2 good jumpers installed.
Copy that in. P610 is made it forward over center. Yeah. And one quick question. Can you confirm that for all the jumpers that you connected, that with the adapter, that both levers were forward and over center?
Yes, I actually just went back through and looked at all 8 connectors, and they are all over center. And for the
Perfect,
SA,
Ann.
I released 2 TA clamps, 3 TA clamps. Right?
Copy. You reconnected the TA clamps.
That I did not. I released 3 TA clamps.
Copy. You released 3 TA clamps. Thanks for the correction.
So I am just about to close the MLI.
Okay.
And Jeanette, am I good to close up this MLI?
And yes, if you can restrain the jumpers behind the shield, and if you need to, you can use those TA clamps, and then you can install the Zeus fastener on the MLI under the shield if you removed it, and you did remove one.
Copy.
You can see David Saint-Jacques has joined Anne McClain to help reinstall that micrometeoroid orbital debris shield.
David, can you confirm whether or not you changed your TCV settings?
I did, yes. It was running hot. Now I've...
Okay, we copy, David. Thanks for letting me know. And guys, we have about a minute and a half to a night pass.
Okay, thanks. All right. Well, I'm sorry, but a little bit better behaved.
Yeah.
You can move to the right if you want to come in.
Well, yeah, what do you envisage?
Sorry?
What do you think would be most helpful?
I think if we both reposition it.
Okay. Should I be here? Stable?
Yep, I'm just kind of getting the MLI down. I gotta get one MLI Zeus fastener still. Okay.
Guys, we're coming up on sunset in about 15 seconds.
Okay, thanks.
Put that bag out of our way.
Yeah. All right, get this TA clamp back.
Okay.
You can see the space station has now entered an orbital nighttime flying over Afghanistan, and the astronauts continue that work outside of the Node 1 module.
Sure? Okay. Maybe in a better position.
Yeah, if this can go to your sleigh anymore, it'd be better.
Yeah, I see. I'm butting against the phone.
There we go. I got the Zeus fastener. I just need to tighten it. That's right, tighten it.
Looks good.
That's good. I can slide this over. So this is connected on an AET.
You see the long T-handle here? Yep, see that?
So, Ann, you should red to the long T-handle tool with your mini workstation end effector, or David, And just a quick reminder that the Zeus fasteners have to be connected in the proper order. You have to do the center Zeus fastener first.
Okay. Got it. Right, so there's a ret from V's workstation to the long key handle now.
To the handle or to the adjustable?
The tether point. The capped on tether point.
The adjustable, yeah.
The capped on tether point.
To the toe? Oh, to the tether point. That makes sense.
All right. So we're going to slide this back. You may need to release that adjustable off of that handrail.
Oh.
All right, and then got to just kind of go past all those
cables. What's underneath here? With the gap spanner?
Yep, and that gap spanner is just slides right under that gap spanner. All right, cable behind my head.
I think it's catching on the little tubes at the center of the axis. There you go.
Copy. We're going to need to pull it toward us in order to get the flanges under again. That's not going down.
Towards you.
There's a couple of cables here.
Another inch.
There we go.
Got it. Do all these cables run?
Yeah, and now we just got to make sure everything's out from the bottom of it.
Everything on top?
Sorry?
All the cables on top?
Yeah, everything goes on top. The gap spanner goes on top too.
So, Ann and David, if you can ensure that the 3 tabs on the inboard side of the panel are in, and that should help you get the panel in properly.
Okay, they're in.
Copy, Ann.
All right, the panel's got to go.
Is it too tight?
It pulled right over it last time. It's a little tight, but it still works.
Slacking it.
There you go. Yep, there you go. Yep.
This juice is not bad here. Need to go further in?
I don't know why this seems like it might need to.
Find your grabber daddy. Gonna be in the way.
Yeah, it's sitting on top. Yeah. All right, so I'm going to do the center V fastener first.
After reinstallation of the orbital debris shield that the astronauts are working on right now, they will continue their tasks separately. After cleaning up this work site, Ann McClain as EV1 will continue working with the Canadarm backup power cables by completing the routing of the cable that David Saint-Jacques stowed in the S0 truss. Saint-Jacques will move over to the Columbus module, where he will begin installing some trunnion slip-off preventers to prepare for the arrival of an external payload platform next year.
It actually needs to go further in that way.
Toward you?
No, toward the node, the center.
Yeah, okay. Pushing against something hard.
Yeah. Could have just, the connector could have floated up. But these are the floating kind.
No, needs to go further in, radially in now.
Radially in, yeah.
I confer to the neighbor. Lift because the Zeus Cessna is cut.
Yeah. Oh, it's also got a, maybe I could slide one of those sliding connectors.
While the astronauts complete this orbital debris shield reinstallation, we've got a question from Ray from using the hashtag AskNASA. Ray wants to know how much training it takes to become an astronaut. After initial selection, astronauts go through about a 2-year training period through multiple systems and processes, anything from Russian language training to training for spacewalks in the neutral buoyancy lab, as we discussed earlier.
This corner looks like it's in the right place.
Once they are assigned to a mission, the astronauts continue their training, and they are always keeping their skills sharp.
It's very close. Oh, that might have been it.
What?
No, that might have been it. I think that's going to work. All right, do me a favor and put downward pressure a little bit if you can.
Holding it.
Our next question comes from Dan. We've gotten several questions about the glove check, and he wants to know what is the purpose and how often does it happen. Mission Control or the astronauts can ask for or provide a status on their gloves at any time, but it's timelined for almost every, to immediately occur almost every procedure. Sometimes the gloves can be damaged, so the astronauts take good precautions to make sure that there is no damage done to the gloves during the spacewalk. Some tasks like relocating the articulating portable foot restraint or lifting the orbital debris shield may cause more glove wear and tear than others.
They're giving enough force in there.
I heard that.
Yeah, I heard it too.
I felt it fall into the slot there.
Yeah, the problem is I have nothing to pull against. I need to put something down because I got nothing to...
Put a VRT on. A VRT. This'll work. hold you like this.
You guys are doing a great job. We're just letting you work through the issue.
There we go. That worked. Hold that down. It doesn't come back. It's got to be held down so it doesn't come back up. That just punched it through to the wire. Well, I got it. I like it. Got it.
Great job, guys. You are phenomenal.
The side one.
30 minutes.
You are phenomenal.
That center one is a good lock on it.
And you can try whichever other Zeus fastener is easiest for you to get to.
Copy. We're doing, that in?
We got starboard, is that
okay? Starboard's in. Oh, is it? No, that's not.
Copy. Starboard is in.
No, it's not in. But wait. I thought it was. It came back out.
Astronauts confirming they have tightened 2 of the Zeus fasteners.
Just to verify, you have the center and the starboard Zeus in.
It is only center so far.
Copy. Only center so far.
Sounded like a good jump. It took actually quite a lot of force to go that 90 degrees.
Oh, yeah?
Yeah.
Yes.
Right. Wait, that's actually, camera's not coming out. Into me, what do you think?
Good.
The line's only at 45 degrees, but it's holding.
We're now 4.5 hours into the spacewalk, and the astronauts are finishing up one of their tasks.
And just FYI, we lost your WVS, so we can't help out much here.
Okay, I think I must have pushed it. I can push it. I got your green light again. We're actually just trying to figure out if this starboard one is actually in, or if we just kind of have it actually in. Oh, there we go. Yep.
Yep.
Okay, we are locked on the starboard side.
Starboard lock. Have to push real hard.
Okay, and David, just FYI, we only need 2 Zeus fasteners installed, so we're going to move on from here. And David, great work, excellent work. So for you, Ann, you're going to stow that short T-handle tool in the crew lock bag, and then you'll grab the long T-handle and install it in the crew lock bag as well.
Okay. Right next to you. I can You're still ready to do this, so I'm going to
I'm going to put
send it over. Ready? Actually, you know what? Why don't you hand me that AET, and I'm going to hook the short handle to it also.
Do that, yeah, both together?
Yep.
Is there something in the crew
Ann,
bag?
just one quick question, Ann. Can you verify that the starboard disease fastener turned a full 90 degrees?
It did, yeah.
Copy.
It's connected to this fill. I'm going to let my ret go. And yes, there's a couple rets free from where the cables came out.
Mission Control has shared that only 2 Zeus fasteners need to be tightened to confirm the attachment of this micrometeoroid orbital debris shield. The astronauts are now cleaning up the work site before moving on to their next tasks. McClain will continue working with the Canadarm backup power cables, and David Saint-Jacques will work with the Bartolomeo trunnions.
You can reinstall that adjustable.
That's a good reminder, thanks. I will get that as I leave, and I'll call it when I do it.
Copy, Ann, thanks.
Both TNGL tools are on one adjustable attached to an integral ref in the crew bag.
Copy that. So one of the things we need to do is a bag inventory. So whenever you guys are ready, we can do that bag inventory.
I can get that, David, if you want to start heading towards your next work site.
Do you wish?
Because I got to go back by the airlock.
Leave it here.
Sure.
Okay, David, before you depart, can you give us a glove and half check?
I got dry head. And the gloves. Left glove, no change.
Copy, left glove.
Glove, no change.
Copy, no change on the glove and dry hat, and we have about 20 seconds to a handover. And David, you're heading back to the airlock.
Not the airlock.
Hear that sound? Please?
Say good?
You just hear that sound?
The spring sound?
Yes.
Good.
We're in another satellite handover and about 4 hours and 30 minutes into today's spacewalk. So far, the astronauts have moved one of the adapter plates that was used to store a lithium-ion battery. They've also installed some Ethernet cables and just installed some cables for backup power to the Canadarm2.
Yeah, we had a weird sound that both of us heard. Mine.
And that may be due to the fact that we went through a handover, so it could have been from that.
Okay.
And could you describe the sound a little better?
It sounded like a spring, a boing.
Okay, copy.
David, end effector still cut on there?
Yep. Checking everything.
Your end effector's got to come off and back on. Or maybe we can put it all around. There we go.
Great.
All right, we'll see you shortly. All right, Jeanette, are you ready for the crew lock bag inventory?
Ready.
Okay, on the outside, I have an adjustable equipment tether and a long wire tie. I'll open it up and right here. All right, on one of the integrals, I have a ratchet wrench with a 2-inch 1/16. I have an AET with a cap. I have a ret to the pocket caddy with a 9-inch hex. I have a ret to another cap. And then I have one of the integrals that goes to an AET. On one end of the AET is a short handle tool, and the other is a long handle tool. And then we also have the pin puller.
Okay, and could you tell me how the loop pin puller is connected?
The pin puller is on an integral.
Copy on the integral.
Jeanette, I'm at the airlock. I'm going to retrieve the medium ore evac.
That's a good plan, David.
McClain worked with the teams on the ground to ensure that all of the tools were in the crew lock bag, and Saint-Jacques has translated back to the airlock, where he is stowing one bag and retrieving another before his next task on the Columbus module of the International Space Station.
And it might have, is that the one, two that were in series to the PGT that to be picked up?
Yep, there might be some on mine. Let me give you an entry of mine in the workstation.
Copy, David.
Without a rep change at the first work site. And Jeanette, I think that's it. I have 3 normal reps and 1 rep tip pin on my mini workstation on top of the rep on my DRT. And the one
Copy that, David.
And the one for my camera.
Okay, and that's a good bag inventory. And David, thanks for the information on your mini workstation.
Jeanette, that AET from that connector is back on 133.
Copy, and thank you, Ann. And Ann, before you head out, could you give us a glove and hap check?
Glove, no change on the left, no change on the right, and a dry hap.
Copy, good, no change in gloves and good hap. Okay, you're heading back to the airlock, and you're going to stow that Node 1 meter crew lock bag on handrail 0550 near the width extender.
Copy. Jeanette, did you want me to stow that in the airlock? And this is the point where we talked I could drop off my PGT and pick up the GoPro in order to do a GoPro survey of the
Copy that,
side
and
of the S0.
stand by, I'm checking.
While McClain translates back to the airlock, we've got a couple of more Ask NASA questions. We have several classrooms in Canada watching today as Canadian Space Agency astronaut David Saint-Jacques, which you see right in the middle of your screen here, is doing his first spacewalk.
And we're about 10 minutes down on the timeline. Our PET is 4:40. So if you have time to do that, it's your call.
Our next question comes from Jordan Harcourt, whose class wants to know how the astronauts keep tools from floating away. You may have heard them use the term RET, or retractable equipment tether. Those tools are tethered both to themselves or to their mini workstation, which can be sort of like a little toolbox, as well as at some points they will tether the tools to different parts of the space station to keep them from floating away.
Medium or U bag, you're heading out to the Columbus worksite.
I think I have the bag on my DRT, rested. I'll be on my way.
Copy all, David.
Yeah, the crew lock bag is back in the airlock.
Copy, crew lock bag in the airlock.
Jeanette, if the team's happy with me trading out my PGT, I will pick up the video camera.
Copy and checking.
Copy and checking.
And we're okay if you want to drop the PGT and pick up the GoPro.
Copy.
And Jeanette, I'm on the Fetus Bird.
Copy, David. And as you're heading out to the Columbus worksite, you're going to nadir on the starboard lab struts, and you're going to drop your green hook on node 2, and I'll give you the hand roll as I see you translating out there.
Copy on node 2.
Saint-Jacques is now translating to the European Columbus module, where he will install some trunnion slip-off prevention.
Copy on phase 1, David.
The PGT and my RET for my swing arm are both back in the airlock. I have the GoPro on an integral RET to my swing arm.
Copy all
and
in.
back out the S0 site.
These trunnion slip-off preventers that Saint-Jacques will be working with today just arrived on the Progress 72 resupply craft that launched just last Thursday, April 4th. These are attachment points for the Bartolomeo platform. It's scheduled to arrive to the space station next year, and it's an external payload station that will be attached to the Columbus module.
0345, and you can drop your green hook there.
0345 for the green hook. Okay.
Jeanette, that thermal cover is closed. I begin my translation out to S0.
Copy, thermal cover closing. Can you do a quick safer check?
Good reminder. Safer handles are down.
And copy, safer handles down. So you're going to head out to the S0 Truss Bay 1, and I have a warning reminder for you as you head out there. Remember to observe a 2-foot keep-out zone from the ungrounded connector P338J338 Alpha, which is located in Bay 1, port nadir of handrail 3463, and also do not use the heat pipes for translation aids inside Bay 1 and Bay 0.
Copy, boss.
Engine I'm at 0345, dropping my green hook.
Copy, green hook on 0345, node 2.
While Saint-Jacques makes his way to install those trunnion slip-off preventers to the Columbus module, McClain is making her way to the S0 truss in Bay 1, where she will finish routing and mating the cables earlier stowed by Saint-Jacques. These are the same Canadarm2 backup power cables.
Okay, Ann, I see you on S0. And David, for you, you're heading out to the starboard. You're heading out starboard to the Columbus end cone, and on the forward side of the end cone, you're looking for handrail 0901.
0901.
And you'll stow the medium or U bag there. And as you're going out there, I have one caution to read to you. The caution is to avoid inadvertent contact with the EHDC that you'll see on the node 2 forward end cone. However, the boom is acceptable for BRT loads.
Copy.
And Jeanette, I have ingressed the truss at S0.
I see that. So you can go ahead and translate to the truss jumper cable. You should see that sort of nadir in the truss, and you're looking for handrail 3451.
Confirm, I see the jumper cable.
And if you like, Ann, you can stow the cap keeper on your swing arm. You can use a rep from the to the cap keeper ring to your mini workstation rep.
Copy.
McClain is now in the Bay 1 section of the S0 truss, which is sort of like the backbone of the International Space Station. While in Bay 1, McClain will route one cable into the next section of the truss, Bay 0, and then she'll later leave this section of the truss, go into Bay 0, and complete the, mate the cable into its final configuration.
And David, for you, once you get to that handrail 0901, you can stow the medium ORU bag on there, and you can also use it for a BRT location, or you can use the boom on the No 2 EWC boom.
Copy, and I am at 0901, the process of dropping the bag.
And we have a suggested body position if you like.
Stand by as I finish with the bag.
Copy.
And Jeanette, now that I'm seeing this connector from the backside, the initial impressions were true. The connector is touching structure.
Copy. The connector is touching structure.
Ethernet, I have the bag stowed on 0901. I am also BRT to 0901.
Copy that.
I'll retrieve the MLI cover.
Copy. So you've read it to the D-ring of the large small adjustable from the ORU bag and released the adjustable from the bag. Is that correct?
Yes, not done that yet.
Okay, copy. And so then you've tethered to the scuff plate MLI with the large hook of the adjustable, and then you can grab the short T-handle tool from the ORU bag to release those 2 quarter-turn fasteners from the scuff plate.
Copy, putting that in work.
David is removing the multi-layer insulation and scuff plate cover so it doesn't get in the way of the robotics whenever they attach Bartolomeo after its arrival to the space station next year. As we mentioned previously, it will be attached to the Columbus module, which is aptly named. Bartolomeo is actually named for Columbus's younger brother, so it's very fitting that it will be attached to the European module Columbus.
And we have one quick question for you. We don't have video of you right now, but can you tell us if the back shell of the ungrounded connector is touching the back shell of any of the other connectors?
Let me turn it back. Hold on. And I just did a GoPro survey of the whole thing from a couple different angles, so hopefully that will be useful.
Yes, that'll be very useful, Ann.
And it is not. And it is not. So there's kind of behind the veil, there is a part that sticks that's like squarish and wider than all the rest. That portion is touching the panel that the other connectors are connected to, but the back shell itself of that connector is not touching anything else. Closest approach looks about half an inch from, I think that's the other side of the P3038 connector.
Okay, copy all, Ann. Those are great words. Thanks.
Ethernet, I have removed the scuff plate MLI. I have routed to the secondary, the tube up.
Copy. And David, please be sure to close the ORU bag to protect the other TSOP.
Okay, we'll close the bag.
Thanks, David.
For that time that the red-blue cable, I believe I'm releasing Art and 7, could you remind me?
So you're correct. You're going to release wire tie start 1 twist. And you are correct. As wire tie 5, you're going to connect it to handrail 3, 4, 5, 2.
Copy.
And just verify that your safety tether is not trapped by the cable or the wire tie.
Sorry, say again?
Verify that your safety tether is not trapped by the cable or the wire tie.
McClain is stowing the red cable being discussed on a nearby handrail for later installation. That won't be during today's spacewalk, but she will continue routing the blue cable into the nearby Bay 0 truss.
Verify that your safety tether is not trapped by the cable or the wire tie.
Copy.
And for you, David, once you install the secondary T-stop, verify that the tether point is pointed zenith, and as you need to, you can lock out your ret to prevent inadvertent removal of the T-stop.
It's done. That is locked. Tether point is zenith.
Copy, and I have PGT settings when you're ready.
These trunnion slip-off preventers that David Saint-Jacques is installing are plugs going onto the end of the trunnions. These will help provide more stability for future payloads attached to the Bartolomeo platform. Saint-Jacques will be installing 2 of these preventers.
Good call, battery 39.4.
Say again, David?
I got a good call, battery 39.4. Ready for settings.
Copy that. Your PGT settings are alpha 1, clockwise 2, and you're going to turn the bolt about 15 turns.
Alpha 1, clockwise 2. 15 turns.
Connect wire tie 5 is connected to 3452. I believe the next I'm releasing 6 and just configuring it low profile.
Is wire tie 6, that's correct, Ann.
As you can see, the space station is now in an orbital sunrise, flying over the South Pacific Ocean, and we have just reached 5 hours into this spacewalk.
Nice, Ann. I see that you've configured wire tie 6 in a low profile. And next you can release wire tie start, and that should separate the red and blue bundles.
Copy and work.
Guys, we have about 30 seconds to a short handover.
Copy.
You can see team members in mission control near the top of your screen. That's Jeanette Epps, NASA astronaut, who is walking the crew step by step through the task today. And right beside her in the blue shirt is astronaut Doug Wheelock. He's also serving as the Capcom for mission control. Near the bottom of the screen is Flight Director Rick Henfling leading the teams in the room today.
David, could you repeat that last call? We were just coming back up with you.
Yes, so 13 turns, green light, 2.5 on the torque. The islet is zenith.
Copy that, David. And David, that was a good torque turns and light. We're going to reconfigure the PGT again to Bravo 4, clockwise 2. And this time you're going to turn the boat 1 to 2 turns.
Bravo 4, clockwise 2, 1 to 2 turns.
And actually, David, we're looking for 16 to 17 total turns, so that would mean you're going to turn the boat about 3 to 4 turns.
I have 13 so far.
Copy, so 3 to 4 turns is what you're looking for.
Copy.
Jeanette, a quick question for you. I believe the procedure, I'm supposed to use wire tie 7 to track down this red cable to 3452. Are you okay if I use wire tie 8 red? Just got a little more slack in it.
Checking. Yes, and you can use that. There's no issues with that.
Okay, thanks.
And Jeanette, I got 19, green light, 19.2 on the torque after only 2 turns, so total 15.
Copy, total of 15 turns.
Jeanette, the red cable is tacked down to 3452.
Copy, 3452, Ann. And for you, David, that's a good config. And if you can verify there's no gap between the T-stop and the trunnion.
I can confirm no gap.
Copy, then you can release your rep from the secondary T-stop.
Copy.
And for you, Ann, you can route the blue bundle through the nadir triangle opening of the base 00, and you're looking for a handrail 3472 on the other side. And you can use an adjustable to temp stow the blue bundle on that handrail.
Copy to understand. And real quick question on wire tie number 6. To release it and put it to low profile. Furthest I can release it without completely releasing it. It has 2 cables inside of it, which kind of holds the blue and the red a little closer together. And just want to make sure that that should be the last one, wire tie 6, that actually connects the 2 bundles.
Checking. Okay, and we concur with that.
Okay, great.
And for you, David, after you've released your rep from the T-stop, you can close and retrieve that ORU bag and stow it on your BRT. And
I'm taking a few photos of the top.
Copy that. I was just about to ask.
You can see from Ann McClain's helmet camera, she is stowing that red cable on a handrail in the Bay 01 truss. Meanwhile, David Saint-Jacques has installed the secondary trunnion slip-off preventer. That's actually the first he has installed. Now he will move on to releasing the scuff plate multi-layer insulation on the near the primary, trunnion slip-off prevention, and then install that primary.
And David, one quick thing, thanks for taking the photos. Since we don't have WVS, those photos will come in handy.
I have a question for you for this area.
Go ahead, Ann.
There's a cable that kind of runs through, it's tacked down a couple places, but kind of runs diagonally through the open space in this bay, which makes it kind of tricky to navigate around in. And there's a wire tie on it that is not connected to anything. I'm wondering if you mind if I tack that down to 3450. It would just kind of keep it out of the way. I don't see an obvious marking on the cable, other than it has wire ties that are marked.
Copy, Ann, checking.
Okay, so Whiskey 0087 is part of it. It looks to be kind of a cable that splits in 5 ways.
Okay, and we understand what you mean about the connector. It's an Ethernet cable, so it can't run alongside of the power cables that you're installing, so you can tack it down, but it should be separate from the power cables.
Okay, 3450, which is the adjacent handrail, has nothing tied to it, and I think if I just tie it back, it'll protect the hardware a little bit more for future travelers through here.
Copy handrail 3450. Copy that.
Yeah, and just for reference, I'm using a wire tie that says S0 handrail 3455, so right, it's been supposed to be attached somewhere.
Copy that, Ann.
All right, and that's attached, and I'm going to go ahead and egress.
Copy, and once you egress, check your safer handles.
Here's a net. I'm at the primary stop location.
Copy that, and you should be looking at handrail 0938. You can stow the medium ORU bag there and BRT to that location.
Copy 0938, I'm there.
And David, one go back, there should be 2 handrails there. You can BRT to the 0938 or 0939.
Okay, I see the options. Go for 0938.
Copy, 0938. And before you enter the S0 bay, just one quick warning reminder that the ungrounded connector is directly on the opposite side of the bulkhead, so don't wrap your hands around the bulkhead close to the connector, and don't translate on any of the existing cables.
Copy, and my safer handles are down.
Copy, safer handles are down. So, Ann, it looks like you know where you're going.
I think I do. I see the cable.
Excellent.
You can see NASA astronaut Ann McClain has egressed the S0 truss, and she's moving to the next portion of the truss, Bay 0, where she will finish mating the blue cable to provide backup power to the Canadarm2.
And Ann, one quick recommendation. We recommend that you go in head first.
Okay, I tried that a few times.
Copy.
There's brackets hanging out from the diagonal. There's a couple of brackets hanging out from the diagonal that are catching.
Copy. And we have an alternate route for you to get into the truss if you like.
Okay, I'll try this again. All right, found the one angle that worked.
Copy, Ann. Good job. We knew you'd find it.
How's it going, David?
Hello. Yep. So, Matt, I have retrieved the plate MRI of the primary top. I have the primary top in my hand, and I'm about to dock it, soft dock it.
Thanks, David, for that report. So you can soft dock that primary T-stop on the trunnion pin and verify there's no gap between the T-stop and the trunnion.
Okay.
And for you, Ann, you're going to translate over to the blue cable bundle on handrail 3472 and retrieve that. I have one quick caution reminder to read to you as well. On the panel Alpha 162, it's near the zenith portion of the S0, so it's a tight space with other connectors and cables in the area, so use caution not to disturb those other connectors. And I see you've retrieved the blue bundle. And if you can assess the worksite access to panel Alpha 160.
And Jeanette, for the primary top, I'm not able to soft dock it. Looking down the trunnion pin, well, does not appear deep enough to do so. After about half an inch of threading, what I see is It looks like a square, a tool interface, about half an inch deep, and that's the end of the well, if you want, on the tip of the tronium.
Copy, David. Stand by. And David, if you copy, you're taking photos. You read my mind, David. We were just about to ask that.
All right, I am at the panel, also 162.
Copy.
I believe I'm actually going to be demating the one side of this connector, is that right?
You're going to demate the Papa 329 from the J329. The J329 is on the panel on the port side, and it's the Zenith connector.
It is on that port side. Okay, I see Papa 329 on whiskey 4145.
Those are good numbers, Ann.
Okay, I understand. Go to demate.
Stand by. Let me check and make sure that you have a go. And Ann, you do have a go to demate.
Mark. Jeanette, in order to get this side loading, can I undo the TA clamp?
Checking. Yes, Ann, you can release the TA clamp.
Copy, thanks.
This is camera footage from McClain's wireless video system.
David, we're talking about the primary T-stop, so stand by.
Yeah, copy. I think I have a reasonable photo. The lighting happens to be pretty good. This.
Copy, David.
McClain is currently in the S0 Truss Bay 00, where she will demate one connector before mating another two. She'll then give mission control the go to power up the 4B channel if everything looks good.
All of a sudden, you are now only faint and only in my right ear.
Copy. Here's a test 1, 2, 3, 4. How do you read that?
I can read you, but faint and only in the right ear. I don't know if it's just my positioning inside the truss.
And the VDC sounds like what I experienced earlier.
And can you check your HAP, and can you tell us whether or not you feel sweat on your head?
Oh, it does not feel wet.
Copy. It could be the moisture into the air cup.
Jeanette, P329 is demated from the Alpha 162 panel.
Copy. And can you give us a check?
I have a good EMI band, no FOD, and good pins.
Copy. No FOD, good pins, and good EMI band. Okay. Next, you can you have a go to remove the caps from the blue cable and stow it on your cap keeper. You should have a plug cap and a jack cap. Okay, David, for you, if you can go ahead and remove the primary T-stop and stow it in the medium RU bag while we talk about it a little bit on the ground, and stand by.
Okay. We need to the MLI back or not yet?
And David, you can keep the MLI in the ORU bag.
Okay. Jeanette, the primary stop back in the middle of your bag, get closed.
Copy that. Stand by. We're still discussing on the ground.
Okay.
Okay, Jeanette, I have the caps removed from both blue connectors.
Copy that, Ann. David, stand by. Okay, for you, Ann, you have a go to mate the P329 alpha to the J329 on the panel.
The Papa 329 Alpha Blue, the Alpha 162 panel.
Good readback. And David, stand by. We'll get Ann going here to mate these, and then we'll want to get some more information from you.
Okay.
Okay, David, in the meantime, if you can think about how you would describe this square feature that you're seeing, and we'll get back to you shortly after we get Ann through the connection of these connectors.
Jeanette, just be advised, I can still only barely hear you out of one ear.
Copy, Ann.
All right, that is connected over center.
Copy, we see over center. And then you can connect the P329 to the J329 alpha on the cable.
Copy, P329, the November 4145 cable. The 329 Alpha from the Whiskey 4193 cable.
Those are good numbers, Ann. And for you, David, can you give us the report of what you're seeing?
Yes, so the center of the trunnion there's a aluminum plate with several holes. Large central hole has threads, maybe down to 3/4 of an inch of thread. And beyond that, there's maybe, I'll go in detail, like a 1/4 inch arrow section that's wider than the threads. And then that narrows down to a square well, about, I want to say, 1/2 inch inside and 1/2 inch in depth. And that is blind. So the primary top pin, the field just bumps at the bottom of that square well before the soft docking features can engage anywhere.
Okay, we copy you, David. Stand by. We're still talking on the ground.
P329 is connected to J329 Alpha of the blue connector over center.
Copy all, over center. Okay, and if you're satisfied with those connections, do we have a go to power up channel 4 Bravo?
Yeah, I'm happy with those connections, and I will work on wire ties.
Copy that.
And so you know, I'm taking a cap keeper onto my MWS, and it has 2 caps and 1 jack plug.
Copy that. We see that. Thanks, Ann. So next, if you you can secure the slack in the cable as needed and verify that your safety tether is not trapped, and then we'll get a WVS survey.
Copy.
And one item, Ann, if you can go back and reconnect that TA clamp that you loosened to get the connector off the panel.
Affirmative.
A live view here of David Saint-Jacques while teams on the ground work to determine what object he's seeing inside the primary trunnion.
David, stand by. We're still talking on the ground.
That TA clamp is close.
We saw that. Excellent work. And as usual.
About 5.5 hours into the spacewalk, Ann McClain has completed routing and installing the backup power cable for the Canadarm2, and she will begin to egress the S0 Bay 0 truss on the space station. On the right side of your screen, David Saint-Jacques is outside the Columbus module, working to install some trunnion slip-off prevention for a future Bartolomeo external payload platform.
Okay, David, we're still talking about things that we can have done shortly. So we're still talking on the ground, so continue to stand by.
Okay.
That wire tie start is on 3469. I'm working on getting another one on.
Copy, 3469.
Confirmed.
And for you, we need more information on that square part. Can you tell if it's a separate part of the trunnion or is it an integrated piece?
Good question. Slightly different color, so it might be a different metal. The insert on the surface of the insert inside the trunnion pin is a particular color, kind of steel-like. That deeper square well at the bottom has a slightly maybe tan tinge to it. It looks to me like a different piece.
Okay, we copy all. Still talking.
Usually metal though.
And David, did you check to see if you could rotate the T-stop since it has 3 pins on the end to try to fit it into the trunnion pin?
Yes, so I tried that, but we don't get anywhere near where the pins would engage, the 3 pins. I get about ½ an inch of clearance there. It is not because of it. That's what I thought first, clocking of the 3 pins, but that's not what it is.
Okay, copy that, David. Good words.
All right, Jeanette, I got the photos of the area, and hopefully in the WVS you should be able to see it right now.
Copy, and we're looking. Okay, Ann, that's a great WVS. You can go ahead and egress the truss. We may have a couple of other things for you to do since David had some issues with the primary T-stop. So you can go ahead and egress the bay and give us a safer check.
Okay, copy. And when I egress, I'll give you another comm check, but I'm still only hearing you faint out of one ear.
Copy. You're still only hearing me out of one. Copy.
And really faint.
And when you egress, if you can check your volume, that may help with the comms issue.
I'm actually going to put the caps in my trash bag right now, so I'll check it right now because I'm going to drop my workstation.
Copy that, Ann.
And Jeanette, do you want me to try putting the top in again? And try to go full circle around it to try all clockings?
Yes, David, go ahead and try that again.
Just don't think, frankly, that the well is overall deep enough. I'll put them side by side in perspective.
Copy, David.
Would be worried if I try to mate it again that somehow the docking feature will latch on the threads and we won't be able to pull it out?
Copy, David.
Just a question. Otherwise, I'm happy to try again.
Okay, David, stand by.
NASA astronaut Anne McClain is wrapping up the final scheduled task on her timeline for today and may have the opportunity to work on some get-aheads. She will egress the truss here and perform a SAFER check. That stands for Simplified Aid for EVA Rescue, an EVA being a spacewalk or extravehicular activity. The SAFER is sort of like a miniature propulsion unit. The astronauts use several tethers to stay connected to the space station, but just in case something were to happen and they became untethered, the SAFER would come in handy to help them relocate back to the International Space Station. It's never been used, only tested, but we know that it works.
And if you can do a SAFER check and a glove and half check.
Yep, and I'm just working on getting out still. And just, you know, I did turn up my volume, so you're still fainter than you should be at this volume in one ear, but louder than you were before.
Okay, copy that. That's good, Ann. So, David, with the primary T-SOP, you have 3 pins, and then you have the center. Can you verify that they're all through holes as you try to install it into the trunnion?
There's not a single through hole there.
So there's not a through hole in the center?
You have one more look before the sun sets. All the holes are blind. The hole for the 3 pins are blind, and the hole for the big center pin is obstructed by that square well that I described earlier.
Okay, copy that, David.
There are 4 through holes that are threaded, like 4 smaller thread holes along the perimeter of the big central hole. 4 of them. Those look to me like they go straight through. Yeah, the insert.
Okay, copy, David. We're still talking on the ground.
I'll stand by the attempting installation.
Copy, David.
Maybe one more piece of information. The 3 holes where the guiding pins would go, although they're not going straight through, they appear to be deep enough to accept the 3 pins. Interference is with the central pin.
Okay, we copy all, David.
I'm out of the truck, did it? Wondered if that was going to happen.
Copy that, Ann. Great job.
I'm checking my safer handles. And stand by for safer handles.
Copy, Ann, and we'll take a glove and hap check when you're done with that.
All right, safer handles are down.
Copy, safer handles are down.
The glove, the only change is on that pointer finger. You can probably see it in my WVS. A lot of that RTV is peeling back.
Copy that, and which glove was that, Ann?
My left glove, left pointer finger.
Copy that, left.
On the left, so at the kind of the crease in the finger, I see some white threads on the tray. So like one layer of the RTV is peeled back, and then the second layer has, you know, looks like eraser wear with white threads through it.
Copy that, Ann.
Skin.
And there's no change in your right?
Change in the right and dry hat. And no change in comm since I got out here either.
Copy
so
that, Ann.
on the one side.
And did you see any cut threads on the left glove?
The left glove has the pointer finger that I just told you about, but other than that, no change.
Okay, copy that, Ann.
I think you should be able to see that in my WVS.
Right now, we don't have a WVS.
And I just pressed the button and got you back a green light.
Copy, and we now have WVS. And stand by, we're tucking on the ground for the next steps.
Copy, and sounded like a broken message that just came up, but I got your last, that you're talking about forward plan.
That's correct, we're talking about the forward plan. Okay, guys, big picture. First, for you, David, we'd like for you to go ahead and clean up the work site and start heading back. And don't forget to pick up your green hook on the Node 2.
Copy. Do you want the MLI back on the scuff?
David, no, you do not have to replace the MLI on the trunnion pin. And for you, Ann, since we have a few minutes, if you are up for it, we can route some of the spider cable to the back to the rat's nest. We don't have to get it completed. We have about probably 15 or so minutes if you want to get started on that.
Hey, I can do that. If the comm gets any worse, I'll let you know. My concern would be if I stop hearing you.
Copy that, Ann, and of course.
At 5 hours and 48 minutes into today's spacewalk, Canadian Space Agency astronaut David Saint-Jacques is cleaning up the work site at the Columbus module after the primary trunnion slip-off preventer was decided not to be installed today. They will later look at some photos that he took of the area and analyze next steps. He'll begin to translate back to the airlock. Meanwhile, NASA astronaut Anne McClain is still outside of the Bay 0 area, and she will begin to work on some get-ahead procedures. She'll be routing the same spider cable that was installed earlier to the Rat's Nest area of the International Space Station. The Rat's Nest is where the S0 Truss, Z1 Truss lab, and Node 1 all meet and connect cables for things like power, ammonia monitoring, and more.
If we can start over. Only thing I got from that was that you had an adjustable on the outside of the bag.
Okay, for the inside, I have two scuff plate MRIs, each on a large, small adjustable. I have a short T-handle on a ret. I have a round scoop on an adjustable feather. I have a socket caddy on a ret. On the socket caddy are two sockets, a 7/16 9-inch rigid and a wobble 6-inch. In front of me I have the primary top on a rack.
Okay, David, that's a good config. You can head back to the airlock, and actually, before you head out, could you give us a glove and hat check?
I'll close the bag and give you that.
And for you, Ann, you're translating back to that lab handrail 0288 where the IDA bag was located.
0288 where the IDA bag was located. Copy it. I just stopped to drop my green hook on face 1 so that David has a clear shot back. And discovered that my safety tether was wrapped around my swing arm, so I was just cleaning that up. And I'm going to drop my green hook. If you're okay with it, it's a stanchion at mile marker 7800.
Copy that, mile marker 7800.
Change the knot. I have a dry hat. No changes on the left glove. No changes on the right glove.
Copy, no changes on the glove and a good hap. And don't forget to pick up your green hook from the Node 2 before you head back to the airlock.
Good reminder. Thanks.
And good news, there's good power connectivity on that cable that you just connected up.
That is great news.
Well done.
As we approach the 6-hour mark in the spacewalk, just a recap of all of the things that the astronauts have accomplished today. We are rounding out the end of the timeline tasks.
Until a certain time or until David gets back.
Stand by checking.
To start the day, the astronauts relocated the adapter plate for a battery from its slot in slot 6 to on top of another adapter plate in slot 2, freeing up that space for nickel hydrogen batteries to be installed robotically later on.
Okay, and we only need about 10 to 15 minutes of the cable routing, however much you can get done in that time.
Okay. Sounds good.
The astronauts also installed a spider cable to route Ethernet to different parts of the space station, which Anne will be revisiting for her next get-ahead steps.
Stand by checking.
As you do come up, I dropped my green hook on phase 1 above the port lab struts.
I see where you are.
Okay.
I'm back on node 2 today.
Copy, you're on node 2.
Following the spider cable installation, the astronauts installed some jumper cables on node 1, and those will provide backup power to the Canadarm2.
David, thanks for the offer, but for the CP13, but today is not needed. We just wanted to get a little bit of a start on the spider cable routing app.
Copy.
So, David, you can head back to the airlock and store that medium or U-bag in the airlock.
Copy. I have retrieved my green hook. All 3 wheels unlocked.
Copy, you picked up your green hook and both wheels are unlocked.
On my way to the airlock.
Copy, David.
And I'm at the spider cable in it.
Excellent, we see that, Ann. So, Ann, the idea here is to start routing the Whiskey 4300 cable back aft. So you're going to go towards the ESP1, and you're going to start at the handrail 0288, and then release wire ties in numerical ascending order as required, and secure wire ties to the nearest handrails. And if you could report the handrails to us.
Okay, I've just released 1 off of 288. Actually, I'm going to release the cable and then check down 1 to 288.
Copy, Ann. And if there's an adjustable on the spider cable, I believe that David put it in the IDA bag, but in case he didn't, you can release that and stow it on your mini workstation.
We've got a view right here of Canadian Space Agency astronaut David Saint-Jacques heading back towards the airlock to wrap up his first spacewalk. Meanwhile, NASA astronaut Anne McClain is routing a spider cable, one that was installed previously under the micrometeoroid orbital debris shield McClain will be routing this cable down the side of the lab, and it will provide Ethernet power to various locations on the International Space Station.
Prioritize space as far aft as possible because there's already a couple cables on there, but the station's kind of clobbered. Can I do a loop of the wire tie around the existing cable that's already wire tied here?
Checking in.
Hold it in place better to keep that handrail free.
I understand what you're saying. Checking.
Okay, thanks.
Okay, and you're going to wire tie all those cables together.
On phase one.
Thanks.
V2 at the top of the fuel store.
Copy, David.
Wire tie 1, 288, moving aft.
Copy that, and that's on handrail 0288, correct?
V2 is at the airlock.
Copy that, David. You can go ahead and temp stow that, or stow the medium ORU back in the airlock. Back in the airlock.
Work.
You can see David Saint-Jacques has made it back to the Quest airlock. He will remain inside the crew portion of the airlock while Anne McClain continues routing that wireless Ethernet cable.
Copy, thermal cover open.
And releasing wire tie 2.
Copy that, Ann.
Wire tie 2 is going to go to 286.
Copy, wire tie to 0286.
Right or your bag is threaded inside the airlock.
Okay, copy that, David. So at this time, if you can egress the airlock, check your safer handles and close the thermal cover, and Ann should be there shortly.
And genetic adjustment to my last, I'm actually going to put this on 285. Wire tie 2 on 285.
Wire tie 2 on 0285, is that correct?
285, is that correct? I'm going to I take that back. It's not going to quite reach. It's going to have to go on 286. Sorry about that.
No worries, copy 286 for wire tie 2.
Engineer, thermal cover is closed.
Copy, David. If you could hang out for a few minutes, and should be done shortly.
on the particular handrail.
Sounds good. Enjoy the view.
And if you can connect one more wire tie, you would go to handrail 0285 and temp stow the bundle there and then head back to the airlock.
I'm good. So I'm going to go one more handrail with a bundle. 85.
Good read back.
While NASA astronaut Anne McClain continues routing the spider cable previously installed earlier, we are just over 6 hours and 4 minutes into today's spacewalk.
Wire tie 3.
Copy that. Wire tie 3 on 0285 and temp stow in the bundle.
She is temporarily stowing the rest of the cable to be routed at a later date.
Unless you want me to disconnect it first.
The crew started out this morning by removing the adapter plate 6 from its location and stacking it on top of adapter plate 2. Later on in the week, the robotics controllers on the ground will maneuver the nickel-hydrogen battery into the now empty slot to complete the configuration and restore that power channel back to full function. The crew then translated to the micrometeoroid orbital debris shield on the lab and removed that to install the spider cable underneath. This cable will provide Ethernet to the space station. Shortly after, they moved over to Node 1, the Unity module. Working on separate sides, they both installed truss jumper cables, and these provide backup power to the Canadarm2. Afterward, Anne McClain moved over to the S0 truss, where she continued routing a cable previously connected by Canadian Space Agency astronaut David Saint-Jacques. She installed that truss jumper cable. Meanwhile, Saint-Jacques was working on the Bartolomeo trunnion slip-off prevention installation. Bartolomeo is an external payload platform that is scheduled to arrive next year. He took some photos of the work site, and the controllers and teams on the ground are going to look at those and determine next steps on how to best install the primary slip-off preventer.
Copy, wire type 3, forward stanchion 0285. Great, Ann, and you can head back to the airlock and pick up your green hook.
And this view here of Canadian Space Agency astronaut David Saint-Jacques, who is back at the airlock and has completed his tasks for the day. Anne McClain is finishing up a little bit of routing that extra spider cable, and she is now heading back to the airlock as well. as NASA astronaut Anne McClain heads back toward the airlock to join David Saint-Jacques. We have another Ask NASA question from Holly, who wants to know if there will be any more spacewalks this year. It's a good question. We are on the third spacewalk of 4, and that's only for this next couple of months. On May 29th, there will be a spacewalk performed by Russian cosmonauts Alexei Yevchenin and Oleg Kononenko.
Okay, David, we see Anne heading back, so you have a go to open the thermal cover and ingress the airlock, and you can attach your waist tether to the airlock D-ring extender and check gate close and hook lock.
Copy, work. And that thermal cover is open.
Copy, thermal cover is open.
Internet, I have my tether to the airlock D-ring extender, gate closed, black on black.
Copy that, David. And when Anne gets there, you can give Anne a go to release your anchor hook.
And I'm coming down the, just right here to David. I'll be there in a sec.
Copy.
Anne McClain has now arrived back to the hatch on the Quest airlock.
Just as a reminder, recall that you connected David's safety tether to the aft D-ring, airlock D-ring. So when you release, be sure to release his and not yours.
Thank you.
When the astronauts are both in the Quest airlock, there will be a series of equipment checks, and the spacewalk clock will stop once the astronauts have closed the hatch and airlock repressurization has begun.
I'm going to... You are locked black and black, correct?
And that was for you, David.
Hello? Yep, can you hear me?
I can hear you very faint.
Yep, you are locked black on black, correct?
So, I have my waist tether to the airlock D-ring extender, gate closed, black on black.
Okay, great. I'm going to release your safety tether, and I'm going to connect it to my left waist tether.
Copy.
Copy all, Anne.
All right, EV2's safety tether is to my left waist tether. I see 2 gates closed, 2 sliders locked, both black on black.
Copy that, Anne. That's a good config. And now you can go ahead and release your anchor hook from the airlock forward external D-ring and stow it on your mini workstation.
that is on my mini workstation. And which side are you on to be?
I am on the forward side.
Right.
Because we were for egress.
Copy. I'm going to take my waste tether off the circumferential handrail.
And we see you ingressing the airlock, and don't forget to grab the thermal cover. We have 30 seconds to a short handover.
Copy.
Right. I need to get my feet down there.
Can leverage against my hand, Joe?
Okay, copy. Thermal cover is closed, and
Cover is closed.
And the Velcro is attached.
We're in a short handover. The lead spacewalk officer for today is John Malarski. He has been overseeing the team and monitoring suit information. He's also walked through the procedures and fed information to the teams on the ground.
And remove your DCM cover and Velcro the cover to the DCM.
Can you say again lastly? I got half of that.
So did you attach the Velcro strap from the thermal cover?
Let me get that. Good reminder. The whole thermal cover just came open. Stand by.
We've got a view on the left of the astronauts closing the thermal hatch cover. And on the right, NASA astronaut Christina Cook waiting in the equipment portion of the Quest airlock. After repressurization, she'll be there to help the astronauts doff their suits.
And remove your DCM cover and Velcro the cover to the DCM. And one quick note is that a TCV setting of 8 max C minimizes the time for SEU cooling.
Yep, copy. Number 8.
See you out of the pouch.
I see you out of the pouch as well for EV1.
Okay, we're now in the crew lock repress cue card. So on your DCMs, you guys have a go to connect your SEUs to the DCM.
In work.
Copy and report locked.
V1, SEU on and locked.
Copy EV1.
EV2 is CU locked.
Copy EV2, SCU lock. Next, take your water switch to off.
V1 water off.
Okay, we start a timer for 2 minutes.
Add a message, water off.
This view from NASA astronaut Anne McClain's helmet. They are inside the crew lock portion of the Quest airlock, and you can see that thermal hatch cover just above that they have closed.
Let's see if you could pull a couple of these things that way, David. Yep. And getting some floaters near up near the hatch, like a PGT and some cabling. Just wondering
Only
if you
about 30 more
see if you
seconds,
can pull
guys.
some stuff. Yeah. Don't want anything bumping the thermal cover again. Thank you.
Okay, Ann and David, the 2 minutes are up. You have a go to check the EV hatch and make it closed and locked.
Copy. And the handle is in the left. With left location. Get my seat down again, thanks. The hatch is closed and locked.
Copy, hatch is closed and locked. For you, David, on the UIA, the oxygen for EMU 1 and 2 valves, 2 of them, take them to open.
Both open. EMU 1, oxygen, EMU 2, oxygen, open.
Hey, Jeanette, I just hit the latch handle and the lock thing popped up. And the latch handle moved counterclockwise. Does that indicate that it is not in a good latch position? I can get unlatched and re-crank it latched if you like.
And can you confirm that the latch handle is in the locked position?
Latch handle is at the 6:30 position on the clock. The decal shows latched. And I gave it as the hatch a good tug, and I relocked it, so I think it's in a good config.
Okay, copy that in. Okay, and that's a good config. And next on the UIA, switch the power for EV1 and EV2, two of them, to on, ON, on.
Power EV1 on. Green LED, EMU on. Power EV2 on. Green LED, EMU2.
Copy to power LEDs for both EMUs are on, and check that the power for EV1 and EV2, the volts are between 18 and 19 volts.
We have 18.6 on both.
Excellent. And last, on your DCM, switch the power to SCU, and you'll get a warning tone.
V1, power SCU. Have a reset message.
Power SCU.
Copy, Ann and David. So with that, I'm going to hand off to Christina and the equipment lock. It was great working with you guys.
And it was great working with you. Thank you to all the teams down there for a third in the series of these EVAs. We know that it's a lot of hard work and a lot of big size of release as soon as this hatch did get closed. And on behalf of Expedition 59, we want to dedicate these last 3 EVAs to the robo teams in the U.S. and in Canada. You guys have been doing 24-hour operations to make all of this possible, and 24-hour operations don't happen without some sacrifices like missed birthdays and other occasions with your family. So it's also for your families. And for another word on that, I'm going to pass it off to David.
Thank you, Anne. I think these weeks of joint operations with robotics and EVA are a glimpse to the future. As we venture further into space, back to the moon and into Mars, we'll be in exploration objectives joining the forces of robotics operations and human operations. And again, a great example in the spirit of international collaboration, teams working together around the globe towards a common goal. Because when we manage to look beyond our differences, we achieve things that seem impossible. That's how we progress. Thanks, everybody.
Wow, those were great words, Ann and David. Thank you so much, and very kind of you for those words. We look forward to seeing you on the ground.
Jeanette, great job.
And David, this is your Expedition 59 crew back with you. We enjoyed your words as well. Thank you both for that. With that, can both take your O2 actuators to press.
EV1 is press.
EV1.
EV2, press.
EV2. You're going to check that the EV hatch MPEV is closed. That's for Ann.
MPEV is closed on the EV hatch.
Copy. And I will be taking the IV hatch equalization valve just off of off. And you can expect an alert tone. We'll start with a very low rate.
Copy.
When the astronauts begin to repressurize the hatch, that will be the airlock. That will mark the end of today's spacewalk.
Between off and norm, please let me know how that rate feels.
Copy.
Comfortable for EV2?
Same for EV1.
And David, repeat your last.
I say the rate is comfortable.
Copy, good rate.
just as a data point, I can still only hear out of the one ear, and now the whole inside of my visor is like moist. It's not fogged because I think I have the anti-fog, but it's definitely wet.
And the calm is EV2, barely audible.
Can you hear me?
Barely.
You both have low comm and moisture in the helmet for EV1 and ground. How did you copy?
And Christina, just to be clear, not a water in the helmet case, just a kind of thin layer of moisture all over the visor, and then still only hearing out of one ear.
Houston copies all.
Copy, and just the moisture and comm in one ear, and so that you know, we have you loud and clear on our end.
Copy.
And Christina, I have you loud and clear, but I have Anne very, very faint.
Copy, you also have faint comm. And Airlock, how did you copy the EV cruise reports?
Airlock Houston, we copied all, Christina. And let's get a HAP check for Ann.
And wheels, my half feels dry.
Copy.
Doesn't feel like there's been any change. There was a noticeable change on moisture inside of my visor in the last, 15 minutes.
Okay, copy. Thanks, Ann.
EV crew, how's that rate? Would you like it increased?
It's a good rate for me. Happy to go a little faster.
Copy one, and David, how do you feel about the rate?
This is comfortable. You can try faster. LFP currently 0.8.
Copy, you have airlock pressure 0.8. We'll crack it a little higher.
Now that repressurization of the airlock has begun, the Spacewalk official time ended at 6 hours and 29 minutes, or exactly 1 p.m. Central Time. That's the first spacewalk for David Saint-Jacques and Ann McClain's second spacewalk.
I wanted you to take a look at David's pigtail, biomid pigtail, when you get to that point. Just kind of check and make sure it's firmly seated.
Copy, and you mean the J1P1 on the Reba?
And Houston, you're barely audible.
Actually, Nick heard you say biomed, so we'll check the biomed pigtail.
Yeah, the pigtail, the biomed.
Copy, wheels. And brake. David, repeat your last.
Goodbye.
And David, repeat your last. Would you like a slower rate?
Comfortable, airlock P 1.2. And
Copy, comfortable rate and airlock pressure 1.2.
And Christina, I can hear you 4 on 5, but I can barely hear the ground.
Okay, that's good data. So copy, you can hear me at full volume, but very low on the ground. And for your essay, if you didn't get the full read on what Wheels just read up, it's just some extra checks that we're going to be doing while we doff your suit.
Copy.
For the EV crew, we're showing about 2 PSI from our end.
Copy, also show 2 PSI.
And how is the rate?
It's fine for me.
Comfortable.
With today's spacewalk totaling 6 hours and 29 minutes, we've got some spacewalk statistics. This being Anne McClain's second spacewalk, she now has a total spacewalk time of 13 hours and 8 minutes. This is David Saint-Jacques' first spacewalk, leaving him with a spacewalk total time of 6 hours and 29 minutes. This is the 216th spacewalk of the assembly and maintenance of the International Space Station. That comes out at 1,354 hours and 53 minutes of total time spent outside the hatch by astronauts. And that equivalates to 56 days, 10 hours, and 53 minutes spent in space. Of the 3 spacewalks these past 2 weeks, which is the 2019 total, they in all lasted 19 hours and 53 minutes.
And if the rate is good for you guys, I'll go ahead and crack it a little bit more.
Sure. Copy. LSP 3.0.
Copy 3.0, and how's the rate?
Good for EV1.
Copy EV1, and David, how's the rate for you?
How's the rate?
EV2 for David.
Can you hear me okay?
How's the rate for you?
Rate comfortable.
Can you hear Christina okay?
And I can barely hear you.
Okay, the rate is good?
Yep, and copy rate is good for EV1 and EV2. As a heads up, when you see 4.0 PSI, you can expect an alert tone. And after that, at 5.0 PSI, I'll be taking the hatch equalization valve off, and we'll do a 2-minute wait and then a leak check on the hatch.
Copy. Copy.
LSP 4.1.
C4.1.
Pressure in the crew lock portion of the Quest airlock now rising. It's 4.88 pounds per square inch at the moment.
And EV crew, copy. We are at 5.0. I'm taking the valve 2 off. You want copy? And David, how copy?
Copy. We have reached 5.0. I have.
Okay, we're now starting a 2-minute wait for the crew lock pressure to stabilize.
Copy. Copy. 2-minute wait.
We have 30 seconds to go on our 2-minute wait, and then we'll be doing a 1-minute leak check.
EV1 copy. Copy.
Starting 1-minute leak check.
Okay. 2 copies.
To recap today's spacewalk and times, it was a 6-hour and 29-minute spacewalk ending at 1 p.m. Central Time, the 216th spacewalk in total in support of space station maintenance and assembly. It was the third spacewalk conducted this year, and those total out at 19 hours and 53 minutes. Of the 216 spacewalks, this totals 1,354 hours and 53 minutes, which equates to 56 days, 10 hours, and 53 minutes. It was the second spacewalk of Anne McClain's career, totaling out at 13 hours and 8 minutes, and the first spacewalk for David Saint-Jacques, leaving him with 6 hours and 29 minutes outside the hatch. Saint-Jacques is the 4th Canadian to walk in space.
So I show us continuing in step 8.
Copy, and EV1 glove heaters are off.
Copy. Glove heaters off for EV1, and David, I know yours were working, but can you please confirm they are in OFF?
Heater OFF, both gloves.
Copy. Please check your gloves for contamination.
EV1, no contamination.
EV2, no contamination.
Copy both. You take your O2 actuators to IV.
In work. EV1, IV.
Copy EV1.
EV2 is IV.
Copy EV2. I'll be taking the IV hatch equalization valve up to norm slowly.
EV1 copy.
Copy.
And how is that rate?
Comfortable for everyone.
Comfortable.
Copy.
LSD 6.0.
Copy 6.0. And for your SA, we're going to just be taking this all the way until we have a DPGT around 0.
And Christina for EV1, just be advised that the little bit of comm that I just had in my right ear just got worse, and now I can kind of barely hear you.
Okay, copy that. You don't have me now either, so we have a low comm volume. I'll speak up. How copy?
I will check my volume.
LSD 7.1.
Again, EV1.
Okay, I have you a little bit now, Christina. Say again your last.
Yep, and I just asked Davi to repeat his last, actually. V2, this is IV. How copy?
Copy, can you hear?
V2, this is Suit IV. How copy?
EV2, copy you very faint, about 1 on 5. How copy?
C, low, and Ann had success turning her volume up for better comm. Are you able to increase your volume?
EV2, I'm at max volume.
See, you're already at max.
Yes.
Speak up.
And Christina, at max volume, I can just barely make you out.
Okay, copy. You're both at max, and you have me about 1 by 5. I will speak up, and we're monitoring you through the window, and we're watching our pressure rise slowly as we expect it to. We'll be listening if anything is uncomfortable for your clearing as we take the pressure up.
One copy.
One copy. LSD 9.1.
Airlock pressure 9.1.
Comfortable.
Copy, comfortable for EV2.
Crew lock pressure continuing to rise, now at 9.6 pounds per square inch. We will wait for that to rise to 14.7 pounds per square inch and level out with the rest of the International Space Station. That's about the same sort of pressurization that we're used to here at sea level on Earth. We're in a satellite handover now, and you're getting a look at the room of flight controllers who have worked through today's mission, worked with the astronauts and on the systems on which they operated today.
We're showing a crew lock pressure of about 12 at this time. How copy?
About 12.
We show 12.12.2.
Copy, you're seeing 12.2.
.0.
Say again for suit IV.
Galaxy 13.1.
See 13.1.
You can see NASA astronauts Christina Cook and Nick Hague, who both performed a spacewalk just over a week ago. They're in the equipment lock portion of the Quest airlock, and they will be the first to welcome the astronauts back in and help them doff their spacewalk suits.
And for the EV crew, if you haven't already, at DPDT is close to 0, you can expect an alert tone.
Copy.
One copy.
Galaxy indicates 14.1.
Copy, 14.1. And we're showing equalized with stack pressure out here.
And David, we're going to open up the hatch.
Copy.
Mechanism is clear.
And as you can see, the hatch between the crew lock and the equipment lock of the Quest airlock is now open.
Okay, and David, we're going to come in and we're going to get your tools off of you in there and then bring you out, and we'll doff your safers while the ground deconfigures the comm to take you off hot mic.
Copy.
Copy.
Canadian Space Agency astronaut David Saint-Jacques is the first back in the equipment lock. Haig and Cook will help remove the simplified aid for EVA rescue, or that safer backpack. You can see Canadian Space Agency astronaut David Saint-Jacques after completing his first spacewalk. NASA astronaut Anne McClain now being brought into the equipment lock of the crew lock to join Saint-Jacques. You can see Nick Haig helping remove that safer unit.
Airlock Houston on Space Ground 1 for Christina or Nick.
Go ahead, Wheels.
And Christina, thanks. Really nice work with you and Nick. And the crew is no longer hot mic, which is a good thing. Also, before we get started in the post EVA, we sent a new message up, message 147. We'd like you to retrieve that when you're able, just to take a look at it. The first delta is in step 25, but we want you to have those deltas in front of you before you continue in the procedure.
Copy, I have that. We'll take a look. And we are currently doing mic boom position photos.
Perfect, thank you.
NASA astronauts Nick Hague and Christina Cook are working in the equipment portion of the Quest airlock to help Canadian Space Agency astronaut David Saint-Jacques and NASA's Anne McClain remove their EMU suits. That stands for Extravehicular Mobility Unit. The next thing to be removed from the suits after the safer, which we previously saw, are the gloves on each astronaut. There are actually more than 65 different sizes of gloves so that each astronaut can ensure that they have the best fit. Following glove removal, we will see the astronauts take off their helmets, which will also wrap up our live coverage for the day.
Houston airlock after step 25. We had a good pull test on that connection in step 26.
Okay, we copy. Thanks, Nick.
As you can see, both astronauts are now back inside the International Space Station, inside the crew or the equipment lock portion of the Quest airlock. You can see NASA astronaut Anne McClain on the right. Her gloves are being removed by Nick Hague. And to your left is Canadian Space Agency astronaut David Saint-Jacques. Christina looks like she is working on something on the back of his helmet. These astronauts just completed their 6-hour and 29-minute spacewalk, working on some of the battery systems on the International Space Station, moving an adapter plate. They also installed some cables to upgrade Ethernet on the space station, along with provide backup power to the space station's robotic arm. Saint-Jacques also worked to install a trunnion slip-off preventer on the Columbus module that is in preparation for the arrival of the Bartolomeo external payload platform, hopefully sometime next year. After repressurization of the crew lock, which you can see in the back of this picture, the astronauts were moved here and the doffing process of their spacesuits begun. The astronauts are stowing the gloves in the extravehicular mobility unit equipment bag. Following that, they'll work to begin to take off the helmets. As you can see, the astronauts' helmets have been removed. Today, the astronauts, both NASA's Anne McClain and Canada's David Saint-Jacques, went outside of the International Space Station to continue some work on the P4 battery relocation of an adapter pallet. After moving that adapter pallet from one slot and storing it on another, robotics teams will later this week reinstall some nickel hydrogen batteries into that empty slot. The astronauts then moved to install a spider cable under the lab MMOD, that's Micrometeoroid Orbital Debris Shield. That spider cable has been routed to different parts on the International Space Station to provide Ethernet connectivity. Additionally, the astronauts split up just a little bit, but still on the same module when they worked on the Node 1 Unity module to install some Truss Jumper cables. These will provide backup power to the Canadarm2 in case of necessary use. Afterward, NASA astronaut Anne McClain moved to the S0 truss to continue installation of a jumper cable installed by David Saint-Jacques. This cable also provides that backup power to the Canadarm2. Meanwhile, Saint-Jacques was working on the European Columbus module to install some trunnion slip-off preventers in preparation for the arrival of the Bartolomeo external payload platform. McClain worked a little bit into some get-aheads to continue routing that spider cable down the lab of the space station. And the astronauts both ingressed after a 6-hour and 29-minute spacewalk when the crew airlock began to repressurize. To go over those numbers again, our final statistics. Today was the 216th spacewalk completed at the International Space Station in support of assembly and maintenance. It was the third spacewalk at the station just this year alone, and really just in the last few weeks. Today was Anne McClain's second spacewalk after completing her first with NASA astronaut Nick Hague in March. That gives her 13 hours and 8 minutes of spacewalk time. And it was the first spacewalk of David Saint-Jacques' career. That gives him 6 hours and 29 minutes of time outside the hatch.
Perspiration and embeds were moist.
Of the 216 spacewalks conducted at the International Space Station, that gives you 1,354 hours and 53 minutes of total spacewalking time, which is equal to 56 days, 10 hours, and 53 minutes of time outside. Thanks for joining us for our live coverage of today's spacewalk. We do have another scheduled coming up in May, on May 29th. That'll be Russian cosmonaut Alexei Ovchinin and Oleg Kononenko. Thanks again for joining us, and have a great week. That wraps us up, and we'll sign off for today. This is Mission Control, Houston.
you.